Hi everyone, welcome to your first part of basics in JavaScript. Let's start where we can start at the bottom, and that is basically what the hell JavaScript is anyway. So JavaScript is basically a programming language, just like any other language. It says that it is an object-oriented computer programming language. What JavaScript basically allows you to do is add interactivity to your web pages. Now, this was a definition which people used to tell other people back in 2007 and 8. But now, at 2018, in 2018 and 2019, JavaScript is the game changer. It allows you to spin off servers, it allows you to create desktop application, it allows you to create mobile application, it allows you to basically write code in WebAssembly, which runs on your metal, on your direct metal as close as it can, just like assembly, and so on and so forth. So there are a hell lot of benefits to learn JavaScript, and we're gonna start off this playlist with basics, ultimate basics of JavaScript, and we're gonna proceed to a medium difficulty playlist, and then we would finally proceed to advanced playlist. If you're someone who has never used JavaScript before, I would really recommend you to just watch along this playlist completely and to get familiar with it. So that's all for this video, and I'll see you then in the next one. Hey everyone, welcome to part 2 of JavaScript basics. Let's take a look at text editors which we can use to actually write our JavaScript code. JavaScript code can be written normally in a normal text editor as well. You don't need sophisticated softwares called integrated development environments, IDEs. For that, you don't need to download those gigabytes of softwares. Don't worry about that. Just a normal text editor would work really fine. And nowadays we have very well documented and basically very well coded with awesome UIs text editors available at our fingertips. So the top 3 text editors I recommend are VS Code, Sublime Text, and Notepad++. I started off my journey with Notepad++, but remember at that time there was no VS Code. Had there been a VS Code, I would have most probably started with it. Then I moved to Sublime Text, which still remains one of my favorite text editors, but VS Code is the game changer. So I'm using VS Code literally for almost everything now. I occasionally use Sublime Text to and fro sometimes, but we're going to continue the series in VS Code. So if you want to stick along with me, I would preferably recommend you to go with VS Code. Otherwise, you might have to like Google some stuff on by yourself if you're not able to figure it out. Other than that, any text editor is fine. Whatever you use is completely fine. Even Notepad is also fine, but obviously I don't recommend that. So I guess, yeah, that's basic intro to text editors you have on the internet, and that's all for this one, and I'll see you then in the next video. Hey everyone, welcome to your third JavaScript basics tutorial, in which we're going to take a look at how to set up our environment so that we can properly start working with JavaScript code. So what I want you to do is basically download VS Code, as I said in the last video. And once you have done that, you would be presented to the screen like this. Now go ahead and whatever you're using, Windows, Mac, or Linux, go ahead and create a folder named anything you like, and just click on this link, open folder. You should be able to see a page like this when you launch VS Code for the first time. If you don't see this link, then go to File, Open, and then open that particular folder. Right? Once you've done that, you should be able to see the name of that particular folder here. For example, I've opened JavaScript Basics, so it shows me JavaScript Basics. Feel free to pause this video at times so that you don't get lost. Right, once that's done, I want you to quickly go to this tab here, click on this, and search for something called as Live Server. Just go ahead and search that. Once you do that, you should see this entry by Ritwik Day. You should be able to see an install button here. I don't see it because I already have installed that. Just go ahead and install it. Once you do that, you should be able to verify that if you have installed by, you would see these 2 particular buttons here. Other than that, you should see install here. Just go ahead and install it. Now what this does, basically in layman's terms, is allow you to run your own local development server. Right, so you see these sites like Google, Facebook hosted everywhere. right? So these websites, these companies have some servers online which they expose. However, if you want to just test out things, you can make your own computer a server, so you don't have to pay for hosting a server, right? So this is essentially what this live server plugin would do. Once you have done that, you would see no change whatsoever in your text editor, but just go ahead and create an index.html file, and inside here just write a basic document, HTML document, right? And I expect a little bit from you guys that you know HTML a little bit, right? I'm not gonna expect a lot, but still a little HTML doesn't hurt, right? So this is a very basic syntax. We can just write a title here, hello world, stuff like that, and you're good to go, right? So at this point, we are basically ready for deployment. And what you can do is basically right click on this index.html file and click on this open with live server and click on this. Once you do that, you should see that your URL which is opened is 127.0.0.1 colon 5500 and index.html, which says you hello world in the title. So essentially this is the exact same file which is served at this weird URL. If you have never seen this before, don't worry about that, we'll come to that later on, right? So that's all for the setup environment, development environment setup. And if you have any doubts, leave a comment. So I'll see you then in the next video. Hey everyone, welcome to your fourth Basics of JavaScript tutorial, in which we're going to discuss how you can get started with JavaScript. So essentially what happens is that when you want the browser to tell that, hey, this is not a piece of regular text, this is actually JavaScript. So you have to include it somehow. And how you do that is basically by writing an opening and closing script tag. And whatever you type inside this is not really handled as a text. It is actually handled as a script. That means that browser will not render it as regular HTML. Just like, for example, if you write my name is Mehul and you write my name is Mehul. Now both of these texts are same. However, if you save it, you would pretty much see that on reloading it, you would see that it is my name is Mehul, right? But this does not print out on the screen because browser does not know what to do with it. It expects you to write valid code inside these two script tags, right? This is one way. Another way is to basically create another script file. So how you do that is basically by script src, the name of your file. Let's say it is myscript.js, right? And you can go ahead and create myscript.js file here, right? And now it would act as if you are writing this whole code, whatever goes in here, inside two script tags, right? So it is similar. See how I did not say it is same, because it is not. There are obvious differences between including script tag like this and writing it directly in the document, but we won't get into that detail. More or less, you can think that it is same, right? So yeah, that is basically how you would include your JavaScript file inside of your HTML document, and I'll see you then in the next video. Hey everyone, welcome to your fifth JavaScript basics tutorial, in which we're going to take a look at how to create variables in JavaScript, and essentially what variables are anyway. So variables you can think of not only in JavaScript but in any programming language is a way to store a particular value, right? Now this value could be a string, it could be a number, it could be a boolean, and you can think of it like it could be a particular object, it could be a particular data structure as well, so as to say. So let's see how we can create variables in JavaScript. Now you have basically three ways to create it. You have to, when you want to create a variable, make use of either let or var or const, right? And you create comments with this double slash. So I'm gonna just write it here. So we're gonna say let my name is Mehul, right? I'm gonna say var, let's say I like It's something like that, right? And let's say I say const pi is 3.141, right? So what you see here is that I've created my name with let, I like with var and const, and pi with const. So these are on, obviously you need semicolon. You do not really need semicolon there. We're going to come to that later on, but for now let's just keep semicolons there. So, and then with semicolons, and that is basically a way to create variable. Now my name holds mayhole, I like holds pizza, and pi holds 3.141, right? So we're going to take a look at some data types in the next video and see maybe see differences between these as well first. So that's all for this one. I'll see you then in the next video. Hey everyone, welcome to 6th JavaScript basics tutorial, in which I'm going to show you the difference between let, var and const. For the time being, please consider let and var as same, although they are not. They have a lot of differences, but we need to get to quite some decent understanding of JavaScript first before I can actually explain you the difference and you might be able to appreciate it, right? So anyway, I'm just going to explain you the difference between let and const and var and const. So const, as the name suggests, you cannot define it again, right? If you do it, let's say pi is 3.4, it's an error, right? However, you can define my name as something else. This is perfectly fine, right? And I like something else too, right? So this is perfectly fine. So in a nutshell, const cannot be redefined, let and var can be. So that's all for this video, and if you have any questions, please leave a comment. I'll see you then in the next video. Hey everyone, welcome to 7th JavaScript basics tutorial, in which I'm going to take a look at various data types in JavaScript. Let's start with the basics. String, as we've already seen in the last video. This is a normal string. We also have numbers. This is 42 and don't forget it. Let boolean is boolean could be either true or either false, right? And with numbers, you can have integers, you can have doubles or floats, whatever you want to call them. It's no compulsory to write F or D or anything here. If you're coming from any other language, just go ahead and simply write your number. Booleans can be true or false, right? What else do we have? We can have something known as arrays. So arrays is basically nothing but just a bunch of collection of some data types. So you can have 1, 2, 3, 4, 5, A, B, C in here, right? We have an undefined value, undefined, right? We have something known as a null value, null. We have a lot of stuff, right? I will not be able to discuss all of this here, but we're gonna come to that eventually. So we have all this stuff. We finally have something known as objects, which is interesting, and you would be using this all the time. So object is basically a way to store key value pairs in JavaScript. So my key name, rather be in quotes, my key name goes with my value, right? Now you need not to have quotes around the key name if your key name is a valid key name. That is just like, does not include dashes or spaces or anything like that. Does not start with numbers and stuff like that. However, if you want to name your key anything, you have to enclose them in quotes. Now you're free to use dashes or spaces or anything, right? You're free to do that. All right. Now, how do we access these data types? Well, string, as you know, can be accessed by just using the variable name. Number, just using the variable name. Boolean, true. Now for arrays, what you want is, let's say you want to get number 4. Now how would you access that? Well, you would write the name of the variable, that is array, and inside these square brackets right here, you're going to write the index of number 4. Remember, in arrays, the indexes start from 0. So index of 0 is 1, index of 1 is 2, index of 2 is 3, index of 3 is 4. So we're going to write 3 here, which would eventually give us 4, right? Array of 5 would give us A, right? And so on and so forth. We're going to access undefined one just like that. I'm not going to write it. Null as just like that. Just ignore these 3 for now. We're going to come to that later on in the series. To access object, obviously just like arrays, you're going to write object, and inside the square brackets you're going to write the name of your key. In this case it's key name. Now if you have spaces, you can include space here and stuff like that. However, if you want to just write key name, you can now access your key with the object dot key name instead as well. But if you include any dash or space or anything, you have to enclose this in quotes, and you have to enclose this inside the square brackets as well. Now this is actually same as object key name, right? This is just a cleaner way to access it. Object.keyname is same as object square brackets key name. This is just a clear way, right? And obviously if you have spaces, you do not have any option. You have to use this way. So this was a basic intro to data types in JavaScript, and I'll see you then in the next video. Hey everyone, welcome to 8th JavaScript basics tutorial, in which we're going to discuss what functions are in JavaScript. So basically what function is anyway is just a way to execute a bunch of lines multiple times. For example, let's just take a very ugly basic example. Let's say that you want to write on Blackboard, I'm sorry, 100 times, right? So instead what you do is you write a function named A, let's say, which says I am sorry, right? And you then use this function 100 times. So you just have to write A's 100 times instead of I'm sorry, right? So this is more or less what functions do for you. So coming to actual use, how to use them in JavaScript, it's pretty simple. Just write keyword function followed by the name you want to give it to your function. Let's just say my awesome function. Curly brackets, which indicates that now we're going to get to that in a moment, right? Then you have curly braces, and inside this all of your code. Now what happens is that if I call this function here, and how do I call it? Just like copying pasting this whole thing, right? So this is calling this function. When you write 2 parentheses in front of it, this is calling a function. If I call this function twice, this code would be executed twice, right? So this is a way to actually use functions in JavaScript. A very basic introduction. Again, we're going to cover this more in depth in the later videos. So I'll see you then in the next video. Hey everyone, welcome to 9th Basics of JavaScript tutorial, in which we're going to cover something different from functions, and I just want to take your attention towards consoles, right? Console is basically, if you're coming from another language, is just a place where your output is visible. In JavaScript also we have consoles, right? So we discussed in data types tutorial that objects store data in key value pairs. So how do you make use of this console in JavaScript? Well, you do console, which is your object dot log, and then this is a function just like we called, right? Now whatever you write inside these curly braces would be logged somewhere on the console. So I'm going to say ABCD, let's say. And obviously you need semicolons there, just put them for the time being. Hit save, and now if you right click on your browser window, click on this inspect here, go to console, you should see you have, oops, just let me resize this a little, ABCD logged here twice. And now the reason for this twice means 2 times, right? So now the reason for this is basically I'm calling this function 2 times. If I call this 1 time, hit save, you see we get ABCD just once. Right, so this is a way to actually use console log to log our statements. And I can call this function, let's say, this many times, and if we reload, you see this function is called this many times, right? So this is a way to actually use console log statements. So that's all for this one, and I'll see you then in the next video. Hey everyone, welcome to Basics of JavaScript tutorial 10, in which we're going to discuss function parameters. Now what that basically means is just like we are passing an argument here, which gets logged to our console, this is basically called an argument, right? So I can create my own function, my awesome function, and I can pass ABCD in here. But what happens now? How does this know that I'm passing an ABCD? Well, for it to know, what you have to do is create a variable here. Let's say this is my string, and notice I'm not using let here, right? You don't have to use let here, you just have to pass it directly. So ABCD gets copied into my string, and now instead of console logging it like this, I can console log my string and I can change it to EFGH and hit save. So you can see that we get ABCDEFGH now. Now I can change this in the next function call to 1, 2, 3, 4, 5, hit save, and we get 1, 2, 3, 4, 5, right? We do not need these quotes for numbers, obviously. Hit save, and we get it as a number. You can see numbers have a different color in console. So that's to help you, right? So these are called function parameters. What if I want to receive another input? Let's say 1, right? I'm gonna say my string 2 here. Now this could be anything, right? You can name this anything. Now if I want to do it again, I'm gonna console log my string 2, hit save, and actually let me just comment this out for the moment, hit save, and we get ABCDEFGH and 1, right? Now let's say I want to just call this with 1, 2, 3, 4, 5. What happens now? What should be the output? Well, we're not passing in my string 2, so it should be, well, undefined, right? So if I save it, you see we get 1, ABCDEFGH, 1, 1, 2, 3, 4, 5, and undefined, because in the first call we have this logged as ABCDEFGH, then 1, then 1, 2, 3, 4, 5, and then this is nothing, right? We are not passing it, so it logs undefined. Well, let's say I don't want this undefined. I want, if I'm not passing this, to hold the value of 0. So I'm gonna place it a default value of 0. Hit save, and now you can see that we get ABCDEFGH 1, 1, 2, 3, 4, 5, 0. However, if I wish to pass my custom value here and hit save, you would see that I get my custom value now. So I do not get this default value of 0, but now I get a custom value which I passed. So if you want to set a default value to a parameter, you do it like this, right? However, if you just want to set a custom value, you can just pass it regularly like this. So this was a very quick introduction on function parameters in JavaScript, and that would be all for this video, and I'll see you then in the next one. Hey everyone, welcome to video 11 of Basic JavaScript, in which we're going to take a look at what return is in a function and how to work with it. So far what we have seen is that we can pass values in functions through something known as parameters and basically access them or set default values to them as well. Now what happens is that sometimes you want a function to do some stuff and then return you a value. So on the basis of that value, you can decide whether the function worked successfully or there was some error or something like that. So what you make use of is of a return keyword, right? Once you write return and write something in front of it, anything which is below this return would not run. For example, let's say I say my awesome function right here returns me 100, right? And what I do is that I get rid of both of these calls, and instead I say let my result is my awesome function see how am I assigning my result to whatever value this my awesome function would return me, right? So I'm going to say ABC, DEF, right? So what happens is that I'm calling this function would execute, and whatever this function would return would get stored into my result. Now, what I can do is obviously go ahead and say console log my result and hit save, right? So you would see that we get 100. However, we do not get console logged ABC and DEF. Why is that? Well, I told you anything below this return statement would not run. If I comment out this return statement, hit save, you would see I get ABC, DEF, and undefined. Now, why is this undefined? When you run a function and you do not return anything from it, JavaScript automatically places this return undefined statement from it, right? So if you do not return anything, that function would automatically return undefined, right? Now you can basically return anything from JavaScript in a JavaScript function, right? I showed you can return numbers. However, it need not be a number. It could be a string. See, it could be a string. It could be a Boolean. It could be an object with a key value pair. You see, we get a nice little object with key value. Just ignore this underscore proto for now. We're going to come to that later on. But for now, just focus that we have a key value pair. Basically, you can return another function itself. Now, how would you do that? Well, you can create a function here itself. And we have not talked about anonymous functions, but just remember that this function is kind of a function which does not have any name, hence anonymous, right? So I can say this returns me a function which just says console log of, hey, I am a function, right? Hit save. You see, we get a function instead. So now my result is not actually a result, it is itself a function. So if I execute my result and hit save, you see that we get, hey, I'm a function. And we also get undefined because this is not returning anything, right? So that was, I guess, what we want to basically know about returns in JavaScript at this stage, but there's a lot more complicated and interesting stuff as well. But for now, mostly you would be dealing with numbers, strings, and maybe objects, but not for sure functions, right? That's something you would not really need soon enough, right? So yeah, I guess that's all for this video, and I'll see you then in the next one. Hey everyone, welcome to your 12th JavaScript video, Basics of JavaScript, in which we're going to take a look at very interesting, however, very important at the same time, and that is known as scoping in JavaScript. So scoping basically just means how long your variable lives. So I'm going to get rid of this code, and I'm going to start from the scratch and say var my variable is 100, right? And what I'm going to do next is I'm going to say var my age is, let's say, 20, right? I'm going to say if my age is equal to 20, I'm going to say var I want is pizza, right? And I'm going to console log all the variables. My variable, I'm going to console log my age and my pizza, my age and what I want. Hit save, and you can see I get 100, 20, and pizza. Now let's just take a look at what's happening here. Now my variable and my age are at the top of the file and are accessible by this whole file. So they are called as global scoped, right? Now what happens is that in JavaScript, whenever you use var, there's no such thing as block scoped. And by block, I mean whatever you write inside these two curly braces, right? So this includes statements which start with statements like if, and we're going to come to conditionals later on, but for now just bear with me for the scoping part. If, else, let's say not really functions, it could be like a switch case, something like that, right? So this is considered as a block of statement. A for loop can also be considered as a block of statement. So when you write this, what does JavaScript look this as? So what JavaScript does is it takes this var I want, takes it to the top, places it here, and does something like I want. Now this is something advanced. This is known as hoisting in JavaScript, but I'm not going to explain you that. I just want you to visualize that we have written something like this. What JavaScript would do eventually is take the declaration of this variable outside the block and just replace it with the initialization. So what that means is, if you think about it, if you console log I want here and obviously remove this, it should console log undefined, right? However, if I remove this declaration for, I just remove everything, then I get an error that this is not defined. So this clearly means when I do this line, what is happening is JavaScript is taking this declaration, placing it above everything, removing this var keyword, and just replacing it with initialization. That is the reason we get undefined, because at this point, it has just been declared, right? It has not been initialized. So this is the reason we get undefined. However, if you try to access something which is neither declared nor initialized, then JavaScript will throw an error. So this was a kind of very brief intro to hoisting in JavaScript as well, but don't worry about that. We're going to come to that later on. What I want you to understand is when you write var inside these blocks, JavaScript treats them like this. Now, what if you don't want JavaScript to treat it like that? What if you do want to have a block scope in JavaScript? That is, a variable created inside this block lives only inside this block. Right now you can see that it lives outside this block as well. So to do that, what you have to do is, instead of making use of var keyword here, which obviously produces undefined because it is also accessible outside the block, you're going to make use of let, right? And hit save. Now you will see that we get I want is not defined. Even if I remove the statement and hit save, we still get this error with this line, right? And you can see that VS Code's syntax highlighting also shows that I want is declared, but its value is never read. However, if you try var, it does not throw up any errors because it knows that we are using it here. So when you use let, it is block scoped. That means anything that comes inside these curly braces is basically where it would live forever, right? Now, if you want to make it accessible in the global scope, you have to manually declare it outside. Once you do that, you can replace it just like this, hit save, and you're good to go. However, again, if you replace I want with something else, let's just say burger here, and if you console.log I want here, you're gonna get burger, right? And obviously you don't get anything because it is undefined. So we get burger 120 pizza. So why is that? Because our global scoped I want is pizza. We get to this if call. When we are at this line, I want is replaced by burger. Now it's not really replaced, it's just that you have overridden global variables place inside this block scope. So whenever you refer to I want inside this block scope, it would be referred by burger, right, instead of pizza. And that is because you have made use of let. If you remove this let, hit save, then you are actually directly modifying your global variable. See, if I replace this let with nothing, I get burger at both the ends. So you need let to create a specific local variable, a specific block level variable, right? If this comes out confusing to you, if you're confused, don't worry, watch this video again. It's gonna make sense, and obviously try it out on your own to understand stuff, right? You will obviously be having challenges after this video if you're watching this on codedam.com, so that's not a problem. If you're watching this on YouTube, well, I recommend watching it on codedam so that you can eventually learn with the quizzes, tasks, challenges, articles, stuff like that at, while you're watching the videos. So that's a plus point. Anyway, so this was a difference between global variables and block scoped variables. Now, it's not like that you can basically access var almost everywhere. Var are basically function scoped. So I have function, my variable, my function, let's just say, and I say var a is equal to 100. I cannot access this a variable right here, even if I call my function. See, we get an error. However, if this is just a normal block, if I save this, and if I obviously remove this, you see we get 100 because, well, you can literally create a block like this anytime, right? It does not matter. So this creates a block. Obviously, you can have some if statement in front of it, but it does not really matter, right? So, however, this is again not the case with let. See, you're gonna get this error. And let me just plug in my charger here real quick. All right, so now let's just create a function just like we were doing. And you can see that if I call this function, I cannot access a outside this function, right? So var, when you create variables with var, they are function scoped instead of block scoped. And when you create variables with let, they are obviously block scoped. And block scoped essentially means that they're function scoped as well, right? So that goes without saying. And what about const? Well, const is just like let, but it's a constant variable. That means you cannot change its value. So you cannot down the line modify here. Like you cannot do this. It would throw an error, right? Other than that, const is just like let. So this was a very quick tutorial on scoping in JavaScript. And this was a very basic tutorial indeed, because we have not covered a lot of interesting edge cases and side cases of scoping in JavaScript, which I do not really intend to cover at this moment, at this particular moment as well, because it's gonna eventually confuse you. So we're gonna come to that later on inside our intermediate or advanced JavaScript playlist. But for now, I guess that much is enough. So that's all for this video, and I'll see you then in the next one. Hi everyone, welcome to your 13th JavaScript basic video, in which we're gonna take a step back from all those difficult aspects of scoping and stuff and take a look at something known as alert, prompt, confirm, stuff like that in JavaScript. So what happens is basically these are not really technically, I should say, a part of JavaScript, but are more of like a utility function provided by the browser itself. The JavaScript, by JavaScript, what I say, it's not really a part of the JavaScript engine, which something you can say which kind of powers your JavaScript, which interprets your JavaScript. So Chrome uses V8 as its engine. So alert, prompt, confirm, and basically these dialog boxes are not really implementation of JavaScript itself, but browsers provide those implementation. So let's really take a quick look at what they are. So I'm going to say alert, hello, hit save. You can see when the script executes, we get this nice little hello alert from our web page, which is basically that's all about, right? So just use this function hello alert and pass in a message, which is a string or a number, could be anything. If you pass in an object, it would kind of not really display in a very nice way. You can see if I pass in an object, okay, if I save this, you see we get this object. So things kind of break down. You can think of it right now. I'm gonna come to that later on, why is it like that. But for now, what happens is that you can pass in numbers, strings, and pretty much it would work just like you expect it to. When you pass in objects or anything else, functions, stuff like that, everything is valid in JavaScript, right? When you pass stuff like that, it will not really be very appealing, right? You can see numbers also work fine. The next thing is basically confirm. Confirm is kind of a dialog box which you can use to ask user if they really want to perform this particular action. For example, deleting something, deleting a photo or a contact or anything, right? So you can say, are you sure you want to delete this? And hit save. And you can see the browser renders it like cancel and OK if I press an OK. Well, what's the benefit of this? Well, as I told you, that functions can actually return values using the return keyword. So we can actually get the result from this confirm box. And I can console log this result. Hit save. And let's say if I said OK, you can see we get true here. And obviously I want you guys to put semicolons here, right? OK, we get true. I press cancel, we get false. So now we can accordingly make decision. If result was true, then we want to perform this action. Otherwise, well, don't perform this, just cancel it. On a similar manner, we have something known as prompt, which provides actually a text field for the user to enter some text, right? Cancel, we get null, which is basically no value. As I told you, the difference between null and undefined for now you can think of is basically null has to be explicitly set to a variable. So you know that yes, that variable does not really have any value. Whereas undefined is basically an uninitialized variable, right? Which does not have any value. So if I change this to what's your name? What is your name? Hit save. And I enter Mehul here, hit enter, you see we get Mehul in console log because that's what we got back from the browser. So this was a quick video on alert, prompt, and confirm. People usually use alert, usually used confirm, but I don't really think people use a lot of prompt. Prompt is kind of used mostly in places where you do not really want to focus on a lot of UI, you just want things to go smoothly and go fast. Basically all three of them. So yeah, essentially it's good to know about them in the beginning stages, but eventually you might not really need them a lot of times. So play around, have fun with these three alert, prompt, and confirm dialog boxes. And that's all for this video. I'll see you then in the next one. Hey everyone, welcome to 14th basic JavaScript video, in which we're going to cover objects in a little bit more detail, not too much, but a little bit. So we have taken a look at what objects are. So if I define an object like this with two curly braces, I can have a key name here with value 1. Let's say I have key name 2 with value 2, and so on and so forth. Now if I want to access any of them, I can either do key name like this, or I can do object key name 2 like that, right? And you can see it basically works the same way. So what happens, let's say if I want to modify one of the value. So what I'm gonna do is I'm gonna write here favorite snack, for example, and let's just write pizza here, hit save, and we obviously get undefined because that's not really set. We get pizza here, right? Now let's say I want to change this. So just like we are accessing it with object.theKeyName, we can also set it. So I can say burger here again, which would eventually change this. So if I console log it again, you can see we get pizza first and burger next, right? What if I want to just console log this object as a whole? Object, that's it. So you can see we get this nice little display which says favorite snack is burger and stuff like that. Let's create another object. We're going to say let person is name, Mehul, channel, codedam, website, codedam.com, and let's say we add some field like is HTML a programming language? True, right? For instance, let's just say. and I'm going to console log this person. So now you can see we get a lot of fields like name, channel, HTML, and website. And basically what this means is that obviously it does not mean really anything. We just got a console log of this statement. So what if I want to, let's say, remove this value from here? How do we do that? Well, one way is to do person.isHTML is undefined, hit save, and I console log this one more time. But now you can see instead of that value getting removed, we are actually getting the key as it is, but the value as undefined. So you can see we do not have is HTML a programming language here, but we do have it here with a value of undefined. But that's not what we want. We just want it to be removed. So how do we do that? Well, instead of setting it to undefined, what you can make use of is the delete operator. Now this is an operator which actually deletes that particular key from that particular object. So we're going to say person.isHTML programming language. Hit save. Now you can see that the difference between these two objects is that is HTML programming language true exists here, but it does not really exist here, right? So this is basically how you would delete a key from an object, and obviously you can set it to null or undefined as well, as long as it does not really bother you or your program. But that's essentially how we would do that, right? So this was a little bit basic manipulation with objects, and just before finishing this video, I just want you to introduce to a quick little concept, not really a concept, but just update what happens if you use, instead of let, if you use const here, right? So we can just get rid of all of this, hit save. Now you should, as a user, expect that person.name is something else should throw an error technically, because it is a constant, its value cannot be changed, right? However, you would see that the value actually gets changed and there's no error thrown. Why is that? Well, you see, when in JavaScript you make use of const with objects, what happens is const only protects, only covers, you can say, the insurance of this person. Const only ensures you that this person would not change its value. It does not ensure that the key of this person does not changes its value. So you're pretty ensured that pretty much JavaScript to make sure that you cannot do something like this. This would something JavaScript would surely protect you against, but not this. JavaScript does not say, hey, I am creating this variable as a const, therefore I would protect all of your keys. JavaScript does not say that, right? So to actually protect your object as a whole, what you have to do is basically object freezing and stuff like that. But we are not going to cover it because it's not really relevant for now. But for now, just remember that const does not mean that you cannot change your key value pairs in JavaScript. You can also do delete person.name. It will still work, right? But you cannot obviously modify this person object directly or assign it any other value. So I guess that's basically it for a basic manipulation, a more in-depth beginner video on objects in JavaScript. And that's all for this video. I'll see you then in the next one. Hey everyone, welcome to your 15th basic JavaScript video tutorial, in which we're gonna take a look at arrays in JavaScript, just like objects. So in a nutshell, arrays is a special version of objects in JavaScript. What do I mean by that? Well, let's see. So let's say I start with an object, but now instead of naming the keys as key name and something, I'm going to start off with 0. I'm going to say hello, 1, world. And I'm going to go ahead and use it object of 0 plus object of 1. And I'm going to say let array is like hello. and world. And I'm gonna do a similar thing with array as well. Not really ARR, just like that. And I'm gonna finally console log both array and the object. Hit save. You can see on the right we have very similar output for both. However, for arrays we have like a standard little notation, hello world, but for object we have like just like the key value pair. Now the thing is, with arrays they're obviously not similar exactly, because with arrays you get a lot of other methods attached to it, other benefits. For example, you can query for length of an array. You hit save, you get 2. However, there's no such thing like object length, right? You save it, you get undefined, because if you have a length property here, sure, you can get that 100, yeah, but there's not really inbuilt length for objects and stuff like that. But what I want to show you is basically very down the line inside code, your arrays are actually built on the top of objects only. So there would be a property named length inside this particular array, which is managed by JavaScript to provide how many elements are here, right? So let's just get objects out of the way and let's just talk about arrays only. So as I showed you, you can get arrays length with arr.length, right? You can basically again modify any element just like you would do with the index of that particular element. For example, 0 stands for hello, 1 stands for world. Well, what does 2 stands for? Well, it does not exist. So let's create it, right? And let's save. You can see we now have 3 elements in this array, hello, world, and 2 question marks, 2 exclamation marks, sorry. So what happens if I skip an index? Let's say instead of 2, I created a 3. Hit save. We see that it shows us empty. Well, it's just browser optimization. In reality, if you do a 2 off, you would see that it's actually undefined. So actually, what browser sends you as empty is actually undefined, right? So it does not really matter. It's just that they want to make more sense for developers, so they are just using empty instead. Well, what if I use array of 100? Let's just console log it, hit save. You see, we get an empty cross 98. That means 98 empty elements. Again, a browser optimization to not ask to show you 98 undefined in a line, right? But you can see its length has now 101, right? So that is the thing. Now, what happens if you do something like array of my key as this? Well, you see that we have got something strange here. We have 0, 1, and my key. It looks familiar. Well, you can see that JavaScript immediately converts it to a regular object, kind of a regular object. It still has its length property and stuff like that. But now JavaScript is storing it as a very regular object instead of an array. For example, if I remove this, hit save, you see we do not get that particular key again, but if you use this particular key, you would see that your object now contains not only the indices, but that particular key value, key name, as well as value name. Now this is a very highly discouraged practice in not only production, but also in development, because of the ways how JavaScript manages memory and according to types how it stores data. I really want to touch on this later on inside advanced JavaScript, but for now, let's just remember never to use an approach where you store elements inside arrays with key names. If you ever need to do this, go ahead with an object. Never use arrays for that. You're going to lose all the benefits, all the performance optimizations of arrays if you do stuff like this. So yeah, I guess pretty much that's it for arrays. We're going to take a look at methods provided by arrays in detailed depth later on, but for now I guess that's quite a good start for arrays for you guys. So that's all for this one, and I'll see you then in the next video. Hey everyone, welcome to 16th basic JavaScript video, in which I'm gonna finally introduce you to if else in JavaScript. Well, we have used it before, but let's just take a look at if else in our official video. Why not? So let's just create a variable. Let my name is Mehul, right? And now I'm gonna verify if my name is actually Mehul or not. Well, we do not trust variables, right? They change all the time. Okay, so if my name is actually Mehul, well, how do I do that? Well, you see, a single equal to sign means equality. That means you're assignment, not really equality, assignment. So when you use single equal to sign, you assign a value. When you use a double equal to sign, you check for that value, right? So double equal to sign would always return you either true or false, right? So if this is true, then I want to execute this block of code. And here I can say, let's see, I can say, well, the variable is still Mehul, right? Hit save. We get, yeah, well, the variable is still Mehul, so we can trust him, right? However, let's say I change my name to something else. Hit save. We do not get anything. Well, how do we map that? How do we determine that? If something works, I want to execute this block of code, this block. Else, if that is not the case, I want to run this block of code. So I'm going to write console.log. This doesn't, or rather we should say the value of the variable changed, right? Well, I remember, hold on a second, we could also have something else as a value. So I'm going to say else if my name is something else. And I'm going to console log this. Else, if nothing is like that, I'm going to say what the hell happened, right? Hit save. So we get the value of the variable is changed because this case is indeed true. And if I change it to like something else a little bit, so we get these question marks because, well, this is not really this, what we wrote in here, right? So this is how basically a if-else block looks like. You use if keyword. Inside your parenthesis goes the condition, which has to be true for that particular block of code to be executed. If it is not true, then it moves on to else if. If it is true, then it executes this and exits. If this is still not true, it will move down the chain, come to else, check, and execute basically. For else there's nothing to check, so it will execute whatever it sees and would exit. So I guess that's all basically. If else is quite simple to get hold of. That's all for this video, and I'll see you then in the next one. Hey everyone, welcome to 17th basic JavaScript video, in which we're going to cover off with our switch case in JavaScript and see how it's different from if else. So let's say you have a lot of cases to check. In that case, it's usually preferable to go for a switch case. I'm not going to go into performance and stuff, but it's more like one of the reasons is that it's more appealing to eyes, right? So anyway, let's just start with what switch case is. So switch case is basically starting off with switch inside these curly parentheses, your condition to check brackets, and obviously it's bothering me, so let's just name it condition only. Here what you have is that this is not really a condition, this is an expression, I should rather say. And we're going to say if this expression is case 1 something, if this is something else, if this is something else, else, the else block is this, right? So let's see how this works. I'm gonna write let my age is 20, and I'm gonna write switch my age. That means we're gonna work on my age now. I'm gonna say case if it is 20, I'm gonna say, well, console.log your I don't know, you're 20. Anyway, if it is 21, I'm gonna console.log you are 21. In any other case, I'm gonna say console.log you are neither 20 nor 21. Now, there's a catch with switch case, and that is if I save this, you would see that not only we get you're 20, but we also get you're 21 and you're neither 20 nor 21. Well, why is that? Well, before that, I just want to switch this to 21 and see what's the output. Now we get you're 21 and you're neither 20 nor 21. Before even explaining you that, why that's happening, I'm going to transfer this case statement from here to here and hit save. Now you can see again we get all three outputs. Well, what the heck is happening here? Alright, let's see how switch case would eventually appear to work like. You have switch of my age. Here it is 21. It sees 21 as the case. It prints this. Now what happens is that switch case is a falling statement. By that what I mean, once it's matched its case, it will keep falling down unless the block exits. Now, well, that sounds like a very weird behavior, but that comes kind of handy a lot of times. For example, let's say you want to have a similar case for 16, 17, 18, 19, and 20. So you can place just like that and you're done, right? So if your age is 17, it will fall down to 21, print this statement. If your age is 20, it will fall down to this, print this. But what if you don't want to fall it down beyond 21? For that, what we have is a break statement. So break, once you encounter this break statement, it will take your control directly outside the switch block. So we can write break at both the sides, at both the cases, hit save, and you see it works just like fine now. We're not getting any weird output of all three outputting, right? Now we can change this to 16 and see that we are still getting 21. So instead of 21, we can say you are less than 22, right? For 18, also it works because it falls down to basically when you encounter 18, it falls down to 21 and prints this, breaks out, gets out, right? If you place break at 18, you would see we get no output because once we get to 18, case 18, it breaks out of the statement, right? That's that. And obviously, if we have nothing matching, we get to default and we say you are neither 20 nor 21. We obviously do not need a break for default, right? Because it's the last statement you can see. So it does not really have anywhere to fall down to. So that's all for the switch case, I guess. I hope you get the idea. You can also compare strings here, integers, boolean, stuff like that, right? So yeah, I believe that's it for this video, and I'll see you then in the next one. Hey everyone, welcome to 18th basic JavaScript video, in which we're gonna take a look at math operators in JavaScript really quick. And basically there's not really a lot of stuff to look into this, so I'm gonna keep it really quick. So I'm gonna start off with a number one, which is 100. Let's say let number 2 is 200. So we're gonna start off with the addition. Obviously we all know that number 1 plus number 2, what it should give us, well, 300. So I'm just gonna place an add here. And by the way, if I did not tell you that you can pass in multiple parameters in a console log statement, and they would all be in a single line mostly, right? So we can start off with the other operators as well. I can name this as subtract, and I can do number 1 minus number 2. I can multiply them with the star operator, and I can divide them with the the divide operator, right? I can also do an exponentiation, which basically just means a raised to the power of b, right? So a raised to the power b basically just means multiplying a with itself for b times, as long as b is a whole number. Now I don't want to get into algebra of power, but that's what you can think of it as for now, right? For exponentiation, we can say 100 raised to the power of 2, which essentially means number 1 times number 1, right? If I write 3 here, then it means number 1 times number 1 times number 1, and so on and so forth, right? We can also have an increment. What this means is you increment a number, and I'm going to get to this with post increment and pre increment in the next video. For now, I'm just going to keep it real simple, and I'm also going to show you decrement. Minus minus number 1 only, right? Hit save. Okay, so what do we have in here? For addition, we have the correct result 300. Subtraction yields 100 minus 200, which is negative 100. Multiplication yields the correct result, which is 200 times 100, which is 20,000. Division yields the correct result as well. 200 times 200 divided by 100 is 2. Exponentiation is basically 100 times 100, which is 10,000, which is correct. Incrementing, what does this double plus mean? Well, it means that I'm modifying the value of number 1 by 1. I'm basically incrementing it. It's different from writing number 1 plus 1 in the way that plus plus number actually increments the variable itself, right? You can see when I change this, a decrement changed to 99, because if I do not increment it, it does not get to 101, hence it's still 100, hence when you decrement it, it gets to 99 instead of 100 from 101. If it might sound confusing, just take a paper, write it down yourself, you'll see what I'm talking about. If you do not increment 100 to 101, then when you will decrement it, it would obviously come not to 100 but to 99, because you know its original value was 100, right? We're going to cover these two, increment and decrement, in the next video in detail, but essentially that's all for now. So that's all for this video, and I'll see you then in the next one. So what's going on, everybody? Welcome to your 19th JavaScript basic tutorial. And in this tutorial, we're going to take a look at increment and decrement operators in JavaScript. So we took a look at, we can create variables like variable my name, my number is, let's say, 42, right? And now I'm going to show you some ways to increment and decrement it, which are usually handy ways, and you're going to do it all the time. So you should basically know the differences between various methods you have at your disposal, right? So what we're going to do, we're going to start off by just doing console log my number plus 1. Simple enough. And you can see we get 43 in here. Just keep your eyes here. The output is here. This is the code. Wait, I'm just going to zoom in a little bit here, right? So we can also do console.log 1 plus my number, right? And that should essentially produce the same result. What I'm going to do next is I'm going to do console log of my number plus plus, and I'm going to console.log my number again. So let's see what happens. My number plus 1 is 43. 1 plus my number is 43. My number plus plus is somehow 42, but it makes my number 43. So what's happening here? Well, before explaining this, let me just get rid of this, and let me just write console log plus plus my number and console log my number. Alright, let's see what's happening here. So my number was 42 initially, right? My number plus plus, if I console log this thing, I get 43. No, I get 42, right? Because that's the first console log statement. Second console log statement is basically what our value now is, so 43. Then plus plus my number gives us 44 and my number gives us 44. So if you're able to observe here, what we have is my number plus plus actually returns the value to the function first and then increments it, right? You can see it gives us 42, but after it's console logged, it increments it to 43 because we are doing nothing in this line, right? We're not manipulating this variable, we're just console logging it, whatever the value was, right? So similarly, on a similar basis, you can observe here that plus plus my number actually increments the values first and then returns it to the function, right? Therefore, the next statement is same as plus plus my number. So let me just ask you real quick, what should be the output of the following code? So I'm going to write my number 1 is plus plus my number plus my number plus plus. And for the sake of clarity, I'm just going to write brackets here. You don't really need them, but still I'm going to give brackets. So let's just console log num1 and hit save. Right, so we get 86 here. Now how the hell do we get 86 here? Okay, let's see how our browser sees the statement. So it evaluates this side to assign it to number 1, right? And what it does is it takes my number and it sees that, hey, it's prefix increment, prefix, right? So what it would do is instead of 42, it would write here 43, right? And then plus what it sees, hey, it is postfix increment, so I do not need to worry about this plus plus right now. I'm going to worry about this plus plus later on when this statement completely runs, right? But remember, my number is not 42 anymore because this statement right here modified it, right? So my number is now 43. So this is why we get 86 as the output, right? Let's just change the operations here a little bit. I'm gonna take this thing first and then add it to that. Hit save. Num2. Right? We still get 86. In this case, what happens is that my number is 42, right? So it would stay 42 right here. But what happens here it's interesting, is that once this statement is complete, after this statement runs, my number now is 43, right? And as you know, that plus plus increments it once more. So before returning, it increments it once more and makes it 44. Therefore, it produces 86 as the output, right? It might seem that those two statements, num1 and num2, are same, but apparently they are not. So usually you would not find this stuff to be confusing in real world code unless somebody codes it really badly, right? So anyway, you should know this difference in between prefix and postfix operators. It's pretty basic, and you're going to use it all the time, especially in loops and stuff, where you will just do I++ or J++, stuff like that, right? So on a similar basis, what we have is the postfix decrement operators, right? Just like increment, we have decrement, and it basically works the same. Instead of just plus plus, you have minus minus everywhere, right? And let's just comment this out, right? We can work on this as well. My number minus minus gives us 42, right? Plus minus minus my number. Remember, my number is now 41, and this makes us 40, right? So we get 82, correct? And if we do num1 instead, so this is num2, this was also num2, this was num1, and we still get 82. Why? Because minus minus my num gives us 41, and as you know, my number is now 41. My number minus minus does nothing, so 41 plus 41, that's 82, right? So this is a very basic tutorial on how, not really basic because that's all about postfix and prefix operators in JavaScript. So that's all for this one. I'll see you then in the next video. Hey everyone, welcome to your 20th basic JavaScript video, in which we're going to discuss about logical operators and interesting stuff with it, which is especially something I've found unique about JavaScript, right? So let's get into it. So logical operators, as it sounds, is something which is logical, which is or, and not, right? So without wasting any time, what we can do is take up an example, something like if, let's say, my age is greater than 10, or I guess we have covered math operators, right? So yeah, that makes sense. Or my age is not really or, and my age is less than 20. I can say console.log you are eligible for something, right? Whatever it is. And up here, I can define my age as, let's say 15, right? Hit save, we get you're eligible for something, which is pretty much correct because that's what my age lies in, right? Similarly, on a similar basis, what I can do is say if my age is, let's say I have, my height is 6, right? I can say or, it doesn't matter if this does not fit in. If my height is greater than 5.5, then also I'm eligible, right? Now, it does not matter if my age is even 7, right? I'm still eligible because my height is greater than 5.5, which is 6, right? Right. So this is or and. Now, not is basically used for Boolean values. So I can say, let's say, am I eligible is false. What I'm going to do is I'm going to say, am I eligible to true, right? And I'm going to say if not of am I eligible, that means I'm not eligible, then I'm going to say console log I am not eligible, else console log I am eligible, right? So that's that. Hit save, and you can see we get I am eligible because, well, we set the am I eligible here to true, right? So that's the boring stuff. Now let's get into interesting stuff in JavaScript, and that is basically whenever you write something like this, you expect this to be a Boolean, right? If you're coming from other languages, you would expect this result to be Boolean, right? But in JavaScript, what happens is that the operations which are done by or and stuff like that, return the value instead of a Boolean. And by that, what I mean is, let's say I create a variable here, let my magic variable. I'm going to say that this has a value of either 2 or 3, right? So what do you think would be the value of my magic variable here? Let's take a guess. If you are doing this in a regular language, it might be, first of all, a syntax error because these are not Boolean values to compare, first of all. But even if it passes, this appears to be, the result of this appears to be a Boolean, right? It seems logical. Yeah, 2 or 3, yeah, it's true because this is a logical operator. But upon saving, we see that we get the answer as 2. And why is that? Now, as I said, in JavaScript, if you're performing OR operation, the value which is returned would be the first truth value. What do I mean by that? Let's say I do a null or 2 or 3. Hit save. We still get 2. Why? Because null is not a truth value, right? Similarly, if I do 0 or 2 or 3, we get 2 because 0 again is not a truth value. So if you are doing OR operations, the value which you would get in a case like this would be the first truth value, which is like a number, maybe a string, maybe an object, stuff like that. That's what is going to be returned. The case reverses if you're using AND. If you're using AND, then you're gonna get the first false value, which is in this case 0, right? If I get rid of this, I get 3 because that's the last value. There's no false value, so it's gonna return the last value, right? If I'm doing like undefined, hit save, we're gonna get undefined, right? So you see that if you're using AND, you're gonna get the first false value. If you're using OR, you're gonna get first truth value, right? And with NOT, it's not really the case because NOT just converts true to false and false to true, but you can use NOT on regular values as well. So if you have my age as 10, and if I do like NOT of my age, you're gonna see that it converts to false. Why is that? Because 10 is a truth value, right? And the opposite of truth value, the NOT of truth value, is false. So you get false. So if you do a double NOT here, you get the actual value. So if you ever want to test if a value is a truth value or not, just put a double exclamation mark in front of it and you're going to get a Boolean result, an actual Boolean result, right? So if we take a look at undefined, you would see that it's a falsy value. That's why we get false on double exclamation. Null is also a falsy value. An empty object is a truth value, right? An empty array is also a truth value. So you can experiment, do stuff like that. 0 is a false value, right? So that was a basic tutorial on this, and I'll see you then in the next one. Welcome to your 21st Basics of JavaScript video, in which we're going to take a look at bitwise operators. In JavaScript, it's basically similar to other languages only, nothing special here. So what we're going to do is start off with some bitwise operators, which are AND, OR, NOT, and XOR. That's basically something you would kind of see in or not really in regular programming also. Bitwise is not really used. It's used for bit masking sometimes, but that's not really your concern for now. It's not really used a lot in regular web development, right? So what bitwise operators do is basically they would convert whatever you have into binary and do these operations bit by bit, right? So what happens is that if I take, let num1 is let's say 5 or let's say 6, and let's say num2 is let's say 3, right? And I console log num1 and num2. Notice a single AND is here. It's not a double AND, otherwise it would be a logical AND, right? And it's save. You see we get 2 here. Now what the hell did happen? It seems like you have divided them. Well, no, not really. What happened is that JavaScript converted the 6 to binary, which is 4 plus 2, which is 4, 2, and this is your 6 in binary, and 3 in binary is 2 plus 1, which is 2 plus 1. There you go, right? So now when you did num1 and num2, what happened is basically what you did essentially is you actually did an AND of these digits, these individual digits, right? So what you did was 0 and 1, which is 0, 1 and 1, which is 1, and 1 and 0, which is again 0. You get 0, 1, 0, which is 2, right? So that makes sense now. What about OR? What if I do a single OR? You see 0 and 0 or 1 is 1, 1 or 1 is 1, 1 or 1, 1 or 0 is also 1, right? So we get 7, right? Which makes sense because 1, 1, 1 binary is 7 in decimal. What about XOR? Well, XOR, if you don't know about what XOR is basically exclusive OR. It is 0 when both the inputs are 1. Well, all the inputs are 1, rather I should say, and it's 1 in just like OR, right? So 0 OR 1 is 1, 1 XOR 1 is 0 actually, right? And 1 XOR 0 is also 1. So 101 is 1 plus 4, which is 5, right? So everything seems working. Now, NOT basically is not really an operator you can do in between two numbers, but rather it's a operator you can do something like this. It's safe. You're gonna see we get -7 and -4. Why is that? Well, if we take a look, 6 is basically, well, we already do have that information with us. So -0, what it does is basically, and actually JavaScript stores numbers like this, right? Not just 3 bits, right? All these zeros, stuff like that. I'm not really counting it, but these also do have a fixed length. So it inverts all the bits, right? So all these bits become 1, 1, 1, 1, 1, 1, 1, 1, stuff like that, and then 0, 0, these two, and then 1, right? And this also becomes stuff like that, and 1, 0, 0, stuff like that, right? So this is basically another decimal. This is basically 2's complement representation of JavaScript in numbers, which is used to represent negative numbers. So essentially you can learn about them if you want to. I'm not really going to cover that in detail right now, but when you double negotiate it, you can verify that you get your number back. You see, we get 6 back. So that's what essentially it's doing, right? It's flipping all the bits. So that's basically, yeah, that's all you need to know about bitwise operators in JavaScript. So I'll see you then in the next video. Hey everyone, welcome to your 22nd JavaScript basic video, in which we're going to discuss about for loop in JavaScript and see how it basically works and how you have to use it, right? So looping is basically a concept of repeating a statement some number of times without actually writing them all by yourself, right? It's essentially useful because sometimes you have to loop a variable number of times, which then basically you want to use loops there, because you cannot write a statement variable number of times, right? If it's a fixed loop, sure, you can replace that and write it all by yourself, but how would you write if the loop gets its input, say, from the user, right? So we're going to discuss for loop in this one, right? And the syntax for that is for, then curly bracket, not really curly brackets, parenthesis. Your 3 statements would go in here, right? Here goes stuff, declaration stuff, right? Whatever you want to declare, variables which are used in this variable. Now remember, let is a block scoped variable, and for loop create a block. So if you use let here, you won't be able to use that variable here. But if you use var here, you would be able to use it here, because var is function scoped. And I'm going to get to that, what I mean by that, pretty soon. So I'm going to say let I equal to 0, right? My initialization is done. Now here's my condition till when, up to which point this loop should run. So I want this loop to run until I is less than 10 or I is not equal to 10, whatever you like, right? But the preference is kind of like using less than and greater than, right? Now here, what do I want to do at each iteration? Well, I want to increment I, right? I want to plus it by 1. But again, instead of this, we can use I++ to make things simple. And I'm just going to console log I here and see what happens. So you see what happened here is basically, I'm going to elaborate it right now. When JavaScript came to this line, it said, okay, let's initialize this let I equal to 0, done. I'm going to check if this statement is true or not. Well, 0 is less than 10. Okay, fair enough. We're going to run this. We're not going to check this at the first iteration. We're not going to execute this at the first iteration, right? So what happened was step 0 was I equal to 0. Step 1 was checking if I is less than 10, which is true. Step 2 was executing the block, right? This block. All right. Then step 3 was I++. Step 4 then again was checking the condition if I is less than 10. Well, is it less than 10? No, because I++ finally gives you 1, right? And it does not really matter if you use I++ or ++I here, because it takes in account of the final value, because here's essentially where you're checking I, right? Not here. So it does not really matter, right? I'm going to just keep it I++. True. Step 5, again, executing, and this would continue. I'm going to get to a step X where I++ is going to give me 9. X plus 1 is again checking. 9 is less than 10, which is true. X plus 2 is executing. X plus 3 is basically I++, which gives me finally 10. And then X plus 4 is checking. Now it is false, so I get out of the loop. So that's why when I++ is 10, it does not really execute and show here. Right? So now, the reason I explained you all this, because I wanted to use var here. Now what happens, since I told you var is function scoped, that means it still exists outside this loop. So I'm going to console log I here and see, let me just console log so that we can see a difference. Let's save. You see what happens is that it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it exits the loop, and then we still see that I is 10. So this is a very common practice actually used by developers whenever they want to get information on how many times the loop ran, right? Because any statement here which breaks the loop would break it, would not allow this thing to happen anymore, and therefore you're going to get the exact count that, yeah, this loop ran 10 times, or pretty much this loop ran like 12 times, right? From 0 to 11. So you're going to get that count always, right? So this is basically about for loop, how it works with let and var as well. And this is basically the working. So that's all for this video, and I'll see you then in the next one. Hi everyone, welcome to your 23rd Basics of JavaScript tutorial, in which we're going to discuss about while loop. In the last one we discussed for loop, and this is basically just another version of looping stuff, right? So for loop gives us the option of placing everything in one place and executing the block depending on the conditions which I told you. But while loop, what it does is that it gives you just a single place. It says while this condition right here inside these two parentheses, if this is true, as long as this is true, this code would execute. And obviously you can modify this condition inside this code only, right? So, all right, let's see. I'm gonna say while, let me see, var I is equal to 0. I'm gonna say while I is less than 100, I'm gonna do a console.log of I, and then I can set I++, right? And hit save. You're gonna see we get all the output from 0 to, unless we get to 99, because once I become 100, it's no longer less than itself. Therefore, the loop quits. And obviously you can console log I here to see that how many times the loop ran, right? And once you do that, you're gonna get 100 here. So pretty similar to for loop only. Only difference is that it gets rid of all those initialization and stuff, leaves it to you, and basically just gives you a container for the condition to be validated at every iteration. Right? So that's all about while loop, and I'll see you then in the next video. Hey everyone, welcome to 24th JavaScript basic JavaScript video, in which we're going to discuss about do-while loop. Now in the last two videos we have been discussing loops, and in the last video we discussed while loop. Do-while loop is also similar, but the thing is, if you write a while loop, let's say var I is equal to 100, I'm going to say while I is less than 10, console log great and I++, right? Now what happens is that we have no output because I is not really less than 10. It's actually much bigger than 10, that's 100, right? Sometimes what happens is that you always want this block of code to run at least once, right? If you want it to run at least once, obviously you can just copy paste it here yourself, right? But instead what you can do is take out this while thing, place a do here, right? And just after this do, place a while here, right? So now if you save this, you're gonna see we get great here at least once because this condition is now false, right? And if this was 0, let's say, and it's save, you see we get great 10 times, obviously, because that's how many times the loop would run. You can verify that by just console logging I here as well. You're gonna see we get 10, so the loop ran 10 times. That's why we got 10 grades here, right? So that's basically it for the do while loop as well, pretty much similar to the while loop itself. And yeah, that's all. So I'm gonna see you then in the next video. Hey everyone, welcome to your 25th Basics of JavaScript video, in which we're going to discuss stuff like break, continue, return, these things, right? So to begin with, I'm really quickly gonna write a for loop for our video. There we go. And I'm just gonna console log I here. Pretty similar stuff. We see we get all the output from 0 to 9, right? And we have discussed why this is the case. So what I'm going to do next is inside this block only, I'm going to say if I is actually equal to 5, which it's going to be at its, what iteration, at its 6th iteration, I'm going to say break. Hit save. Let's see what happens. So we have the correct output till we get 5, but after that, what happened? Well, it encountered this break statement, and hence, whenever you see a break, whenever JavaScript sees a break, it gets you out of this loop, right? So if you want an early exit out of your loop, you're going to make use of break. Cool. What if we make use of continue here? It's safe. Well, you can see we get all the output correct. Nothing's wrong. But hey, wait. What happened here? Well, if I try to console log done here, hit save. Let's see what happens now. So we get 0 done, 1 done, 2 done, 3 done, 4 done, 5. Hey, 5 is not done. So what just happened? So what happens is basically whenever JavaScript continues statements, it does not execute anything below it inside a loop and returns back to that step which I told you, increment it and check, right? So JavaScript skips all the things below it and gets back to there. So if we place console log here instead of the first statement, what we're going to see is we get 0, 1, 2, 3, 4, no 5, 6, 7, 8, 9, because when I was 5, we skipped this line. We skipped basically anything below it, right? So that's the basic difference between break and continue. Obviously, you could write return here, but it would be an illegal statement because you're not inside a function, right? And I'm pretty sure we have covered functions. Yeah, so we did cover function. So what I'm going to do is create a function here, function my loop, right? I'm going to copy paste this whole loop inside here. I'm going to call my loop. Hit save, right? So you see we get pretty similar output to what we got with break. You can see it's similar. So what's the difference? So essentially what happens here is the output is same, but the difference is if you're using return, nothing even outside this loop would execute, right? So if I say loop ended, right? You see, it does not appear. But if I make use of break, obviously we get out of the loop. With the return, we get out of everything. Get out of the function itself, not even the loop, right? We just quit out of everything. So that's basically gist of what break, return, continue, stuff like that does. So that's all for this video. I'll see you then in the next one. Hi everyone, welcome to your 26th basic of JavaScript tutorial. And in this one, we're going to discuss map for arrays, a map function for arrays. There's something known as map, which is different in JavaScript. We're going to come to that in intermediate section maybe. So what we have in here is, first of all, let's just create an array. So we have this array, right? Now, based on this array itself, what we can do is create another array, array2, which would be actually based on this array, but a little different, right? So what I'm going to do is say array.map, and map takes a function, right? And I think I've not gone into the arrow functions, but what essentially they are, I can just cover them quickly here. So I'm going to cover them again later on in the next video, but let me just cover it here. So you have a typical function like function by function, like this. You can create a similar function by saying let my function is an arrow function, something like this, right? So what you have is a variable which is assigned this function right here. So arrow function takes all these parameters in this parentheses, similar to this, and then the definition starts from this equal to, and then the symbol, the greater than symbol, and then the block of the function, right? Just remember this is an alternative to this one, although there are a lot of differences, right? But we're not going to cover them right now. So I'm going to say array.map is, I'm going to get an element here, and then what I'm going to do with this element is say I'm going to return element times 2, and I'm going to console.log array2 here. Hit save. You see, now what we get in here is a new array with all the values being doubled, 2, 4, 6, and 10, 12. Our original array was 1, 2, 3, 4, 5, 6. New array is 2, 4, 6, 4, 2, 4, 6, and 10, 12, right? So what happens is that map gives you a new array based on the older array, of which you can parse element by element. So if I return, let's say 0 here, you can see our new array consists of all zeros because that's what we instructed it to do, right? So this was the map utility, a map function on array, and that's pretty much it for this. And I'll see you then in the next video. Hey everyone, welcome to 27th Basics of JavaScript video, in which we're going to take a look at filter for arrays in JavaScript. In the last video, we took a look at how, if you have, let's say, an array of some numbers, what you can do is basically get another array by using map on it and saying that a single element should be transformed according to the rule return, let's say, element divide by 3, right? Hit save, and you're gonna see in console log we get 0.3333, 1, 1.6666, and 2, which makes sense, right? On a similar way, what we can do is we can create new array using something known as filter. And what filter would do essentially is whatever condition, not really condition, whatever the return value of this function would be, if it's true, then what happens is that that particular element is included in this new array, otherwise it's not included. So for example, I'm going to say element, and what I'm going to say that if element is greater than 2, let's say that if element is greater than 2, I'm going to return true, right? Otherwise I'm going to return false. It's safe. And by the way, you don't need curly braces if your if statement just has only a single statement, right? You can write without curly braces. Obviously, I would just prefer you to use semicolons at the starting. And finally, you can just console log your new array so that you can see what its contents are. right? So you can see we get 356 because 356 is essentially the elements which are greater than 2 which are present in our array, right? On a similar basis, we can do stuff like this, right? If none of the conditions matches, you're gonna get an empty array, obviously, right? So this is how basically filter works for array, and that's all for this video. I'll see you then in the next one. Hey everyone, welcome to 28th JavaScript basics video, in which we're going to discuss how to use for each for arrays. So basically it's similar to other two methods we learned. So I'm going to create an array. Again, I'm going to say these are some names, anything, right? Stuff like that. So what I'm going to do is say array for each. Now for each is just like map, but instead what happens in map is that whatever value you return, a new array is created out of it, right? But for each, what happens is that that's just a simple loop, right? So it's basically just doing something with this element, right? Doesn't matter what you return, doesn't matter if you return anything at all or not. Just that's it basically. So you can just console log element, right? Hit save. You can see that we get all the names listed, and you can verify that nothing is being returned from this for each by just console logging it, and you see we get undefined. That means this particular piece of code doesn't really return anything at all, right? So for each is basically used in as a drop-in replacement for our traditional loops, like stuff like this. You can say is array of I, and then whatever you want to do with this element. This is basically more or less like this only. There are obviously differences between them, but again, since this is a beginner tutorial, I'm not really going to cover a lot of differences, but more or less you can think of these two as the same implementation, at least when you don't have any asynchronous code, right? We're going to get to that later on, but for now, this is just a cleaner and drop-in replacement for this for loop, right? So yeah, I guess that's it for the for each part, and I'll see you then in the next one. Hey everyone, welcome to 29th Basics of JavaScript video, in which we're going to cover something known as reduce for arrays. It's also a popular and commonly used methods for arrays, so I just want to cover it real quick. So what it allows us is, as the name suggests, reduces the array to a single value. It's particularly useful for numbered arrays where you want to do a computation on all the numbers but at the same time reduce them to a single value. So let's just create an array with let our arrays 1 2 3 4 5 6 7 8 9 10, right? And we know the sum of all these elements is 55, but let's just compute it using reduce. So what reduce does is you can see that it accepts a function inside its curly parenthesis, and what this function does is that this consists of two arguments. The first one is you can say the accumulator, and the second one is the current value, right? So accumulator is whatever you have done so far with the values, right? And current value is the element, right? So what happens is that when you do something like this, accumulator by default would be the zeroth index value, and current value would start from this one, right? So what I'm going to do is return accumulator plus current value, and I'm just gonna say constant result is this thing. I'm going to just console log this result so that we can see that our answer is 55, right? So what's happening here? At first iteration, what happens is accumulator is 1, right? And current value is 2. At second iteration, accumulator is 1 plus 2, that is 3. Current value is 3, right? So you can see that it goes on so on and so forth unless we hit 55 and we hit current value as not really 55, 45, and current value is 10, then yeah, right, at the last iteration this is the case, and then we finally return 45 plus 10, that is 55. So you can see right now we are running this function, this particular piece of function 8 times, right? 2, 3, 4, 5 up to 10, that is 9 times, not really 8 times. So we are running this function 9 times. But what happens if I pass in a second argument here, let's say 0? We still get 55, which is correct. By the way, this 0 is the initial accumulator value. But now the difference is the loop starts from accumulator having a value of 0 and current value having a value of 1. So the thing here is, if you observe, now when you provide accumulator a value, an initial value, then the loop runs 10 times, starting with index 1, right, index 0. But if you don't provide it a value, then the loop runs 9 times with accumulator taking in the first value, the first index, and the current value being starting from the next index. So this is kind of like somebody can ask you how many times this function executes, so you should know. And by the way, we can just quickly verify that by, let's just say, we create a count here, and we just do a count plus plus, and we just console log the count instead, right? Hit save. We see the function runs 9 times, not 10 times. However, if I provided initial value to accumulator, you see that the function now runs 10 times, which is pretty cool, right? So there's no difference between providing a 0 here or not, but sometimes you would need to provide accumulator an initial value. So there you go. So yeah, I guess that's it for this video, and I'll see you there in the next one. Hey everyone, welcome to 30th Basics of JavaScript video, in which we're going to discuss about Indexof and Find and basically stuff like that for arrays. So we have to look how we can map over an array, filter values out of it, just loop over with for each, and use reduce for reducing an array to a single value. But sometimes you have to see if a value exists in an array or not. So let's see if we have an array of my favorite foods, right? And we just put in random stuff in here. Let's say pasta, and the list would go on, but anyway. So let's say if we want to determine whether you do have a favorite food or not in there. So what we're gonna do is just run my favorite foods dot index of, and then the thing which you want to check, right? So let's just say pizza. So now if you run this, you get a 0. Now what does that mean? Well, Indexof method actually returns you the index of the element passed, right? So in this case, you can see that pizza is at 0th index, burgers is at first index, so you will get 1, right? And so on and so forth. Now with the ES6, what you have is, first of all, let me just tell you that if you just include an element which does not really exist, you're going to get a -1, right? So what you have to do pretty much is just do a check of this. So you see, we get false, that means this element does not exist. And we get true, that means this element does exist, right? So ES6, what it did is, instead of like providing this thing, now we can do just simple includes, which would automatically return us a Boolean value. Let's say I do a burgers here. So you can see that we get a true value here because it did exist, and anything which does not exist, you see we get false, right? Now on a similar basis, what you can do is you can say my favorite foods dot find, and actually this is useful in cases when you have objects as the values of array, right? So what I'm going to do is I'm going to say students is an array which consists of objects having name as, let's just say ABC, age as 15, right? Then we have another student with name as DEF, age as 16, so on and so forth, right? So now what we want to do is basically we want to get a student, we want to find a student, students dot find, and it's all English, right? So you want to find a student and you can say S is the temporary student variable, where you want to find which student whose age is equal to 15, right? It's safe. Just console log that particular student, and you're gonna see that we get that particular student whose age is 15, right? So this find method is usually useful when you have objects inside arrays, but you can use it anyway with any data kind, right? So whatever value you return, the find would return the first index. Now even if it were 15, then you would still get ABC because find exits on the first match, right? Otherwise you can have any parameter, like name is DEF, then you will get, you know, that particular record. And if you execute something which does not exist, it will return you undefined, right? Simple enough. So that's all for this video, and I'll see you then in the next one. Hey everyone, welcome to your 31st JavaScript video, in which we're going to take a look at a very interesting, however very important topic in JavaScript which people often mess around with, and that is differences between double equal to and triple equal to, right? So what happens with JavaScript is that when you compare two variables, let's say A is something, let's say B is also something, right? So when you try to compare A with B with double equal to or triple equal to, what JavaScript does, first of all, is it determines the type of both the variables, right? So either there could be two possibilities: the types are same, types of A and B are same, and by type I mean that both A and B are strings, or both A and B are numbers, or both A and B are objects, stuff like that. Or the other possibility is the types of A and B are different, right? Right. So when this happens, when types are same, what happens is that depending on the type of variable, it would either compare the value or the memory location, basically, right? So it could either compare the value, if it's a literal, if it's a, you know, a string, number, stuff like that. Otherwise, in case of arrays, it's going to compare memory. But you don't need to remember all of this. I'm just telling you how the JavaScript works under the hood, right? Don't need to get into a lot of details right now because that's not really required on the basic one. But still, it's good to know what's happening. If types are different, then what happens is a type conversion first, right? So what happens is JavaScript converts one type into another type to actually compare them, right? Because you cannot compare apples with oranges, right? So you need to convert either one into another to actually compare them. So let's take a look at A being 2 and B being this. So what I'm going to do is write console log A is equal to B. Let's see what happens. So we get false for triple equal to. Now the reason for this is that once you encounter equal to or equal to, the step 1 is check types. Step 2 is if type is not same and operator is triple equal to, then return false. That means, you know, they are not equal. Otherwise, what happens is if type is not same and operator is double equal to, then, you know, change the type of one variable. And finally, compare the values. Type is now same, right? In either case, if it's not same, then triple equal to actually just, you know, returns false. If it's not same and the operator is double equal to, it changes the type. And then finally, both of these operators compare the values. So what happens with triple equal to is because the types are not same, you know, it returns false automatically. However, if we do a double equal to, you're going to see that we get true instead, because 2 is compared to a string. So what happens is that this type is changed from number to string, and then basically both of them have, you know, are equal, so it returns true. So what's happening under the hood is JavaScript is calling toString on A to make it string, which eventually returns you 2 in the form of strings, right? So there are all the rules written out how you decide which type is upgraded and what happens, but I'm not really going to get into depth of that right now. But for just your reference, that's what's happening right now. So A is converted to string and is compared to B, and therefore, they are true, they are same. On a similar basis, what happens is, let's just say I have an array 1, 2, 3, and I have a string B as 1, 2, 3. Now what happens? See, the double equal to returns true, surprisingly. Well, why is that? Well, you can guess that if you call .toString, the toString method on an array, you should probably get something like this, 1, 2, 3. See? So if you forcefully convert an array to a string, you get all the values separated by comma, right? So that's essentially what JavaScript does under the hood. So it sees, oh, you are comparing a string to an array. Let me just convert this array to a string and then compare them. However, if you directly compare them with triple equal to, it will quit on step 1, step 2, because their types are not same, right? So this is a string, this is an array, you can compare them. So false. Yeah, they're not equal. Cool. Another thing is that if you even have same types, then if you run this, save, you see we still get false. Now why is that? You might argue that both might be called as toString, but hey, we are not comparing arrays with strings, right? So JavaScript does not perform a type conversion here. It directly compares the values, and in case of values, it refers to the memory location of A and B. And because they are different, it's obvious that it will return false, right? However, if you did like something like let B is A, then obviously it will return true because both point at the same memory location. So as a matter of fact, instead of getting confused, what I recommend you guys is to always use triple equal to, because double equal to, for using double equal to right way, you have to know how the type conversion works and which types might convert into which. So for example, you might mistake this to be like, for example, you want to check if B is defined or not. So what you can do is if B console log, B is defined, otherwise just B is not defined, DEFINIT, right? Now you might think that, well, B is, yeah, it's defined, but what you actually get is it's not defined, because you're trying to compare a number to a boolean, right? Because a boolean goes in here, right? So when you convert 0 to boolean, it's false. So if you don't know that, you might just miss this. So what you want to do is actually check if B is actually undefined or B is actually false, whatever condition you want to do. Then only you want to do basically, actually we did something wrong. So we want to check if B is not undefined or B is not equal to false. That means B is defined, right? So you can see that for double not equality check as well, we are making use of an exclamation sign and 2 equal to instead of just 1, right? So that's how you have to work. So I guess that's all for this video. I'll see you then in the next one. Hey YouTube, welcome to your 30-second Basics of JavaScript video. My name is Mehul, and in this video, let's just take a look at what DOM is in JavaScript. DOM is not really a part of JavaScript. DOM is something which the browser constructs. So what happens is whenever you write an HTML document like this, JavaScript, what it does is it constructs a DOM, which is a tree-like structure to actually represent what your HTML code is, right? So for example, this is DOM right here. So you have your HTML tag, then you have head and body inside it, just like this, and then you have inside your body certain tags, inside the head certain tags as well, like title. With title you get a text node, and so on and so forth. So this whole thing, this whole tree is called a DOM, right? So what's so special about it? Well, to manipulate this DOM, for example, let's say you want to edit the title text from my text to hello world, let's say. So you need to have a certain API exposed to you in order to traverse this tree, get to this node, and change its text, right? It's basically a tree is given to you, and you need to change the contents of a particular node in that given tree. So how would you do that? Well, there are a lot of ways to do it, but JavaScript, what it does is it exposes a DOM API, and not really JavaScript, but the browser itself. So you can say that 2 plus 2 is 4, right? This is a part of JavaScript engine. The JavaScript engine knows how to do this, how to compute this thing, but JavaScript engine by itself does not know how to traverse this tree and then modify this thing, do whatever. So the browser actually exposes you some APIs, that is, some ways to traverse this particular tree and get to this node, and then do manipulations with it. So, for example, if you if you consider Node.js, which is JavaScript running on the server, you would not get these APIs on that part because Node does not implement DOM structure at the backend, right? Because it does not need it. On the browser, JavaScript comes as a separate thing, and browser adds functionalities to that particular JavaScript engine, which allows you to traverse the DOM tree as well. So to summarize, DOM tree is nothing but a tree of elements, right, which is exposed to JavaScript via certain browser APIs like document, like window, and so on and so forth, which we're going to discuss later on, right? And I think, yeah, that's a basic overview of what DOM is. And from the next video onwards, we're going to see some stuff related to it. Hey everyone, welcome to your 33rd JavaScript basics video, in which we're going to take a look at what document and window objects are in JavaScript and basically how to work with them. So in the last video, we took a look at what DOM is in JavaScript, the document object model, and how it basically creates a tree out of your HTML structure so that you can manipulate it later on. So now, two most interesting objects you can say in JavaScript which exposes DOM API to you are window object and the document object. Well, as you might have guessed, the document object gives you access to the whole document itself at once. You see, when I hover over this, the whole screen turns blue because the blue thing shows you what you have been working with, right? So for example, if I go to elements and hover over h1, you can see the blue area actually shows me where the h1 is, right? Just like that, when I hover over document, the whole screen turns blue because the whole screen is document, right? When I expand this, you see we get our regular HTML structure right here. The window object, however, is above document. So what do I mean by that? Well, if you expand window object here, you would see there are a lot of properties here for window object, right? Window is an object. We have talked about objects, and objects can have both methods and properties. Window object has both methods and properties, and you would see that somewhere along here we would be able to find document as well, right there. So you can see that window actually contains a document object. You can see it's similar to that, right? So now, if I write window.document is equal to document, you see we get true because both of these refer to the same particular object only, right? We have been doing alerts and confirms and stuff like that. You see that is browser specific. So browser has the responsibility to expose those alerts and confirms and stuff like that to us. So we just did alert and it worked. But what browser is under the hood doing is actually calling alert on window.alert, because alert is actually a method on this window object, right? So just a quick little tip here: if you want to check a particular property or a function exist in an object, what you have to do is just write alert in window. It says me true. What do I mean by that? What does this mean? This is basically just like, for example, if I create an object, let's say let my object is A1, B2, right? And now I say A in my object, which is true. But if I say C in my object, this key is not there, so obviously this is false, right? So we can see that alert was in the window object. We can see that the document is also in window object. We can also see like confirm, which we used, is also in window object, right? So basically all the browser specific functions of JavaScript you would find in window object, right? Because this window object is provided you by the browser, not by the JavaScript, which kind of may seem confusing, but for now you can just remember that window is JavaScript only. So with window and document exposed to us, we can do a lot of manipulations to the DOM now, because document gives us access to that particular DOM tree, and from here we can access basically all the elements, iterate over them, change their contents, change their styling, what the text they hold, animate them, stuff like that, right? So document also comes with a lot of properties. So if you want to take a look at those properties, what you have to do is just write console.dir, I think, document, hit enter, and you would see the properties now. So whenever you want to, sometimes what happens is, just like in this case, if you just write document, it will give you the actual document. But if you want to see the properties associated with this particular object, just console.dir, right? Once you do that, it will give you the properties. Document.url will give you this thing, document.base URI will give you this thing, and so on and so forth, right? Compat mode. You don't need to worry about all this stuff. Just go through it, just take a look, have a taste. What if you can understand, some things, it will be good. Otherwise, this is not really necessary. Most of the properties here are null because they are not set, right? But it might be interesting for you to see stuff like this. So this was a little introduction to the document object and window object, and that's all for this video. I'll see you then in the next one. Hey everyone, welcome to your 34th Basics of JavaScript video. My name is Mehul, and in this video let's just take a look how we can actually traverse the DOM tree and make some modifications. So we know that if you write document, it will automatically be appended by window.document. So you do not really need to write window all the time, right? Unless there's a name collision or something like that happening. So we're just fine with document as well, because all the properties of window object are automatically exposed without actually writing window itself, right? So we're going to say document.getElementByID. Now what does that mean? Well, if you see, if I just write this thing, which should technically give us the function definition, we get function getElementByID with some native code. Well, what does that mean? Well, this function is not really implemented in JavaScript. What you would typically do is you would create an object and you would say getElementByID is a function. It just says, let's say, return 5, right? And hit enter. So now if you do object.getElementByID, you see you get the function definition, but with document.getElementByID, you get native code. And the reason for this is this native code is actually implemented not in JavaScript, but in C, C++ or other languages JavaScript is built on the top of, right? This is obviously because it's faster to access native code than JavaScript. So anyway, this was not really a part which was required at this time, but still I wanted to just get it out. So what we want to do is we need some way to select this H1. So we took a look at getElementByID is a way to do that. So I'm going to give it this element an ID of, let's say, name, right? Once I give it an ID attribute, I can actually write document.getElementByID name and hit enter. You see, it returns me this particular element. With this, I can now take a look at what methods do I have with this. We see h1.name has a lot of interesting methods. We have access key, all these properties, and if you take a look at the methods, you have like these properties like inner HTML, inner text, right? And a lot of stuff for you to browse, right? So right now, what we're gonna do is just say that document.getElementByID.name.inner text, which is a property we took a look, and let's say this is my name is code down, and hit enter. You see, once you change it here, the DOM reflects it, right? So this is one way of changing the text. You assign an element, an ID, and an identifier, and you select it with JavaScript. You dot it, basically just get its inner text property, and then override it with your new text. Now, obviously, I can change it back to like Mehul123, whatever it is, right? And it will reflect. On a similar way, not only do we have getElementByID, we have a lot of other selectors as well, like getElementByClassName, getElementsByTagName, and so on and so forth. So we're going to take a look at some of them in the next one. And that's all for this video. If you liked it, then don't forget to subscribe, and thank you for watching. Hey everyone, my name is Mehul and welcome to 35th Basics of JavaScript video, in which we're going to take a look at another selector for elements, which is getElementsByClassName, getElementsByTagName, and so on and so forth. So let's just jump into it. I'm going to reload the page first so that we get our context back. And now I'm going to say let selectors, or rather, let me just create some more elements here. Hello world 2. This is changes from ID to class because ID has to be unique. Class could be same as well, right? So now I'm going to say document.getElementsByClassName. See, we get document.getElementsByClassName, and then I'm going to pass in the name of the class, which is name right here, and hit enter. Now if we take a look at what selectors is, you see that it is an HTML collection. It's not an array, though it is, but it's still not the type of array. And we have these two elements, 0 and 1, which are this one and this one. Now, instead of like doing selectors dot something something, we have to first of all get into that particular element. For example, this one, and then we can say inner text is first element. Let's say, right? You see it gets changed. Similarly, we can say one.innerText is second element, right? All right, so this is how you get elements by class name. And remember that if you have elements in your selector, the plural form, then you're gonna always get back an array, even if there's only a single element, right? So even if there were just, let's say, a single one, and still if you did this, then also you're gonna get a single element in an array, right? It does not matter. So now let's say you do not have class or IDs, but you want to select tags on the basis of their names, right? So what you're gonna do is you're gonna say let elements is document dot get elements by tag name, and you're gonna say p, let's say. And now if you write elements, you're gonna get a collection of two elements, which is the first p and the second p, right? So now again you can do similar stuff. Dot inner text is right, and elements one dot inner text, and you might have noticed there's this inner text and inner HTML. What this means is basically you can, if you want to like give something like my name is Mehul and you wanted Mehul in bold, then you're not gonna get it with inner text because it treats everything as text. But if you want your JavaScript to actually render the HTML inside your text, you're gonna make use of inner HTML. You see, where's the difference? So if you just have a text like this, it does not matter if you use inner text or inner HTML. But if you do have your HTML as well embedded inside your text, which you want to replace the original text with, you better use the inner HTML attribute. You better override that, right? So this was a brief on how to select other elements apart from getElementByID, using getElementByClass name and using getElements by tag name. Right? So this was a little DOM manipulation. Now you can obviously, on a similar basis, edit the title as well. So for the title, how would you do that? You're going to say document.getElement by tag name, get elements by tag name. What do you want? You want title, and since you know there's only a single title, you're going to give it a 0. And then what you want is again get elements by tag name, and again you want, or actually you already have title. You can go head and then you can go title, title, right? So you see you can nest this stuff, right? I'm nesting this stuff, and then you can again give it a 0 and say dot inner text is wow, right? So you see our title changed from document to wow. So what did just happen here? So document.getElements by tag name of 0 gave us access to this head element, right? And then on this node of the tree, considering this as the whole tree, you did another getElements by tag name of title. So it searched title only inside this head tag, and then you access it again, and then saying dot inner text, setting it to wow, gave us wow. Now a shorthand for this is because since we access head all the time, JavaScript has already exposed document.head to us with document.head and document.body to us with document.body, right? You don't need to do like document.head dot document.getElements by tag name head and then 0, stuff like that. You don't need to do it. So JavaScript also has a very nice way of working with CSS selectors, which we're going to take a look in the next video. That's all for this one, and see you then in the next one. So what's going on YouTube? My name is Mehul and welcome to your 36th basic JavaScript video, in which we're going to take a look at setInterval and setTimeout. So setTimeout basically allows you to delay the execution of a particular piece of code. So for example, let's say you want this line to change from my name is Mehul to something else in 2 seconds. So what you're going to do is write console.log, let's say program starts. I'm going to write console.log program ends, and in between here I'm going to write set timeout with then fat arrow notation, the functions we talked about, and I'm going to say this as document get element by id name dot inner text, and let's say something, right? And obviously we can just give semicolons, just leave it. And what happens here is, see, you can see that we have id h1 id name, so we're good there. And if I add a 2-second delay here, you see the first argument is a function, which is the function which basically executes after the duration specified, right? So if I hit save on this, you see we get program starts, program ends, and then after 2 seconds it changes to something, right? And then nothing happens. So set timeout runs exactly after the duration specified and then stops. However, if you have set interval here, and let's say we have let I is 0, and I say the inner text of this is basically not something but ++ I instead, and hit save. So what we're going to see is after 2 seconds, you see this counter increments every 2 seconds, right? So set interval keeps this block of code executing after every whatever duration you specify here. So if I drop it to like 100 milliseconds, you're going to see that our counter updates every 100 milliseconds, right? However, if you just have set timeout, you're going to see that it just updates once and then it stops. The set timeout is for actions which you want to delay in the future and want to execute it only once, whereas set interval is for repeating this particular piece of code every x seconds, where x is specified as the second argument, right? So that is all for set timeout and set interval, and in the next video we're going to take a look at how to basically clear them and manage them as well. That's all for this one, and I'll see you then in the next video. Hey everyone, welcome to your 37th Basics of JavaScript video, in which we're going to take a look at how to use clear timeout and clear interval to actually clear your timeouts and interval. And by that, what I mean is stop executing them before they have happened, or basically in case of set interval, just clear them so that there's no further execution, right? So what happens is sometimes you want this thing to not run if a certain condition is met, right? So to do that, what you have to do is, let me just begin with set interval because that would be easier to explain. So we have this I++ condition with us. Let's say I want to run it only till maybe I is 100, right? When I is 100, what I want to do is clear this interval. Now, how do I clear this interval? Well, you need to call clearInterval, but you need to pass in the ID of this particular interval. And by ID, what I mean is that whenever you create a particular interval, it always returns this function. This whole function returns a number, which is an ID of this interval. So once we get this ID, we can actually use it to clear this particular interval. So if I save it now, what we're going to see is that it runs to 100 and then it stops. So let's just wait it to hit 100, and there we go. See, so once we get to 100, what happened is that I became 100, and then we ran clear interval with the ID passed, right? You can also console.log this ID to see what this is. So we see this is 3, and right now I can manually just clear interval of 3. You see, when I cleared it at 3, it stopped at 70. On a similar basis, you can have set timeout and hit save. You see, timeout also had an ID of 3. So if we increase it to like 5 seconds, hit save, and I say clear timeout of 4. You see, I cleared it before hitting 5 seconds, so the set timeout block never ran, right? And it does not matter if if your ID is not valid, right? So you can write anything here, it won't create a problem here. So it does not really need to be a valid ID. JavaScript is lenient about that. So even if your timeout is clear, you can still run clear timeout anyway nonetheless, and it's not an error, right? So I guess that's all for set timeout, set intervals, clear timeout, clear intervals, and play around it with a little and see what you can create. You can create some really awesome applications using this, and that's all for this one, and I'll see you then in the next video. So what's going on YouTube? My name is Mehul and welcome to your 38th Basics of JavaScript video, and let's discuss event handlers in this one. So what happens is that you would need to sometimes provide interactivity to your web application, and for that you need to add events like clicking elements, double clicking elements, pressing keys, stuff like that. So for those, what we have is something called as event handlers in JavaScript. So let's get straight into the most commonly used event handler, and that is onClick, right? So what you want to do is fire a piece of function when an element is clicked, as simple as that. So I'm going to say that const element, which is my element, is getElementByID, my name, which is this particular thing, right? And what I want to do is when I click on this, I want certain code to be executed. So how to do that? Well, you can say element.onClick, and then you can assign this a function, right? So you're assigning this property of this object a function. Now this function is the function which would be executed when onClick happens. And onClick is automatically called by browser whenever somebody clicks on this element. I'm just going to say console log clicked and hit save. You see, when I click on this, my name is Mehul, we get console logs of clicked, right? 12 console logs. So this was one way of creating an event handler. There's another way directly from your HTML. So what you can do is directly from HTML, you can say within your HTML, let's say I create on click here also. I say on click, and let's just create another function, my function, and say console log something else clicked, right? And copy this, paste it here, hit save. Now if I click on this P, you see we get something else clicked. If I click on this H1, we get clicked, and then again something else clicked. So this was another way of creating event handlers. This is known as attaching an event handler as inline code, right? So you're doing this inside HTML, inside inline the element, so it's called inline event. This we are doing by selecting the element first in JavaScript and then doing it. This is a better approach, a more cleaner approach as well. But frameworks like Vue and stuff actually allows you to have inline events. So this was all about on click. There could be a lot of elements, there could be a lot of event handlers actually, and you can just basically Google them and see their usage. The other one you can use is on DBL click, which is on double click. And if you do that, what you're gonna see is if I double click on this, then I get clicked. See? On a similar basis, we have other event handlers as well. I'm gonna discuss the keyboard event handlers later on in the code. But for now, let's just keep this on click and double click only. So I guess that's all for this video. And in the next video, we're gonna see some more information about this. So what is going on YouTube? Now my name is Mehul and welcome to 39th Basics of JavaScript video, in which we're going to discuss about exception handling, basics of exception handling in JavaScript, and how to work with it. So exception basically means that something has gone wrong with your code and it needs to be addressed. Now sometimes you know a particular piece of code which might create an exception, and you even know how to handle it if there's an exception. For example, if you're creating an application which does a network request to some server which you do not own, then obviously you know that servers can go down and there could be problems. So what you want to do is try to ping that server, and if it works, then okay, execute the code. And if it doesn't, you want to use a mirror server or some other server which basically does the same job. So how do you do that? Well, in JavaScript, what we have is something known as a try-catch block. So what happens basically is inside try, you write code which you think might produce an exception, right? So for example, let's say I get I don't know, let's say we have let I is 100 and let j is 0, right? So what we want to do is basically see that if j is 0, then we do not want to proceed. For example, if you want to just divide, so if j is 0, we do not want to proceed, so we're going to say throw an error which says j cannot be 0, right? And right here inside catch, we catch this error, and hit save. So you see that we do have this exception which says j cannot be 0 because this was an exception. But let's say if j was 2, hit save, then we get nothing. So we can just basically proceed onwards and say I by j. Hit save. You see we get 50 here, right? Because that's the answer. And what would happen if we did not have this thing, this try catch block? Hit save and change it back to 0. You see we get an error that uncaught j cannot be 0, and my nice little statement which had nothing to do with all this code also did not run because of this error, right? But if you have all this inside a try catch block, then obviously it does not matter to my nice little statement, right? It still runs. It still runs even if j is 0. So this was a very basic video on how to use try, catch, and you don't necessarily need to use throw all the time. Sometimes the functions you are creating would throw themselves automatically. So throw basically just throws an error. It is used manually if you want to throw an error, sometimes automatically if JavaScript cannot find something. So for example, one way for JavaScript to throw an error is like selecting an element, let's say which does not exist, ABC, right? And I say its inner text is 100, right? So this element does not exist, so it would return me null. I'm trying to set a property of a null object, of an undefined object, right? So if I hit save, you see we get type error, cannot set property inner text of null. So this element was null, and I tried to set its inner text, and it did not exist, and it threw an error. So I caught this error here, and the nice little statement still executed, right? So I hope this makes sense, and I guess that's all for this video. And if you liked it, then don't forget to subscribe, and thank you for watching. Hey YouTube, welcome to tutorial number 40. This is not really a tutorial, just a closing one for the basics of JavaScript. And if you have made it so far doing all the tutorials, or let's say almost all the tutorials, then it's great. I hope you learned a lot of stuff in JavaScript which you did not know earlier. And fasten your seatbelts because you're about to go to intermediate JavaScript videos, which we're gonna cover a lot more details from the beginner ones, and finally into advanced JS, which covers JavaScript in very depth, right? So I guess that's all for this video, and I'll see you then inside the intermediate JS playlist. The link would be in the description. You can find it and get started with it. See you then.
In this lesson, we're going to be building out our HTML and discussing a little bit more about what the DOM is. So first of all, I've added a simple extension to my browser, and this is the HTML tree generator. And what this does is this gives me the ability to see the DOM of any web page. And as you can see, the way that the DOM works is that it's a series of, let me close that one up. And you can see that it's all the elements on the page are represented within this tree-like structure, and we can easily access them. We see the relationship from them from one to the next to the next. So we've got the parent, we've got children, and then we've got the children's children and the parent of the parent, and so on. So you can navigate your entire web page using this type of format and maneuvering through all of the different elements that are available on your page. So if you actually want to see a little bit more about what's available within the DOM, we can open up our console and we can type in console, and this is console directory, so not console log, and type in document. So this will give you the ability to see the document object, and you can do this on any web page, your favorite websites. Go to it, open up the console and type in console directory. And as you can see, all of the elements on the page are represented here within the document object. And you can see all of the different nodes, the children, and then their children, and so on and so on. And the nice thing about it as well is it highlights all the different elements as you maneuver through them so that you can easily select them and find them available within your DOM. The advantage of understanding how the DOM is structured is it's going to make it a whole lot easier to interact with that document object when you're using your JavaScript. Open up our editor, adding in a div. I'm going to give it a class, so that's how I'm going to select it from all the other elements on the page, and then this is going to give me my connection with JavaScript once I select it in order to update and manipulate it. We're also going to need an input, and the type of input is going to be a number. So we'll set that up, and I'm going to give it a default value of 100. So we're only going to have that one input, so that gives us, again, a way to select it. So I'm just making sure that all of these elements are distinct enough that it's fairly easy for me to select it using JavaScript. So next, let's set up using a button. And then within here is where we're going to calculate the tip amount. So we've got all of the fields that we need. We've got an input number, and then we've got a button that will calculate the tip, that will invoke the event to trigger the function that calculates the tip, and then the output where we're going to output the contents of the tip. So when we refresh our page, not a whole lot happening here. We have the input field, and we've got our button for the tip. And list out the document. Opening up the document object, I'll make this bigger. You can see that we've got child nodes, so we've got HTML as the first child, and then within HTML, I've got several children, or I've got 3 child nodes, so I've got head, text, and body. So this is the contents of the head, and this is the contents of the body, and then inside of the body, we've got child nodes, so I've got 9 child nodes. I've got children here, so there's 4 different children. So there's that input div there's that output div that I created with the class of output. There's the input field that I created, as well as the button that I created. And then lastly, we've got our script area where we're linking to our script code. So you can see that it actually matches exactly what we have on our left-hand side within our code. So once you've set this up, go ahead and set up your HTML page, and you're going to be ready to move on to the next part where we're going to be making use of the data that's represented here on the HTML page and connecting in our JavaScript, and then using that data, manipulating some of the elements on the page. And that's coming up in the next lesson. This lesson, we're going to be selecting the element and the contents of these elements that we created in the previous lesson. So first of all, let's start by creating a variable. We'll just call it temp, and then using the document object. So remember, this is an object, and in JavaScript objects, you can move through the different objects by the dot notation, or you could use the bracket notation as well. So we're going to do dot, and then looking at all of the different children and the methods that are available, we want to use one of the methods that's available within JavaScript, and that's query selector all. This is one of my favorite ways to make a selection. There's query selector and query selector all, and because in this case we're only selecting the one element, I'm going to use query selector. Using the tag button, I'm going to be able to select it within that type of format. And now when I type temp, we can see that the button is the one that gets lit up. So Chrome is lighting that up when I'm hovering over that. And then I can make use of the content that's available with it. So now I've got an object called temp. I can do inner text. And you can see that Chrome gives you a suggestion of all the different available methods. And I'm going to change that to hello world, the inner text. And as you can see, the content updates within the button as well. And this is how easy it is to use JavaScript and manipulate the contents of an element. You can also get information contained within there. And if we just simply type in temp inner text, we can already see that the word hello world is being returned because this is the value of the inner text of temp is hello world. Now let's make use of it within JavaScript within our editor. Opening up our script file. We're going to do the same thing, but we're going to use const because this object isn't going to be changing. And we can use button as our variable name. And using the same format that we just saw, document and query selector, selecting the button element, and now we've got it available within our button variable, and we can output that button variable. So when I refresh the page, you can see that that element now has been output into the console, and that means that we have it within an object format that we can make use of within our JavaScript. So the next step, if we wanted to update the inner HTML or the inner text, we can do inner HTML. And the difference between inner HTML and inner text is that the inner HTML allows you to have HTML scripting, whereas the inner text only outputs it as text format. So we'll update that to say hello, refresh the page, and you can see that now that has been updated as well. So go ahead and try this out for yourself. Open up your editor, make a selection of the element on the page, and update the inner HTML or inner text of the content of that element that you've selected. In the next lesson, I'll show you even more you can do now that we've selected it within an object format and we can make use of it within our JavaScript. So go ahead and try this out for yourself. In the previous lesson, we saw how we can use query selector to make a selection of an element and then make use of that element within our JavaScript. This lesson, we're going to look deeper into query selector as well as query selector all. When we were making our selection, we were selecting via the button tag. And if we had two buttons, so if we had tip number 1 and tip number 2, so the buttons both are button tags, and there's no other way to identify them than the order that they're being represented on the page. So we've got tip number 1, which we're using our JavaScript and transforming it to hello, and then tip number 2, we don't actually see that we transformed it. And that's because we're using query selector. And what query selector does is it selects the first element of the page that matches that specified selector group or group of selections. So if none is found, then you're going to get null returned. So essentially, this is the syntax that we're using, and there's also some additional examples at the Mozilla Developer Network about how you can make that selection. And as you can see, that this is a selection within that same format where we're using ID. We can use classes as well as the tag names in order to make the selection. And all it does is return back the matching tag that is the first element that it finds within the page. Here's an example of how it's using class. And then here we're using query selector with a more complex selector, and this is similar to what you're going to find within CSS in order to make the selection process. If we want to select more than one element on the page, then we can use query selector all. So this returns back a node list representing all of the document elements that match that selection. So if, for instance, we had more than one element that we were selecting, we'll go back here and we're going to transform this and update this to query selector all, go and refresh our page. We see that what's being returned over here is a node list. We've got a number of different elements on the page, and even if we only had one, we would still be returning back within a node list, except we'd have a list length of 1. And we can see that inner HTML is set to hello, but we're not specific on which element we're actually trying to select. And as button has more than one item within the node list, it simply puts the inner HTML to hello within the object of the node list, and we don't actually affect the actual elements that are on page. If we want to be more specific, we have to specify which element we want to select. We can do it within the same array type format where we select the node list starting at 0 index. And if we want to select the second one, it would be bracket 1. So this would be selecting the second element. Correspondingly, if we want to update that inner HTML, we could select it within this type of format. We also have the option, because it's within an array type format, that we can loop through the elements and update them. And we'll show you more on that in the upcoming lessons. But for now, we only have the one button, and we are going to be using query selector. So go ahead and try this out for yourself and create a simple exercise where you've got more than one element that you're selecting, and you still want to select the first one. So try out using query selector all. And of course, if you only have the one element, then you would be using query selector, not query selector all. But go ahead and try this out. In the next lesson, we're going to continue to build out our project. This lesson, we're going to be showing you how to add an event listener, and this is where you can make JavaScript interactive with the elements on the page. We already have our button, and we want to make this button interactive. In the earlier lesson, we saw how we could set the inner HTML, and we're going to update this because we've got the button object. And then within the button object, we've got a number of methods that we can add in. So these are built in within JavaScript, available within every one of these element objects. We can add event listener, and then we need to specify the type of event listener that we're listening for. We're listening for a click, so we want to make this button clickable. And then once the button gets clicked, then we want to invoke a function. We're just going to do an anonymous function, so it's going to be a function without a name. It's going to run anonymously within the event listener whenever the button gets clicked. For now, let's output something within our console, and we can just type in click within the console. Try it out, so refresh, and when we click it, we can see that the click shows up within our console. That means that this block of code is being run every time the button is clicked. Now, we want to also select our output element. So that's going back to our index.html. We have an element with a class of output. So we're going to use the same format as we did before with document and then query selector. And as we've only got that one element with that class, and then selecting the first one, of course, on the page. So grabbing it using the same syntax we would with CSS, where we do a dot for classes, that's going to grab that output into our HTML. And the next step that we want to do is we want to take that output and we want to update the inner text of that output. And we can output that to, let's click out to output. So refresh. So what do you think is going to happen now when I click the button? Going through the code, you can see that we've added an event listener to the object, the button object. And whenever it gets clicked, it runs this block of code. So we're going to console log out the word click. And then we're also going to update the output element inner text to the word output. So let's try that out. So go ahead and click it. And you can see that we've got output being displayed there. So the next part is that we want to add in and grab the value of our input field here and output that into our output area. So I'll show you how to do that in the upcoming lesson. You can go ahead and give it a try, and I'll show you the solution coming up. So next challenge was to grab whatever the value of the input here is and output it within the output class element. Try it out for yourself. This lesson, we want to select the value of this input field and output that value into the inner text of output element. So let's first of all grab our input value, and we can call this, let's call this cost using document. We're going to use query selector again. So query selector, making a selection of that element, that input field. So going back into our HTML, we see that it's input type number, and we only have the one input, so we can go ahead and just use input, just as we did with button, selecting that input. And now what we want to do is we want to get the value that's associated with it. So the value in here is not the inner text or the inner HTML. This is just dot value within that object. So instead of console logging the word click, we're going to take the cost object and output the value that's associated with it. So try that out, and you can see that we're getting the value of 100. So what happens if we update it to 100,000 or 10,000? We're still getting that value added in there. So whatever this value is at the current time, even though we're using const, we're relating it to that object, and within the object, we can update the values and have it put out an output here within our JavaScript when we're listening to the add event listener. The other option as well is that oftentimes you're going to find this placed within the actual event listener. So you can do that as well in grabbing that input. So you're always going back out to that element and making that selection in case something has changed. So in case you've got some more dynamic content within your page, you might want to place that within the add event listener as well. So for now, what we'll do is we'll add it into the add event listener, but as you know, you can keep it on the outside as well within the global scope of this object. So now that we've got the value, we can take that value and we can make some calculations on that value. So going back into here, we've got our value and we can make use of that value. So if we were to take our value and we wanted to multiply it 15% is of whatever value is entered in there, when we press tip, you can see that within the console we're outputting 50%. So what happens if we if we add in a decimal in there, you're going to see that we're going to go to a dollar value, but we've also got more than 2 decimal places in from the cents. And there's a way to fix that, and I'll show you that in the upcoming lesson using a JavaScript method that will limit the number of decimals that we're going to have within our value to 2. So that's coming up next. So go ahead and try this out for yourself, get the value of the input, and then you can make use of it within your JavaScript. So try it out. Within this lesson, we are going to be finishing off our tip calculating project. Let's add in a new variable. I'm going to call it temp, be essentially our template for our output. I'm using single quotes within this one because in case I want to use double quotes within my HTML, I want to fine tune it. And I'm also going to update the output to be inner HTML as well. So we can write you should tip and then have a $sign value there. And then we can break out of the string. So this would be whatever our tip value is, and then break back into the string with a single quote on, and then this is the total number of, or total cost that we're calculating that tip upon. So close that off. We need to create those variables. So tip will contain a value of what we were outputting in the console, and we want to update this and fix it. So we're going to use toFixed. And essentially what this does is it formats the number to a fixed point notation. And with currency numbers, we want to account for cents. So we want to move in 2 decimal places over to account for the cents. So that's going to give us a value for the tip. And then we already have that value for the cost as well. So let's save that and refresh. And let's do tip. And then we need to still update this to inner HTML, and the inner HTML here is going to be whatever the value of temp is. So refresh, tip, and we get an output of you should tip $15 on object because we don't have the value there. So make sure that we add in value there. Try that one more time. You should tip $15 on 100. Type of format, we can calculate out whatever the tip is going to be. So even if this has cents attached to it, you're going to see that it outputs here within that cents format as well. And we get the tip being calculated on the total value that's input within that input field. In the upcoming lesson, I'll show you how you can template this, and this is going to make your code a little bit neater as well. So templating, what that does is it allows you to bring the object in without having these breaks out of the string value. So that's coming up in the next lesson. So go ahead and try this out and make sure that your tip calculator is functioning. We have a fully functional tip calculator. We wanted to add in one more thing in this lesson, and that's going to be setting this up using a template type format. So get rid of the single quotes and adding in backticks. The backticks are available above your tab, and they look like this. And as you can see, it opens and closes and breaks out of the string value. And then we can also still use that same string format, but it's including all of that content that we had here within the $sign. So in order to break out of this $sign, we can use the $sign, and then we've got $sign, and then this is breaking out of that tick object where we're using the $sign. And within here is where we can add in the cost value, or actually this would be the tip value. So just type in tip in here. So let's refresh and see what that looks like. So now we've got tip of $15. And typically you only need the $1 sign, but because we are outputting values and money, that's where we've got the $2 signs. So in order to get that object, it's $sign, curly bracket, and then whatever the value of the variable is. So in this case, we're doing a $sign, curly bracket, and we're just updating this cost value into be contained right within there. And as you can see, that brackets actually outputs them within those variable values instead of having it within the string value, which is orange within my interface. So let's try that out one more time. You should tip $15 on $100. So this is a great way to make your code much neater, and also gives you the ability to use single, double quotes without having to use the backslash in order to break out of them. So I'll just show you how that works. So try that out one more time, and now you can see that we've got the double quotes and the single quotes, and we don't need to break out of it. The backslash break just simply adds in a space there as well. So go ahead and try this out for yourself. Get comfortable with using the backticks and the templating format for JavaScript. This is going to be a quick lesson on my developer setup. So in the upcoming lessons, you're going to see that I've got my editor opened on the left-hand side, and the editor that I'm using is brackets. And I've got my browser opened on the right-hand side, and the browser that I'm using is Chrome. So we do need a way to create our index.html file, as well as to see it rendered out. If you are looking to use the same editor that I'm using, you can download it. It's open source, available at brackets.io. It's an Adobe product. It's a pretty good editor. If you already have one that you're familiar with, you can go and use that one as well. So the editor, it doesn't really matter which one you use. We're just simply writing in the front-end code and rendering out in the browser. The browser that we are using is Chrome. Most browsers will have some format of developer tools. What developer tools do is they give you the ability to communicate, debug your application, and communicate between the code that you're rendering out and the browser window. In order to open up DevTools in Chrome, on a Mac, it's Command-Option-C. On Windows machine, it's Control-Shift-C, or you can go ahead and click the three dots in the top right-hand corner, More Tools, and then select Developer Tools. And that will open up this window that I'm going to have open throughout the upcoming lessons. There are some prerequisites to this course, so having a solid understanding of HTML and CSS is important, as we're not going to be covering that, and this is just supplemental in order to produce a better looking application. Prerequisite to this course is JavaScript. So having a fundamental core understanding of JavaScript is a prerequisite to the upcoming lessons, as they are focused on building out an application and applying JavaScript, and you should be familiar with setting variables, interacting with the DOM, creating functions, adding conditions, and essentially the core fundamentals of JavaScript. So it is highly recommended that you have that before you begin the upcoming lessons. Source code is also included, so after each lesson, I'm providing source code of that lesson, so you can copy and paste it in your own editor and run the code, try it out for yourself. Welcome. In this lesson, it's going to be about building out our HTML structure so that later on we can incorporate all of the gameplay that is necessary in order to produce our application. So starting out, we're going to create a div. This is going to be a main div, calling it, giving it a class. We're going to assign a score there. So this is where we can output whatever the score values are that we want to show. Also setting up another class, and we can give this one a class of game. And then within here, we can show all of the gameplay. Creating one more div. So inside of the game class div, gonna create a div, and this will be the start screen. And then here is where we can have all of the welcome message and start button and so on. So we'll add that in as well. Next, creating a class and adding to this class, we're going to call it game area. And so this is where all of our gameplay will take place. So we're going to swap between the start screen and the game area once we start the game. I'm also going to create a basic class. I'm going to call it hide, and this is going to have one property where we're going to use display none. So that way we don't show both of those, and we can add and remove the hide class as needed in order to show different screens to the player. Next, we're going to use JavaScript to connect to our elements on the page. And within the start screen, we're going to add in an event listener, so when the user presses the start screen, it can start the game as well. So selecting the various elements that we have on our page, I'm going to use const, and for the score area, using the document and query selector, we're going to select the element with score and output that into the JavaScript score object. selecting our start screen, using document query selector. We're going to select the element with a class of start screen. And you don't have to call them the same. You could call them something different as well. And next, selecting our game area. And I'm just going to call it the same thing so that we have some consistency. Query selector, and selecting the element with the class of game. So once I've made these selections, I usually like to double check and make sure that we are accessing them properly. So opening up your developer console, we can type in score. We see that we access that div. Type in start screen, see that we access that div, and then game area, just to make sure that we're accessing the right divs, so that coming up next, we can focus on the JavaScript and create all of the interactions that are going to be necessary in order to produce the gameplay. So one last thing that we wanted to add in before we conclude, and that's adding in an event listener to start screen. And this is going to be a click event. So whenever the player clicks the start screen, where we've got that welcome message, this is going to trigger off the game start. And adding in a function, call it start. So this is where all of our gameplay will start. And we'll take a look at that and we'll build that out in the upcoming lessons. So go ahead and set up your default HTML, add in classes as necessary within the styling, and then use JavaScript to add all of those elements as objects, usable objects within your code, so that you're ready to move on to the next step. And then also test out that click event, so that make sure that that is functioning. And the way that to do that, usually I put a console message into that function, so I know that whenever I'm clicking it, it is being invoked and it is working. So go ahead and add that into your project, and you're going to be ready to move on to the next step. This lesson, we're going to be adding in more event listeners, and these are going to be the key press event listeners. So whenever the player presses a key on their keyboard, it's going to invoke these key press functions. So setting up our document, adding an event listener just as we would any other event listener, and the event listener that we're listening for is key down. So anytime somebody presses on the keyboard and presses down on the keyboard, where they're located, the focus is located within the document, which is everywhere, the whole page, then we are going to be invoking our function. We'll call it press on, and then we're going to also do another one for press off. So we're going to be able to detect once the player presses the key, and then once they let go of the key, and using key up method in order to accomplish that. Our press on function, and we need to listen for the event object. So we're passing that in as a variable e, and we can also prevent the default action by using the JavaScript method prevent default. And I'm going to console log out the value of event key. And within this event object, we're passing quite a bit of information, and we're going to be making use of determining what key was pressed whenever the key was off. And as well, we're going to take the key that was last pressed and we're going to output that into key off. And I'm going to comma separate this out so that we can distinguish between the two functions. So let's try that out. So refresh. And now whenever I press the key, I can see that I've got key on and key off. And what we want to do for this is we want to toggle a function that determines which way and which key is actually being pressed, so that we can take some type of action depending on what key is pressed. And we also want to have the ability to press multiple keys at the same time and check to see what those keys are and how they're being invoked. So in case we have multiple keys, I'll clear this out. And this time I'm going to press the up and the down at the same time. And you see when I lift off of one and then I lift off of the other, we get that off function invoking. And that's how we can detect whether the player is pressing one key, two keys, and depending on how many keys they've got pressed, we can take the action accordingly. Set up an object to track which keys are being pressed, and we're going to use the same values that we've got for the key names that we're seeing here being indicated within the console. So setting up an object, and we're just going to check to see if the key has a Boolean value, so whether it's pressed on or off, and then we're going to take actions accordingly. So using arrow up, let's set that. So by default, we're going to set them all to be false. And this way we can handle multiple key presses at the same time. There's also arrow right, so default for that, of course, false. And then the last one that we're going to be tracking, and if you want to track additional key presses, you can do that as well within this type of format. So you could track as many keys as you wanted to within this keys object. So the last thing that we want to do is, instead of tracking that the keys have been up and down, we're going to simply take that key value from the event key and add within that key object, setting the E key, so corresponding to the string value of E key that we saw output within the console. We'll set that value to be false. And we need to do the same thing for onClick. So we set it to be true in this case. And you're going to see that now we're toggling between the Boolean values, and we know exactly which keys are being pressed. So while I'm pressing the up arrow, I see that we've got up arrow true. If I'm pressing left arrow, we see left arrow is true. If I push another key, so now I'm pushing the left and the right arrows. So arrow right is true, arrow left is true. And we've got full control, so we can have as many keys pressed as needed within our application, and we can track all of the key presses. So go ahead and add this into your application, add in the ability to track what keys are being pressed, and also set up an object, you can call it keys as well, that tracks which keys are being pressed. And coming up next, I'm going to show you how to introduce gameplay, and we'll create an object that will move around depending on what keys are pressed. This lesson, we're going to be looking at a JavaScript method called requestAnimationFrame. And what this is going to do is this is going to allow us to have a method that allows our browser to understand that we've got an animation frame. And essentially what that does is it allows you to loop through multiple times within that same function. And the way that it works, we've got an example here on the Mozilla Developer Network. They've got start to equal to null. Then we've got our element there. So whatever that element is that we want to animate, it's making a selection from the HTML. And then using a timestamp, so down below, it initiates that function window request animation frame. And we know with Windows methods, we don't need to specify window, but it's always a good idea to do that anyway. So sometimes you might see the request animation frame without the window prefixing it, and that's okay as well. And in this case, we are going to be using window request animation frame to request our animation frame. And what it does is it invokes a function, and the function that's going to invoke is going to be over here. We've got it running on a timestamp. So in this particular example, it's going to be moving that element around, and depending on how far this progress is and tracking the current timestamp and the value minus start, it's going to be transforming that particular element. So this is a really neat example, and you can go ahead and you can try this out for yourself. And we're going to bring the request animation frame into our application and add it into our application, making animations happen. So setting up a brand new function, and then this is the function where all the magic is going to happen. We're going to call this play game, and this is the function that we're going to request. So with the console log in play, and once we hit that start button, so we've got the start function, this is where we want to invoke the request animation frame. So using the window object and then request animation frame. All we need to do is specify what the function is that we want to request, and the function that we want to request is the play game function. So now let's see what happens. So we hit start and we have in play. So it's not exactly looping quite yet, and you see that what's happening here is that within the animation frame, they're requesting that animation frame again, and that's what actually creates the loop of the animation. So just as any function that we're invoking within itself, it's going to constantly loop and create additional animation frames. So we've only got one animation frame that we're animating right now, and now we're going to invoke that same function within itself. And what that's going to do, when we go back out here and we start it, we see that we've got an animation happening. So now we can also check to see that if the game is in play. So let's set up a variable. We'll call it player. So this is going to be a blank object. And once we start the game, then we're going to take our player object, set start to true. And then in our animation frame, we're going to take our player object start and we're going to make sure that that is true. So we're not going to do anything unless the game is actually started and in play. And we're not going to request any additional animations or anything unless this function is true. And really at the end of the day, it's not going to make much difference because we are setting the player start to be equal to true before we're calling the play game. And that's why we don't see any difference quite yet. So now that we've got that in play, the next part of this is to add in that animation and make something move. So what we need to do is we need to create an element that we can access and we can move around our screen. So going into our game area, this is where we want to place that particular element. So we've got the game area object that we created earlier, and we're going to use JavaScript to generate our car or our vehicle. So setting up a variable, we can call it car, and document, creating an element. So in this case, we're creating an element, and the element that we're going to create is a div. And then adding into car, I'm going to update the inner text. And for now, it's just going to say car inside of it. And then using that game area object, we're going to append a child to it. And the child that we're appending is the car. We're appending a child, and currently right now, we still have the class of display none being shown, and we need to hide the start screen. So that's the next function that we need to do as well within the start area. So once we start the game, we can get rid of the console message now because we're not going to have that in use anymore. So taking the start screen, selecting class list, we're going to remove a class from it, and the class that we're removing is hide. And also what we want to do for game area is we're going to select class list, and in this case, we're going to add the class of hide. And actually, I just got that opposite. So we want to add hide to the start screen, and we want to remove hide from our game area. So let's try that one more time. So now we've got that element that we've created. You can take a look at it. And this is the one that we're actually going to be moving around. So that is still yet to come in the upcoming lessons. So I'll show you how to do that, how we're going to make car, that element that we created, move depending on the arrow keys. So that's still to come in the upcoming lesson. Try out request animation frame, add it into your project. So when the game starts, you've got an animation that's playing, and you've got a function that's handling all of the gameplay. Welcome back, and this is the lesson you've all been waiting for, where we're going to make something happen on screen. We're going to take our car that we're creating, that div that we've just created, and we're going to move it around on the screen. So there's a few things that we need to add and prepare for. Adding it in as a position absolute. So of course with CSS, position absolute gives us the ability to provide left top coordinates for the positioning of an element. We can also position it from bottom, so do that. And for now, we're going to set bottom to be 100 pixels. And we'll also position our left position. So our left position by default will be 200 pixels. I'm also going to take the opportunity to set a width of this particular element. So setting the width of the element to be, and setting the height of the element to be 150 pixels. Also background color, so whilst I'm adding in content here, so we'll have our little blue car, and I think I'm actually going to make this a little bit smaller. And now next, what we want to do is add that class into the element that we just created. So where we've got our car that we created in the last lesson, this is a car object of the div that we're creating dynamically. We're going to use set attribute, and the attribute that we're setting is a class. So you can do this if you don't have any classes already added to that element. You can just set a default class, and the class that I'm going to be setting is car, the one that we just created. So let's try that out. So there's our blue dot or blue square, and we want to ultimately now move that around the page. So we see that that's a fairly long and big car. I'm going to make this smaller because I do have the screen zoomed in. So I can zoom out a little bit on the screen so that it's a little bit more manageable. And well, that is a long car, so we don't want to make it a limo or anything like that. So I'm going to shorten that a little bit. There's our car, and we want to move this element around depending on what keys are being pressed. And we already have the play game function operating that we set up in the earlier lesson. So now it's a matter of determining what key is pressed and updating that element position. So selecting our element, we've got our request animation, so we can keep that at the end. And now we need to apply some conditions. And within our conditions, we're going to check to see the value of keys. So using that key object, we've got several objects there. So we've got a key up. So selecting the element using the document object, query selector, and we're selecting the element with a class of car. So that's the one that we just created. So now that we have it, so we need to also add in to our X and Y coordinates. So taking the player object, we're going to have a value for Y. We're going to increment this value with, for now, let's do a value of 5. And we can also set a value here. We can set a speed value there. And then we can use that speed in order to control how fast their element is moving. And as we're building it out, we're going to grab the X and Y coordinates of this particular object. So arrow down is going to decrease that. Arrow left is going to update the player position, so decreasing the X coordinates. Arrow right is going to increase the X coordinates. So we've got a variable that we're tracking in the background that's going to be player X and player Y. And I'll show you how to add that as well into our object. And so as we're generating the car, we can take our player X value and set it by calculating where the car object is and getting its offset position. So we can get its offset left position. And we need to do that after. And then player Y value is going to be car, and we're going to use offset top position. And we'll console log out the value of player so that we can see what the value here is. So when we start the game, preset some values. And you can see that all the way up here that we're setting the value of X to 200 and Y to 280. And this is actually going to correspond with the positioning of this particular element. Now that we know which key is being pressed, we can adjust the position of that particular element. So now it's a matter of taking the car and updating that element style, updating its left position to be equal to player X plus, so that those are always matching. And we'll take also player style and top position and equal that to player Y plus pix. And you can also double quote those as well. So let's try that out. So now when I press my arrows up and down, and actually down is moving it up. So we need to adjust that up and down. So that was a little bit of an adjustment there. So now whenever I press, and I can move up arrow, down arrow, left, right, I can also move them together at the same time and have multiple combinations of movements. So this is how you can create an element that moves around on the page depending on what arrows are being pressed. So coming up next, we need to extend on the gameplay. So go ahead and add this into your project. Try it out for yourself, and it's a matter of tracking those positions, and then we can update them over here. And it's if we need to make some additional updates to these values, that's why I kept them separate, because we could have as well tracked the position, current position of car. But I usually find doing it this way is a little bit more easier, and it's a little bit more clear as to what's happening and easier to read. So that's why I introduced that second variable under player, where we're setting that value to wherever that particular element is located off the offset left and offset top. And then I'm introducing that positioning so that both of those match. And we're updating the player X and player Y position instead of the car position directly. So go ahead and add this into your project. This lesson, we're going to be adding in a road for our car to drive on. So I'm updating the default positioning, and I'm going to take margin auto so that it automatically centers on screen, because that's where I want to position the road as well. And the road is actually going to be the entire game area that we're using, that we constructed earlier, setting up a background color for it. And we'll set up a background color of black. And this is the width of the road. How about we do 200 pix width? And the height of it is going to be 100%, so going right from top and bottom. We'll hide any of the overflow of that element. And we're going to position it. We're positioning it relative. And also center it, so margin auto will center that road. So let's refresh and see what we got. So we've got a car on the road, and our car can actually move off of the road. So we need to take care of that and handle that the car is moving off of the road. So now we can detect that using our JavaScript. We can detect a bounding box. So, or we can just call this road and equal that to the game area. So that's, remember, the road that we set up earlier. This is the game area, or the road, in other words. And taking that road value, so we're setting it up and taking game area, we're going to use a method called getBoundingClientRectangle value. And what getBoundingClientRectangle does is it essentially gets the size of an element and its relative position to the viewpoint. A getBoundingRectangle value, and that's going to return back the top, right, bottom, XY, height, and width of that particular element. Going into our code, when I console log out the value of road, you're going to see that this isn't within an object format, and also going to get rid of the in play. So refresh, click it, and you can see now we're getting the bounding of the road. So we know where the X and Y position is. We also know the width of it, the height, and the top. So know quite a bit of information. We also know where the right position, top, left position, bottom position, and all of this information we can then use in order to determine where our code boundaries are. So we don't actually need it to restrict the left movement, because the left movement is going to be located at wherever the position of player X is. And we see that by default, if we list out the value of player X, it's going to be 0. So we just need to make sure that player X is greater than 0 before we try to subtract off of it. So try that out, and we see that it is 0. So now we can't move off of the left side of the road. We also want to make sure that we can't move off of the right side of the road. So again, that player X value, and adding it in. So whenever we're moving along the horizontal line, you see that the player X value is, once it hits roughly around 145, then that's where we need to stop that from moving over. And when we use that bounding box, I've got a position there of left position and right position, and I also have a width. So we want to make sure that the position of X doesn't exceed the width position of the particular road. So taking X and making sure that X is less than, let's try that out, and now we can move it to the right, but we see that we're still moving off to the right, and we're going all the way to 215. So we need to make one quick adjustment, and that's calculating out the width of that particular element, and we know that we did set a default width, so we can just use that 50 pix. So minusing off of that value, road minus 50. So that was one quick adjustment, adjusting for the width of that particular element, and now we see that we can't move off of the side of the road. And it actually is a little bit bigger, so let's do 60 pix. We'll try that out, and just make sure that we're not able to move off of the side. Where instead of road X, we could do road width minus 50, and that will give us the exact position to the right-hand side. So we also need to make that for what the up arrow and what the down arrow is. And in this case, we want to try to box in the player's movements to a particular area here. So we don't want them moving all the way up to the top. We don't want them moving all the way to the bottom either. So we want to restrict some of that. So let's take a look at that code and add in some additional values. So over here, we're incrementing the value of player Y. So taking the value of player Y, we want to make sure that the value of player Y going into our rectangle, our bound rectangle, we want to make sure that it's less than the container bottom, and we're not going to go underneath the bottom. And we can do something else for the top as well. So making sure that player Y is greater than, and we've got a value for top. So let's do that. So adding road top value. And now we can move to roughly around somewhere close to the top, and we can't move to the bottom. And if I make this bigger, so if we refresh, we're still restricted to whatever the current size of that particular bounding area is. And also it allows us to have some flexibility with our app as long as we're not moving off of the side of the road. You can see that I'm still bound to those restrictive conditions that we had earlier. So go ahead and add this into your application. So we've added in a road, and next we need to make it look like a road. So that's coming up in the next lesson where we're going to build this out and we're going to put lines that are going down. So that's going to indicate that this is an actual road. That's still to come in the upcoming lesson. In this lesson, we're going to add in some road lines. First of all, going into our CSS, let's create that line. We're going to position the line absolute, just as we did with the car, because it's going to sit on top of the road. And background color of the line is going to be white. So now we need to add the lines into our page and move them along as the road is moving along. So we've got our car. I'm going to get rid of these console messages. So now we can focus and track on the lines themselves. And I want to have the lines moving down the center of the page. So as we start the game, this is where we can generate the lines and then add them dynamically onto the page. So just before we build out the car, so the car can go on top of the lines, we're going to build out the different lines on the page. So creating a loop, setting x to 0, looping while x is less than 5. How about we create 5 lines so we can break out of our loop? And then here is where we're going to create those divs using what we did before with document, create element. And the element that we're creating is a div. We're going to add a class to the div. So using that div object, we can this time, we can do class list to have something different. Class list add, and we're adding the value of line. And then we need to set a position of it. So this is the default position of where we're positioning the line. So setting that up to be, and just as we added in positions here for style top position, we can do the same thing for the line. So style top. So let's set the top position to x times, so we're generating out all of the different lines there, and then setting them as pixels. And then lastly, we need to append them to our game area. So just as we did with the car, we're going to append the line to those. So try that out. So welcome message, and we get a bunch of lines there. So they're not exactly being positioned center. So we need to make sure that they are being positioned center. So going back to where we set the positioning, so instead of margin auto, we'll do margin left. And we know the road width is 200 pixels. Our width is 10 pixels. So we're going to divide that in half. So that's going to give us a left margin of 95 pixels. So now we've got our lines for the road. Got 5 of them there. If you need to create more, you can create more as well. And we need to get them moving. So the next lesson, we're going to continue to build out the lines, and we're going to have them moving as the game is looping. And as you guessed it, we're going to place it within the animation frame where we've got the play game. And this way we can select all of those elements with the class of line and update their positions. So that's still to come in the next lesson. So go ahead and update, add in the CSS for the line, generate them once we hit the start button, and I'll show you how to get them moving in the next lesson. This is the second part to getting the lines moving. So as we see, we've got lines on our road, but they're not moving. So we need to get them moving. And the way that we're going to get them moving is within the play game. We've got a number of options that we can move them along. So we can set up a loop here, or we can create a function to move the lines. So I prefer to create a function that's going to move the lines. So we can invoke that and have that completely separate of the movement of our car. So setting up that function that's going to move lines. We need to use query selector all and select those elements as an object. And we created those elements with a class of line, an object called lines using document. In this case, we're using query selector all because we want to select all of the elements with a class of line. And then we can loop through all of those elements. Let's loop through the lines object. So this is a node list, and we can use the for each to loop through each one of those items. creating a function, and we can grab those by using item. And we're going to need to have a variable for its y position. So just as we set it for the car, we can also set it for our line as well. So as we're generating out those lines, we can take the element and we can give it a y position. And that y position will be whatever the value of x times 150 is. So that's its starting position of y. And then we can use that value of y. So as we're looping through, we can see console log item, and we can see a value of y for each one of those items. So just make sure that it is working. So we see that we've got all of those value of y's, and we can do a condition to check if item y is greater than 750. And if it is, then we're going to reset the value of item y to be 0. Or we're going to actually set the value of y to minus 750. And then what we need to do is we need to set the value of item style top to be equal to item y plus pix. So just as we did before. And then we take item y, and we're going to increment it by the value of player speed. So let's see how that looks. So start that up. And actually, this is reversed because we're adding to it, so we're not setting it equal plus. If we do it that way, then it's always going to be 5. And the same with this one here. We need to minus the 750 off of it. So let's refresh. And so now we see that we've got these lines that are running, and they're running all the way down. So we actually need to do something a little bit different as well for this. So maybe let's subtract even more off of it, so we can do 1,000 off of it. Let's try that one more time. So let's create some additional lines. So create 10 lines. And so that's going to be a max width of 1,500. And so now instead of checking for 750, let's check for max of 1,500. So now we've got all of the lines showing up. And we also have our car moving. So we've got it moving across the lines. So notice that it's on top of the lines because we added that element afterwards. So go ahead and add in the lines for your road. And coming up next, we need to create some cars that are going to be obstacles within the game. So that's still to come in the upcoming lessons. In the earlier lesson, we generated lines. Now we want to generate some additional cars that we can use and output those values to the player. So we've got our lines, and when we refresh this, so to break out of that, going back into our application, into our CSS, we should create some additional cars as well. So we can just call them enemy. And we're going to update the background color for them as we're generating them out. So they're going to have the same properties as our initial cars, so they're the same size, and they're going to have the same feel and look to those. So going into our application, so just as we created some lines, we should also create some additional cars. So within the start game, we created our lines here. Let's take this, what we did earlier, and also create, instead of just having the player, we're going to add in and add some cars as well. So we'll call them enemy. So these are divs. And these are the enemy elements. And we surely don't need 10. How about we do 3 for now? And we're going to generate them to have y to be equal to. And I want to start them off at a negative position so they're not already on the screen. So have them at y minus, and let's use a random value here for that we're going to generate out. And we're going to use the JavaScript math function. So math floor math random times 200, or let's do times 500. And then we're going to multiply it by -1. So this is going to give us a random position for I of that particular element. So they're all essentially going to be off screen once we start up. And add in the enemy Y position there as its starting point. And then add them into the game area. And also going to set the background color so we can distinguish them to style and background color. So we'll set them all to red for now. So they're all red. Now we need to get them moving. So just as we moved the lines, we can create a function in our play game to move our enemies. So move enemy. And I'll copy out the function where we move the lines. And instead of move lines, update that to move enemy. And selecting those elements that have a class of enemy, just going down to make sure. So instead of adding a class of line, we need to add the class of enemy to them. Give it more of a generic object name there, so element. And we can keep item there as well. And instead of subtracting 1500 from it, let's update this and set it to be equal to, we could also keep the subtracting of the 1500. And we also need to add in the positioning of the item to the left. So adding in a style left. This is where we can use math floor and math random. And let's multiply it by 150 because we know we've got 200 width for the road. Don't forget to add in the pix. And then we've got 50 width for the width of the car. And we also need to use this down where we've generated the element. So not just top, we need to also specify that we are adding in left position, so they're not all within that same line. And we can generate this randomly as well. So instead of having the math value here as random, so we can space it out a little bit better. Gonna remove that and set this to x plus 1, and then multiply that by a value of 600. So that will space out our enemies a little bit better. And we can keep the enemy y value the same. So now you can see that they've been generated and there is spacing between them. And they're always randomly positioned, so either on the left or the right. And then that one kind of showed up a little bit unexpectedly. So we need to also take that into consideration where we're going to multiply it and we're going to subtract out 600 from it. So going up, just do a quick adjustment here. And we're going to set the value of y to be -600. So try that out, run through that one more time. And now we've got some better spacing between the enemies. And you can see that they're always coming right off of the top. So go ahead and add this into your application, and you can be ready to move on to the next part where we're going to be doing collision detection. And that's going to be wrapping up the game where we're going to check to see if this car is overlapping any one of these enemies. And if it is, then the game's over. So far, we've built out the basic structure of our game. We've got some enemies there, and we need to be able to check to see if collisions are happening between the different elements on the page. I'm going to remove out all of the console messages. So save that so we don't have an overwhelming number of console messages, and we just want to simply detect if there's a collision taking place between the two elements, so the enemies and the current car. Creating a function. We're going to create a function to check to see if it's collided. Call it is collide. And we're checking to see element A versus element B. First, selecting our bounding client rectangle of A using the same function that we used earlier, where we get the bounding client rectangle. That will give us all of the parameters that we need in order to detect that collision. And next, we can do rectangle and set that to the same thing where we're getting the bounding client rectangle method. So now we've got the overall top position, bottom position, right, left position, and we need to make a determination if there's any overlap. So we're returning a value, And we're checking to see if the overlap is positive, and if it is, then we're going to be returning back a value of false, but we want to show a value of true. So checking to see, and that's why we've got that negative there, to negate the true and turn it into a false value if there's no collision. And if there is a collision, then we're going to return back true. We need to check all of the corners. So taking a rectangle and the bottom corner, we're going to check to see if the value of a rectangle bottom is less than the value of B rectangle top. So that's going to check the top corner of rectangle B, bottom corner of rectangle A. And so we know that if those are matching, we also want to check to see if there's an overlap rectangle top, and if it's greater than B rectangle bottom. So that's going to take the other corners, the opposite corners, and check those. The other condition that we're checking, so we need to check the left and right position. So we're checking the top and bottom values to see if there's any overlap. And next we're checking the A rectangle right position. And this is the opposite of the top and bottom. We're going to do the horizontal positioning and checking to see if it's less than B rectangle left. So see if there's any overlap there. And then there's one last value that we need to check to see if there's any overlap. So we need to check to see if rectangle A's left side is overlapping rectangle B's right side. Let's try that out, and we need to send over those values. And we can do that as we're moving the enemy. So we're looping through all of those enemies, and we can also get the car value that's available here. So passing in the car object, so we don't have to select it again. We're going to take that car value and make use of it within our loop here. So passing over those values, we're going to check to see if car and if item, and if they are colliding, then we're going to output in the console. So we see that once they're overlapping, we get a hit displayed in our console. And if there's no overlap, then we don't get anything. So now we know that we are able to detect the collision. And this is the collision on each and every one of the enemies. So it actually doesn't matter which one we're hitting. We're always getting that collision. Because we do have that bounding box for the car, and we also have the bounding box for the item. So once we have a collision, then that's where we need to stop the game and show the player that the game has been stopped and that they've hit and made a collision. So coming up next, I'll show you how to do that. So go ahead and add in the collision detection into your application using the getBoundingClient rectangle and checking the horizontal as well as the vertical top and bottom positions of both of those elements on the page. We need to add in some scoring into the game as well as a way to end the game. So we know that once we've got a collision, that's when the game is over. So starting out with the scoring, let's update and add in the score for the game. We've already got a score element on the page, and we've already connected it to a value of score. And within the player setup, I'm also going to set up a value of score, set it as default. And then when we start the game, what I want to do as well is take that value and set it to player score is going to be equal to 0. So this is our starting position of the game. So once the game is in play, every time we loop through, I want to update the score. So every time we're running through that function play game, before we conclude, I want to update the score. So let's add that value in. So that's player score, and we're going to increase it by 1. And then using the score object, we're going to update the inner text of that element to equal whatever the value of player score is. So try that out, and we see that we've got our score calculating there. Add in a little bit of styling for that score. So background color, and we'll set that background color to be black. Also, let's set up a height for that. So height of, and text align, we'll center text align that value. And also we need to actually see the score, so let's update the color of the score to be white. So there we've got our score value, and that's always increasing. And we can also update that to say score to make it more evident what it is that we're outputting there. So as we're playing the game, score, and increasing the player's score. I'm also going to make the text a little bit bigger as well. And of course, you can style this as needed. This is just some default styling. And also, I always like to add in the font family, so we could add it in as fantasy. So we've got our score ever increasing in value. And then once we hit the collision, that's where we want to stop the game. We want to stop all of the gameplay. And we do have a function in order to handle the end game. So let's create that. So end game function. So we've got our hit, and at this point we want to end the game. So when we start the game, ending the game is going to be fairly opposite to that. So we're just going to build that down here where we've got the start button. So function end game. Let's generate that end of the game. So player start is now going to be false. So that's going to stop the looping. And where we've got that animation frame, so it's going to stop it from continuously looping through. So try that and make sure that we do have a way of ending the game. So that's essentially our game ending part there. We can also update our message. So our score and inner HTML can say game over. And I'm going to do a line break there. Score was, and then whatever the value of score is going to be. And that's again held in player score. So we've got our score. Score was 104 and game over. So we've got all of the messaging that we need. I'm going to make this a little bit bigger because it looks like it's running out of the overlap there. So the score, again, we'll adjust that slightly. And sometimes that is the case where you do need to make adjustments as. So now what I want to do is I want to add the ability to start the game once again. And we can do this in a number of ways. That we want to have the ability to initiate, again, a brand new start screen. And I'm going to create a button in order to accomplish that. So we can add that into our score area, or we could simply add that on top of take our start screen that we hid when we press the start button. And instead of hiding it, we're going to remove that class of hide. So we'll have our start screen once again. So once we have our collision, we get our welcome message again. And I want to update some of the styling for that. I'll do a margin auto so that it centers the content. And for that, we also need a width as well. So let's set it to 300 pixels. Let's try that out. Welcome message. And let's see what happens when we get a collision. So there we go. We've got our welcome message again showing up there. Instead of welcome message. And so there we go. So we've got all of our gameplay and all of our score and our information being output into our game. So go ahead and add this end game function into your game. And we should also have a way to start the game again. And as we can see, it's not really starting well. So that means that we need to remove quite a few elements when we hit the start game, just to make sure that everything is emptied out. So going into our start game, and we're going to take care of this in the upcoming lesson so that we can actually restart the game by clicking the button. And we've got a few things that aren't working exactly as needed, so we need to take care of those in the upcoming lessons. So that's still to come. We've created a way to end the game, but we don't have a great way to restart the game. So we see that once we get the restart content, but we're generating a new car, and there's quite a few things that are happening there that we don't actually need happening within the page. And that's because our game area, we're generating a bunch of stuff that's already existing. So I want to select game area and update the inner HTML and just simply remove out all of the content that's been available there. I'm also going to be removing out the hide of the gameplay, as we don't need that anymore because we actually do want to see the road in the background. So let's try that out. and refresh it. And when we hit start, let's see what happens. And now we can hit start again, and we're able to start the game once again. And we can always restart the game because now we're zeroing out what we're building out within the gameplay. So we're not adding any extra cars, and we're not adding to the confusion of what's happening within the gameplay. So we need it to always clear out and reset it back to its initial state. So just quickly go through that, and you can see that we're setting that animation frame. We're creating the car. So all of this is being done, and it's resetting basically all of the parameters of the game and rebuilding all of the elements that we're using within the gameplay. So by clearing it out and setting the inner HTML to blank, that's essentially clearing everything out. And we already have the player content here, so the player start and player score is already added in there. So those are the two parameters that we also need to reset in order to create the gameplay. So now that we've generated that, we can update some of the styling, and coming up next, we'll do a final run through. And one of the things that I did say that I want to add in is the ability to generate random colors for the bad guy cars. So let's set that up, and I'll show you how to do that. And we go into our functions, and we need a way where we're setting it to red. We need a way to generate a different color for those cars. So I'll show you how to do that. And that's just an extra, so you don't have to do that. All of the gameplay is still there, but I'll show you how to do that in the upcoming lesson. So that's a quick bonus lesson. Instead of red, it'll be random color. So as we're generating out the enemies, we can also generate a random color. So we're going to add in a function that's going to generate that random color. We can just call it random color. And we want to return back random hex values. So we're returning back, and with hex, we need to do the hash in front of it for the color. And we're going to run several functions. So we need to create these functions that are generate out the value of a random hex value. So creating a function, we can call it function C. We only need it to use it within the random color. And we're going to call to this value. So creating out our hex value using math and math random. And you'll see that online there's several different ways, and there's actually some shorter ones as well to generate random colors. This one's a little bit easier to explain. So we see that we're generating a random number from 0 to 255, and we know all of those digits. So if we do an RGB color, that it's going to be 0 to 255. And what we want to do is we want to transform this to a string value to a hex value. And the way that we do that is we do toString 16. So that's going to convert our decimal number to a hex number, returning back. And as we know with colors, we get FF, EE, and so on. So those give us that 255, 0 to 255 in a string value. And there's one other thing that we do need to take care of before we return this value, and that's in case we end up with only a one-digit number. Within our hex value for the colors, we're going to need all 6 characters. So this is to make sure that in case our hex value turns out to be only 1 character, we're going to use a substring value of -2. And you can use this for numbers as well to make sure that you do get, instead of if you go down under 10, you're only going to have 1 digit there. If you want 2 digits, then you can do this as well. So this will always make sure that you're returning back a value of at least 2 characters, 2 digits. So we've got our 0 that we're placing in front of it, and if we need to use it, so 0 plus the string value of hex, which is this one we've generated up here. And if this one is 2 characters, then it's only going to return back the last 2 characters. If it's 1 character, then it's going to still return back the last 2 characters, but we're dropping a 0 in front of it. So now that we've generated a random color, we can update this value to be random colors, and you'll see that now we're generating random colors for those enemy cars. Also, we need to apply that into where we're generating the items as well, so whenever they run off of the page. And this is another one of those optional things. So if it runs off the page, we can generate a random color for it, so assigning a different color value to it. And again, this is another one of those optional things that we don't have to add, but we can add if we want to, of course. Also within the enemy, you can add in a value in the inner HTML, and you can set a value of X if you wanted to. So we could do X plus 1, so we know what car number it is. And then going back into here, if we have any text in here, we can make this really big. So we can do font size and set that to be 2EM. And also get rid of that name car as we're generating out our car. We don't need to write car on it, of course. So as we generate this out, we can get rid of this line here that's writing out the inner text for that for our. So you can see now we've got the cars. They're going to have numbers on them. So 1, 2, 3, and then we're going to have 1 coming back and so on. So going back, let's also, or we'll do a text align and center text align, and also vertical align. So align it to the middle. So see how that looks. And if we wanted to as well, we could add in a space there, so a line break. So where we've got that inner HTML, because it is HTML, of course. So that will move it down 1. So let's try the game out, and we'll work through any of the final bugs that we have within the game and the application in the upcoming lesson. So that's still to come, as well as we can make them look a little bit more like cars as well within the CSS if we wanted to. This lesson we're going to update some of the styling to improve the way the game looks. So within our car and as well as our enemy, we're going to apply a background image, and the image is going to have a URL, and within this URL, so we actually have an image car2.png, so we can apply that, and the background is going to be cover. So let's see what that looks like. So now when we refresh, okay, they look a little bit more like cars now. As well, you can add that image as well into your application to make them look a little bit more like car-like. So that was just a little quick tweak to adjust the way the cars look. And let's do a final code review of the game, just to make sure that everything is working as intended. So when we start the game, we come in and we've got a really narrow road. So we might want to even adjust the width of the road if we wanted to. As we can see, it's a little bit narrow, and sometimes might look a little bit better if the road was wider. So instead of 200 pixels, let's do a width of 400. And in this case, we're probably going to have to make some adjustments to the code as well. Let's try it out and see how that works. And we do need to adjust where the lines are, as well as where the cars are coming in. So you can make it a little bit more difficult, but then this as well, we need to adjust because we hard-coded some of these values. So we've got our margin left, so we need to adjust that to be 195. And we also need to adjust where the car position is, as we've got that to be as a static position as well. So if we update all 3 of these, we should be good to go with having a wider road. So go back and try that out and see if that works. And so far, so good. It shouldn't be affecting any of the other mechanics of the game. So we should be able to start again and see that that is working properly. And sometimes you do need to play through these games just to make sure that everything is working as intended. And we might even want to change our car color to be white so that it stands out a little bit more within the road. So that's another option. So you can really easily adjust the car color, and that's coming in from as a default here within these lines. We've got it as blue. So we can set it as white, or we could use JavaScript to set that as well. So it's all dependent on what you want to do. So now we've got our white car, and all of the enemy cars are going to have a number on them. So we see that it's got the 1, 2, 3, and so on. So see, they all have numbers on top of them. So do try out the game, and in the upcoming lesson, we'll do a quick overview of the source code to do a quick review of what we did and how we accomplished and built out this car game from scratch. So all of that is still yet to come in the upcoming lesson. This lesson, we're going to do a quick CSS update on the start screen to make it more effective and look a little bit better, as right now it's kind of in line there and it's pushing down where the road is, so it doesn't look the best. So if we use a position absolute, we can float it above the road, again using a background color, so we need a way to kind of stand out, so we'll make it red. I'm going to update the width to be 50%, so that's dynamic there. So that way when I do a margin or a left position, I can use 25% left. And also we can set a top, so we can set a default top of 100. A color for the font, set it to white. And we're going to also need to use Z index to make sure that it's actually going to show up on top of the road. So let's see what that looks like. And now when we hit start and we generate it again, so now it's just popping up on top. And this looks quite a bit more effective and much better. You can also update the font family if you wanted to as well. So if you do something a little bit more interesting. So try that one more time. So it stands out a little bit more as well. Press here to start and arrow keys to move. If you hit a red car, you will lose. So we need to update that because we updated the color. So if you hit another car, you will lose. So this was just a quick lesson to fine tune it. And of course, you can style it and color it and update it as needed. I'm also going to decrease the size of the fonts. So do a 1.7. And also so that we can do a line height. So this will affect where the positioning of the line is and adjust it slightly. So make it 35. I'm trying to move the numbers more centered on top of the car. And as you can see, that's a little bit more centered. We can move them down slightly as well to maybe 38. So now we've got the numbers showing up on top of the car, and that's actually where we wanted it to. So a few minor adjustments. Have some fun with it. Play around with the CSS to make your game look fantastic. So coming up next, we're going to do the code review. Welcome back, and in this lesson, this is our final lesson of the section where we're going to do a quick code review. And I hope you had an opportunity to try this game out for yourself, build out your own version of it, and always before you finalize the product, play through it several times just to ensure that things are working as expected. And as you can see, I'm fairly satisfied with the way that this game runs. And whenever I do the collision, then we run and we get game over, and we also get our score. So everything that we set out is in place. So we can do a final code review now. First, we came into this application. We added in a bit of styling to present the game in a better style format. So that was all of this was just typical CSS styling. And this isn't necessary for the gameplay. As you know, that we started, the original cars were just squares, and then we've been updating them throughout the gameplay. So again, this is optional, and you can make your own version of how these cars look. Coming into the HTML, we didn't have a whole lot of HTML. We tried to keep it to a minimal and tried to do as much as possible with JavaScript. So we set up an element for score, we set up an element for our game, and then we had two different screens. So we've got our start screen, which is this red box here, which gives us some instructions and also tells the player what to do and how to start the game. And then we have our main game area. So this is where all of the magic happens and how we generate out all of our content within our JavaScript. We came into the JavaScript creating some objects that connected to the elements, to our HTML elements. So that made it really easy to connect to those and attach all of the different functionality that we needed and the interactive and dynamic content. We also needed to set up a few objects. So we've got one for the player, which tracks the speed and the score. We can also add in other values if needed, because it is an object. And using objects keeps it nice and neat within one package so that you can really easily access it, and it makes a lot more sense when you're adding it into the code. Also for the keys, so we generated another object for the keys. By default, we set them all to false, and these were all of the 4 different keys that we're tracking. So we wanted movement for up, down, right, and left. So we needed to also track those if they've been pressed and if they've been released, and take the appropriate function within our gameplay for that. We needed to add in a few event listeners. So one of the event listeners that we added in, we wanted a click start in order to start the game. So that adds that functionality to that start screen. As well as for the keys, we needed 2 functions. We needed one function that tracks when the player presses a key down, another one when the player presses a key up. And going into our object, we set up those keys tracking what the keys were set as. So if we set the keys with the key value to true, we could also set them to false afterwards as well. We also tracked the console log, outputting the key values. So this is actually not necessary for a finalized gameplay. So we can remove that at this point. So going into the key object, we're able to track which keys are pressed up and down. Then going into our gameplay, we were tracking our gameplay. So we have our start button, which kicks off the game and starts the initialization of the game. So that was our start function, where we need to hide the start screen. We need to clear out the game area. So in case this is a restart, we need to clear that out. We also reset those values to true and to 0. So the player's start value is the one that's going to control all of the functionality. So if this is true, that's when the game is playing. If it's false, then we're not going to play the game. The game stops in play. And basically it stops the animation screen. We also needed to generate the lines for our background. So we went and we generated 10 lines for our road to make it look more like a road, of course. We also initiated our play game request animation frame, and this is going into a loop, so we'll take a look at that as well. We generated our car, so that's the white car there, creating an element, so that was a div, set an attribute of car, so connected it to the class of car, so that gave us the styling and the image and so on, and the basic width, height, and position of it. Within the game area, then we added in the car on the game area. So that gives us the ability to add it into the HTML of the object. So see there's our car. We've generated that. These are all the lines that we generated and the top positions of those lines. And as you can see that once we start running the application, then these line values are going to be changing dynamically. We also have our enemies. So we generated 3 of them. And this, again, was a generation of particularly a div, and we had to set some properties into the div. So those are within the styles there that you see that's how we're actually moving the element by adjusting the style. We create a random color for it, and then once we've created it, we append it to the game area. And you can see the enemies are generated down there. So they all have different top starting positions, and they also have different background colors. And generating the random colors, we create a function that generates a random hex value, and we can see that again within the style, that these are just random color values that are generated. So the main action of this game takes place within the request animation frame, where we're calling the play game function. So going over to play game, this is where all the movement of our application happens. So first we were getting the car element, so selecting the element with a class of car, so that way we could select that one that we've generated within that game area. And then we had a couple functions, one for moving the background lines, another one for moving the enemy. So take a look at those in a bit. We got the road bounding area, so that was so that we could use that for top and bottom. We could have also generated these values as well for the road, the top and the bottom. So this wasn't absolutely 100% necessary that we use the get bounding client rectangle, but we were using it within the collision detection. So it was a good practice exercise to start using and understanding what values we can get from this JavaScript function. Down here is where we're checking to see if the player start is functioning, and if it is, then we attach with the arrow keys what's going to happen, using and updating a value that's contained within the element object, so a y and an x, and then taking those x and y values, and this is where we were updating the style in order to match it with whatever the x and y position was. Because it's a lot easier to update the x and y position. We could, of course, have calculated out moving the left and top, but then we'd have to do it multiple times. So this way was a little bit cleaner. Next, we reinitiate the request animation frame and reinitiate that play game. So it's going to continuously loop and run all of that function. And then we've also updating our score as we're moving through, and also updating the inner text of the score so the player can see the score increasing. And then all we're doing is going back to that play game, and this is where all the functionality takes place. We've got our move lines, move enemy. So those functions are sitting over here. So we've got our move enemy, and we're passing in that car element object because we need to make a collision detection. So instead of selecting it and using it again with document query selector, we just simply passed it in. Then we were grabbing all of the elements with a class of enemy. So this makes it dynamic. So if we had more enemies, we could grab all of them. We loop through each one of those and we check to see if there's a collision. And if there is, then we end the game. Otherwise, we just continue with the movement of those cars. And the other thing too that we're checking to see if the car has run off of the screen, and if it has, then we reset it to -600, and we also reset the left position and we reset the background color. So it can have a different background color, and we can also have a different left position. And then after all of these conditions, so if these conditions are not true, then we skip directly through updating the Y position of that element. And that means that we're updating the style and the top position just as we were with the player's car. The other one that we're doing is that we're updating and moving the lines. So this one wasn't as complex, where we're still doing the same thing where we're using query selector to select all the lines and looping through all of the lines within the node list. We needed to check to see if the value of Y was off the screen greater than 1500, and if it was, then we're subtracting 1500 from it, and this keeps the lines within the same distance apart. So instead of setting a value, we're subtracting the 1500. So if we had 1515, we would still end up with negative subtracted off of there. So we'd still end up with a value that we could utilize, and we would still have the same distance between the lines. Also, increasing the player speed by the player speed. So this can be dynamic as well. So we can increase the player speed and it will increase the way the lines move as well as the enemies. And we also had our item style that we were updating as well. Now, one of the most important functions of this game was the collision detection, which we're using within the move enemy, where we're taking the enemy object as well as the player object, which is the car, and then the enemy object, and checking to see if there's overlap between the elements on the page. And we're using that get bounding client rectangle method in order to get the top, left, right, and bottom positions. And then we were looking and comparing to see if the horizontal or the vertical top and bottom are overlapping, and again the opposite, so the top and the bottom of the opposite ones. And if there's overlap there, then we know that there's a possible collision. And if this one is as well possible collision, and this one as well if it's a possible collision. So taking all of these into consideration, notice that these are ORs. So if any of these are overlapping, then we know that we've got some type of overlap, and we need to take this into consideration as we return back that value. And this is all contained within one statement here. And if there is any overlap, then by default we're toggling that value from false to true and returning back a value of true. And that means that we do have a collision between the elements, and then we do the end game functionality. And essentially that was really the core of what we're doing. The end game was relatively straightforward, where we have the player start function, so we set that to false so we can stop running that animation screen. We output the score for the player so they can see what the score is, and we also write game over. And then we also have our start screen where we're showing that start screen button again, so the player can restart the game. And we needed to make sure as well that when we're restarting the game that we're clearing everything out and we're preparing a brand new game again for the player. So go ahead and try this out for yourself. All of the source code is also included, so you can copy, paste it, try it out, experiment with it, and get familiar with the content that we've covered in the previous lessons. Thanks again for taking this section of the course. Hello and welcome to our course, where we're going to be building out a fully dynamic interactive card game from scratch. My name is Lawrence, and I'm going to be your instructor for this course. I come to you with many years of web development experience, and the idea for this project comes from a card game I used to play where we deal out a deck of cards. We could have any number of players, and we turn over the top card and see who has the highest card, and the one that has the highest card gets all of the cards. So coming into the application, we have ability to select any number of players. So I'm going to select 5 players. We hit start. And we see what happens with the application is it generates 5 players that can interact with the cards. It shows us which one won. So what's happened here is we've actually dealt out a deck of cards. And if we go into the console, we can find out a little bit more about what's happening. So we see we've got this array. It's called deals. And within that deals array, all of the cards that have been dealt and all of the hands that each player currently has. That the ace is the highest card that was dealt out. So player 1 possessed the highest card. So they ended up having all of the cards added into player 1's hand. So that's why player 1 ended up with 15 cards. And you can see those cards that were just dealt out are now at the bottom. So all 5 of those have been added to the player's hand. Got suit, rank, value for each card. That's how we distinguish what is contained within each card. And then also we have for player 2, so they were originally dealt 11 cards, so now they're down to 10. And the other players were originally dealt 9 cards or 10 cards, and now they're down to 9 because they lost. So the objective of the game is to keep playing until one of the players possesses all 52 cards. So in the application, write out what happened in the game. So player 1 won 5 cards. And that's a little note there at the bottom so that we can see what's happening. So now we have an option to run our next round. So we can do how many rounds we want to attack. And in this case, we'll just do 1 for now. And you can see that it runs through generating the cards, picking up the top card of each player's hand, figuring out who has the highest card, and the one with the highest card gets all of the cards that were turned over. So now that deals array that we just saw earlier has been updated. Cards are now sitting within the player's appropriate hands. You can also attack multiple rounds. So if, for instance, we want to do 10 rounds, you can see what's happened here is that player 4 didn't do so well after 10 rounds, and he's out of the game. He's lost. Player 1 still holds most of the cards, and it won that last round. And if you want details on what happened the past 10 rounds, it's all output here at the bottom. So this is the application we're developing. JavaScript experience is required as we are going to be focused on building the application and JavaScript related to building the application. Also, HTML and CSS are prerequisites to this course. All of the source code is included, so I do encourage you to try the code out for yourself. Run it in your editor and see how it works and get more familiar with the different functionality going over in order to build the application. In addition, if you have any questions or comments or need clarity on any of the topics covered, I'm always happy to help in the Q&A section. So I know you're excited to get started, so let's dive right in the next lesson and start building this application from scratch. Hello and welcome to the first lesson of this section. Here we're going to be building out the HTML and the structure so that we can bring in our JavaScript and make our game interactive. So we need to have a few different elements on the page. So this one can be a span. I'm going to give it a class. So this is our message area where we can communicate with the user, give them information about what to do. And for now, I'm just going to write in here, press to start. And this will also output something for us to view within our browser. Also, we need a scoring area. We can just call this one score. And then lastly, let's create an element to contain our main game. And then within here, in case we need to add any additional elements, we're going to have our game area. So this is where all of the gameplay is going to take place within here. And we're just going to leave them blank because we're relying on JavaScript to fill in all of the elements and manipulate them and make a game out of it. So the next thing that we want to do is open up our JavaScript area. So this is when our script tags, and select those elements. I'm going to make this bigger because there's not much to see right now. And selecting those elements so that we have them in JavaScript objects so that we can make use of them within our code. I'm going to use query selector to select the elements. You can use select by class name. You could use getElementByID. So there's a number of different ways to select the elements that we want to manipulate. Taking in the score, so you're going to have that as an object in JavaScript. We can also have our game area, so that's an important one. And we're going to utilize these objects throughout the upcoming lessons. So it is important always to start out, to have a good start to it, so that you don't have, so you can reference them really easily within your script. And also we'll select that game message area as well. The same way using the query selector and selecting the element by its class name. So once we have that, usually I like to check just to make sure that we do have those elements selected. So now if I go into the console and if I type in score, we're going to see an output for score. So it's selecting the element with the class of score. Next, selecting our game area object. Once again, selecting our game area element. And what it does is it outputs the corresponding element information out into the console. And that just makes sure and double checks for us that we have actually selected the correct elements, and now we can use them as objects in JavaScript, manipulate them, apply different functionality to them. And that's all coming up in the upcoming lessons. So for now, before the next lesson, open up your editor and create a basic game structure. So an area where you can communicate with the user, send messaging, also a scoring area, and then a main gameplay area. And then using JavaScript, add them in as objects and double check within the console to make sure that you do have them ready to go and ready to be used in the upcoming lessons within the code. The next step in the build process is to start the game. In the previous lesson, we set up the HTML. We've got select number of players and a start button. So this is where the player is going to start all of the interaction with their game when they hit start. And that's where we need to handle picking up that event, adding an event listener to the start button. So selecting the button, we're going to add an event listener to all of the buttons. We can do this in a number of ways. So we've got buttons, and we can use for each in order to loop through each one of the buttons. And then setting up a function, we can pick up the item. And then as we iterate through, you can see in the console log, we've got all of the items are going to be listed. So when we refresh, we see that we've got the start button as well as the attack button. So both of them get listed. And that means that they're being represented as objects. So we can add event listener. So selecting the item and using JavaScript add event listener method, we can listen for a click on that event and send it over into the play game function. And that's where we can handle any of those events on the button. So next thing that we need to do is set up the play game function where we're going to initiate the game play. And this is also where we're going to detect which button got clicked. So we've got play game. We're passing in that event object. So it doesn't matter which button gets clicked. And of course, we only do have the one when we're starting. So let's take that information from the button and figure out what button got clicked. So we can use target, so the event target, and getting that inner text, or we can do text content. And I'll console log out the contents of temp so that now you can see that when we hit start, we get start output into the console. So we can use that information by applying a condition and checking to see if temp is equal to start. Make sure that if you've got a capital there, that you're keeping it capitalized because it's getting all of the text content from the button exactly as we're expecting it to be. So once we've got that start, we need to kick off the start game function. So this is our start game function, and we'll kick that one off. So that's the main one that we're going to do, and this is where we're going to handle the start game functionality. So everything we need to do in order to start game is going to be contained within this function. So I'm going to hide the start option as we're starting a brand new game function in order to toggle the buttons. So create a function and button toggle, which will make it really easy to hide and show because we're not going to have the start button and the attack button on at the same time. So we're taking button number 1 or buttons number 1 from the buttons object and updating the class list, and all we're going to do is toggle the class of hide. So if it has it, it's going to remove it, and if it doesn't have it, it's going to add it. So taking buttons. So whenever a start gets clicked, and this will hide the start button. So maybe that's the first thing that we're going to do after we start the game. We're going to do a quick button toggle because we don't want the user to be able to press start again. So we see that attack gets now shown. And if we hit attack, then we could also do something to handle the attack button. And that could also be toggling the buttons. But in this case, we want the attack to show and we want the user to constantly be able to hit attack. So we'll keep that one in play. So going back to the start game function, so this is where all of the start of the game takes place. And we need to first pick up the number players. So using document query selector, we're selecting the input element, and we only do have the one input. So we're selecting the value from that input element. And we're still going to be using this input under attack because it's going to give us a number of how many attacks we want to launch. So we can reset that default value if we want. We can reset it to 1 once we start the game. Taking that element object, we're going to reset that value back to 1. So this is just going to say 1 right now, and that's how many attacks we're going to launch at each iteration. So the next thing that we need to do is we need to make the deck of cards. So that's coming up in the next lesson. So for now, we have the game starting. We get the player to select the number of players they want. We hit start, update that input to be 1, and then we've got the option to attack. So this is the number of attacks that we're going to launch. So that's all still to come, and we're going to work that into the gameplay. So go ahead and add the option to toggle the buttons, updating the class list. And you can also see that when you go to inspect on that element, this one has the class of hide and this one doesn't have any. And when we start out, initially the attack has hide. So when I click start, that hide goes to the start button and it gets removed from the at attack. So that's where we're toggling the button. And if we were to do this function again, we can launch that into the console, and you can see that every time I toggle the button, we're not returning anything, but those button classes are being removed and added. So that's the one thing that we did within the start. So we changed the view. We also picked up the start button content, and we have a function that's going to start the game. So we've got the number of players, and this will dictate how many players we have to deal cards out to. So next we need to make that deck of cards so that we can deal it out. Welcome back. In this lesson, we're going to be creating a deck of cards. So the first thing that we need to do is set up a few more variables, and these are some default variables that we can utilize. We need a deck. This is going to be a global variable, which will be the array that we're going to use. We're also going to set up a few other arrays. So we've got the ranks of the cards, and this is where you can list out all the cards that you want. So we want all the way up to 9, 10, and then jacks, queens, and these are strings, and kings, and we want aces to be the largest card. And then there's the different suits. So set up another array to hold the suits. And we're going to specify the suits as we've got hearts, diamonds, club, and spades. So using these values, we can loop through the suits, and then we can also loop through the ranks and build a deck of cards. So that's what we want to do when we start the game. We've got the start game function. We've got a global variable to handle and to take all of the deck contents. So next thing that we want to do when we start the game is we want to build the deck of cards. So build deck can be the function that will create the deck of cards. Let's set that function up. So when we start the game, we're building our deck. And this is going to be a series of loops. So first thing that we want to do, clear out the existing deck of cards. So it's a global object. So that's why we don't have to declare it again. And let's use for loops. So starting with I is 0, and while I is less than, and looping through that suits array. So looping through while I is less than 1, we're going to increment it by 1. And so we need another loop inside because we've got another parameter that we're using in order to build the deck of cards. So we'll set this one as j, and looping through while j is less than ranks length, as we've got both of those arrays that we've got to iterate through in order to build a full deck of cards. So once we're looping through there, let's create a blank card object. So this is going to be an object, and this can hold all of the information that we need for our card. So let's set up some values for that object. So taking in the suit. So this is going to be coming in as suits, and suits is controlled within I. Card, and we want to get the rank of the card as well. So this is held within the ranks array. So as we iterate through there, when we get to j, we'll output that value. We've also got a card value, so that can be j plus 1. So setting this up to be whatever the value of j is. So as we increase in ranks, we can increase the value of the card. And then lastly, let's take that card and we'll push it into the deck. So as we loop through both of these loops, by the time we're completed, we're going to have a finished deck of cards. And we can see that when we console log out whatever the value of deck is. So let's see what that looks like, and refresh. We hit the start the game, and that builds up our 52 card deck. And as you can see, we start out with all of the hearts. So we've got a rank of 2 and a value of 1. So going up, and aces are the largest value, so they have 13. So they're going to be the highest card. You might also want to have an ace as a 1. So it all depends on how you want to set up your deck. For this case, what I'm doing is I'm having the ace set up as the highest card, so that's going to be 3. So we get all of the values, all the ranks for the hearts, all the ranks for the values, diamonds, clubs, and spades. And then we've got all the cards have a value in the order that they appear in the array. So if you want to switch these around, you're welcome to do that. But best practice is to keep it within that sequential order so that way you can automatically set the values as you loop through them. And it's going to make it a lot easier to compare which card is higher. So now that we've built a deck, next thing that we do is we need to set up the players and then deal the cards. So that's still all to come in the upcoming lessons. So go ahead and build a deck of cards. And this is another thing that we're going to do, is going to shuffle this deck of cards before we deal it out as well. Hey, welcome back. Last lesson, we built the deck of cards. This lesson, we're going to set up the players. First of all, let's create a class. We'll give it a class, name it player, and apply some properties, displaying and as inline block, so that we can line them all on the same line. We're going to set a default width for each player to have a width of 200. Also setting up a height for the player, so we can do 600 pixels, and we can adjust these as needed later on as well. Vertical align, let's do center for vertical align or middle, and also set up the text align as center, and make the font size fairly large so it stands out. And we're also going to add in a border, so one pick solid border, and give the border a slight color. And we're going to create these player elements on the page dynamically, where when we start the game, so we've got our start game function, and we build the deck of cards. The next thing that we want to do is create the players. So we'll create a function. We can call it setup players. And we've got the number of players that we're getting from the input, so this can change dynamically. And also we're going to place it in a function so that once again we can dynamically generate this as needed. So setting up a function in order to handle that, called setup players. And we'll pass in the number of players as a variable called num. And here we need to empty out the arrays. So we've got one called players. And also let's set that up as well as a global object, so just players just under deck. So we've got some of these variables that we can manipulate in our JavaScript. So setting up players as blank, and also one other array that we need as a global array to hold a value, and this is going to be called deals. So this is where we're going to actually deal out the card contents, and we can set that up as an array as well. As we build out the number of players, we'll create a for loop for it to do that, and looping while x is less than the value of, refresh that. Creating our main parent div, we can give it a name of div, and using document create element allows us to create elements on the fly with JavaScript. So there we've got our div created, and we can console log this out as well. So as we're creating them, we could generate and we could see them. So now when we hit start, we're going to see that we create 3 divs, and these are the 3 divs here. So we need some information that we need to set up within this div. Let's add an attribute to that div, and taking the div, using setAttribute method, and the attribute that we're going to set is the ID. So we can set the player, and the value can be num plus 1, or we're going to set this as x plus 1. So as we're looping through, we're going to set the ID of these divs to be player 1, player 2, player 3. Next, let's add in a class. So taking that element and using class list gives us the ability to add classes to that element. So we're going to add a class of players. So that's the one that we just built. So now we've got 3 elements that we've created with IDs as well as classes. So we also need to create another div, so we can call this one div1, and using the same format where we're using document, create element. So we want to create another div that we can place inside of the div that we're building, that we're constructing. So this will give us an area to output the cards and the card information, as well as some information. So we can call this text content, and this is div 1. So we're going to build this div 1 and then we're going to attach it to the div. So we've got some information player. So once again, x plus 1. This is the inner text that we're going to represent there. Let's create another div. And this one is going to be more interesting because we're going to create within the players object where we've got our player. And as we're iterating through x, we're going to set that array value to be equal to an element that we're going to create on the fly. And that's going to give us the ability to access it across different functions. So we're creating another one and we're calling that one div as well. And this is where all of the cards will go. So now whenever we reference it, we can reference it as players and the index value and adding in text content. So adding that text content, for now we're going to put value of cards in there. And this is where all the cards are going to go. So taking our main parent div, now let's append the divs to it. So we're going to append the child. And the first child that we're appending is that div 1 that we created. So because this is a variable, we append it that way. And the next div that we're appending to the parent, so this is another element that we're adding into that main parent. And this is going to be the player's x. And I'll show you how this is all going to come together. And then lastly, we've got our gameplay. So that's our main area where we want to add in the gameplay. And we need to append the div that we've just created dynamically to that element. So that's going to make it all visible. And we also want to build out our deals array. So we want to have multiple arrays within that main array. So all we're doing is pushing in a blank array. So by the end of all of this, you're going to be able to see the different players on the screen, as well as we'll output the deals array. So you can see that as well. So when we click start, we get player 1, player 11. So there's a problem there, and we need to transform this into a numeric value. So what we can do is we can use parse integer, where we make sure that we are transforming it into a numeric value. So let's try that one more time. So we got player 1, player 2 cards, player 3. Make this smaller. So bring it down to 100%. So now we've got all of the players lined up. So if we do 2 players, we get 2 players. If we do 4, let's refresh it and try that out. So we've got all 4 players that are showing up on the screen. And because I don't have a lot of room and we're setting the default width to 200 on each one of these, you can see it being represented here. I'm also going to make this a little bit smaller so we don't quite need a height of 600. We can do it as a height of 400. So that's going to show it a little bit better within our screen visible area. So now we've been able to generate the players. And the nice thing about this is that when we try to access the players array, you're going to see that we've got the 3 divs in there. And these divs are actually corresponding to the divs where we've got cards written on the screen. So we have an easy way to loop through the players array and access the elements accordingly. So player 1, player 2, player 3, and this is our visible area where the cards are selected. So that's why that was set up within an array format so that we can easily access these items that are available in the array. And then the rest was for visual properties in order to show the player name as well as the cards that we're going to be displaying. So all of that was outlined there within the player structure. So go ahead and add this into your project. And coming up next, we're going to work a little bit more on the building out the deck as well as dealing the cards. So that is all still yet to come. And this, of course, this is an important part where we're using the players array and we're adding in these elements so that we can access them as needed. And that's going to come very evident as we do more visual stuff and we output the cards visually for the player, the cards that are being returned. And that's all still to come as well. What's next? When you're building out a game, you've got to ask yourself, what do you want to happen next within the gameplay? So we come in, we have select number of players. We can select a number of players at this point and start the game. So we hit the start button and we are represented with all the different players. We've built a deck of cards and we need to also deal the deck of cards now that we have a bunch of players set up. So let's create a function in order to deal cards. And I also want to pass in a value in here. So this is going to be the first player that's going to get the card. And the first player that we want to retrieve the card is going to be player 1, but within the array, they're going to be the first character there. So that's going to have an index value of 0. So that's why that one is passing in 0. Let's take deal cards and take our starting player card. So that's the card that they're on. We need to pass in that 0 value. And what we're going to do is we're going to keep going and dealing into the deal cards function until we run out of cards. And then once we run out of cards, then that means that the deck of cards has been dealt. So let's take our player card value and we're going to pass in a ternary operator here, checking to see if the value of player card is greater than or equal to the player's length. And remember, players was that array that we created in the last one. So we've got a length for the players of 3. So we're checking to see if it's larger than 3. And if it is, then that means that whatever the value of player card is the one that we're going to reset it back to 0. That's our starting card. Once again, that's our starting player so that we go back to, again, that first player with the index. And if it is larger, so if it is larger, then we're going back to 0. Otherwise, it's going to be the value of player card. And we can also console log that out so it's a little bit easier to follow. And we're going to log that out as we deal the cards. So we're going to continuously loop through here. And we're removing cards from the deck. So as long as the deck has a length greater than 0, then we know that we've got more cards to deal. And if it doesn't have a value of greater than 0, so that means that all of the cards have been dealt. We can take our message element and update the text content to say cards dealt. And that means that all of the cards are dealt. And we can also add in a return here to return that function so that we're no longer iterating through. So next, what we need to do is we need to loop through here. So this isn't going to do a whole lot quite yet. So we see that we've got all the player stuff that we did last time. And as we're looping through, we're outputting that player card value. So we've got player card. And there's not a whole lot of information there that we have available to us because we're only dealing the cards once. And that's just passing in that same 0. So that's our starting 0. So now is where things get interesting. Where what we want to do is we want to get a random index value from the deck of cards so that we're not taking always the top card. We're actually going to be, the way we're dealing this is we're actually selecting one of the elements randomly using math random and then math floor from our deck of cards, and then we're going to remove that. And that's where we just multiply it by the deck length, and that's going to give us a random index value from the deck of cards. So let's create the card, and the card is going to have a value. So using the deck of cards, we're going to splice a value, so changes the content of array, adding new elements while removing old ones. Well, we don't want to add anything new, but we do want to remove an existing one. So our existing one is available at random index, and we only want to remove out one card. And because this is going to be an array that's going to be returned back, we only want the first item that's available in the array. So now if we do a console log of card, you're going to see that just after that 0, we have a card that was randomly picked. So the first card that we're dealing is the Queen of Diamonds. Its value is 11. So this came when we built the card. So that's all the card information. So next thing that we want to do is take our deals array, and depending on what player card we're on, and remember this is that array that we constructed in the last one. We're setting up the players, and we added in within deals just empty arrays. So that built out the array structure. So now we can use the player card to get the index of which array we want to add this in. So we're pushing the card into the array, basically. And if we output deals, so now we don't have to output card, and if we output deals, you can see that within deals, we've got our first player has a first card in their array of cards that they have. So next we need to increment the player card value and do this all over again until we run out of cards. So we're going to return a function here, and the function we're returning is deal cards, and we're returning the value of player card because we incremented it. So this will continuously loop through while the deck length is greater than 0, and if it's not greater than 0, then the cards are all dealt out. So let's see how this plays out. So let's do a quick refresh and a start. We get cards dealt now, and as you can see, deals array, we have all of the cards have been dealt out randomly. So we see that we've got a total of all of the cards dealt out into the array. So we've got 18 plus 17 plus 17. So that's a total of 52 cards all dealt out randomly. So every time we deal the cards, it's going to be a random sampling of the cards for each player. And this nice thing about it here, this is fully dynamic. So if we have 4 players and then we look at the deals array, you can see that it's dealt it out to all 4 players. So each one in this case got 13 cards, and these are all the cards at random. So this is how you can select a number of players, deal out cards to them, and build a deck and deal out those cards to them, and have this all dynamically available. So it doesn't matter how many players you have, it will always deal out the cards nice and neatly. So next, what we want is more visuals. We want to be able to see the cards that are dealt out and the card that's on top so that we can play through the rounds and then also determine who's going to win. So that's going to come up, and we're going to set that up now that we've got the play started. The next one is going to be attaching an event listener to the attack button, and the attack button is the one that we're going to deal the next round to. And this is going to specify how many rounds of play we're going to have and how many interactions we're going to have. So this input is going to change from being how many players to how many rounds we're using to attack. So that's all still to come. So go ahead and set the ability to deal the cards up in your project. So what's the next thing that you think we need to do in the project? We come in to play the game, select number of players. We can select any number of players. And what happens, we create a deck of cards. We deal out the cards to the players. We get a message that the cards are dealt, and we don't see any of the cards. So we actually want to see the cards that have been dealt. And that's the next thing that we need to do when we start the game. And we've got our start game function. We need to make the cards. So we started the game, and next we need to make the cards, and this is going to make the cards visible. You can also do that at the start the game as well. So either one, you could, where we're dealing the cards, and once we've dealt the cards, we can make the cards at that point. So maybe that's a better option. So once we finish dealing the cards, let's go ahead and make the cards. And the way that we're going to do that is we're going to create a function in order to handle that. And this is going to be visual, making the cards visually. So let's create another function in order to handle the making of the cards. So we've got all of the players set up, and we've got everything in place that we can show the cards visually to the player. So let's first, we're going to create a loop, and creating just a basic for loop. We're going to loop through while x is the length of players. So remember, players is that array object where we've got all of the different player information, and this also corresponds to the elements that we have on the page. So we can really easily go through and we can update the element content. So this corresponds to the number of players that we have and the number of elements that we have on the page. And also corresponding to our console log, so we've got our player, but we also have a value for deals. And this is going to be essentially the player's hand. So you see that we've got all of the different deals that we have. So the first player here, we can grab the first card from them. The next one, we can grab the next card, and so on. So that's what's being output in deals. And we want to grab that first card. and the card that we can grab. So we're going to pull that out of their deals array. So creating another variable, we can call it let card. And this is where we're getting the deals. And in order to get the first item, remove the first element from an array, we do shift. And what's going to get returned back within the console is going to be that first card. And then it's going to reduce the size of those arrays. So see now the arrays are down to 17, 16, and 16, and that's because we've drawn out that first card. So the next thing that we want to do is we want to show that card. We want to make that card and show it. And we also want to place the card into a holder so that we know which cards have been played. So let's create a variable, and this is just going to be, right now it's when we come into make the cards, it's going to be a blank array. And then as we create the cards, we're going to add them into the temp holder so we can push them in there so we can always access them. And we know which card has been played and which cards are currently in place within the temp holder. And this is sitting outside so we can loop through and we can see which cards have been played by the players as we iterate through there and as we push it into our temp holder. So this is going to give us the listing of essentially the cards that have been played. And the next thing that we want to do is we want to show the card. So we want to pass in and select the player that we want to show the card in. So this is, again, contained within that player's object. We have the element that we want to show the card within. And then the card that we want to show, we're also passing that into the function. We also need to create a function in order to handle that. And this is the show card function. So it's going to take two parameters that are coming in for the show card. So the first parameter is the element that we want to show the card in, and the second parameter is actually the card and the card information. So coming into the console log, we can output that card value as well as the element. I'll get rid of the console messages here, and I think that that should get rid of some of the console messages. So now the only console message is coming when we show card. So we want to show the queen of diamonds for the first element for player 1, the 8 of spades for player 2, and the 9 of hearts for player 3. So we need to show that card for the player. So we also want to make sure that the card is not equal to undefined. And if it is undefined, then we might have some issues. So make sure that it's not equal to undefined so that we do have a card object there, and that means that we can create the element. So let's select that element and apply a style. We can apply a background color, and I always want to make sure the background color is white. So let's set that by default to white. And this is the element, remember the one that we passed in and where we want to build the card. So now let's build the card. And this is where we need to create a few different elements. So taking our HTML1 object, we can take the card rank because this is an object, so we can get the rank value out of it and add that into our HTML object that we're building. And then also we can use ASC characters for the cards using the card suit. So this is a really neat trick because when we use the suit, and the suits were written in a format that they could handle the ASC characters, so if we've put the ampersand and diamonds and the colon beside it, then what you're going to get as the output is you're going to get a visual of that rank of the card suit. Let's create another HTML element, so we'll call this one HTML2. And this can take in some additional information, so it can take in the card rank. And this is basically we're just designing the card the way that we want it to look. So it will have the rank and the suit. So next, let's build the card and creating an element. So the div and document, create element. And the element that we're creating is going to be a div. And I can console log out the div before we output it into our visual area. And to the div, let's do class list and add a class. So we need to make a class for the card so that we can style it properly. So we'll do that afterwards, after we create the element. And using document, create element. We're going to have to also do quite a bit of visual styling to represent the cards as well. So this span 1 will have text content, or let's set inner HTML as we used HTML there. of whatever is equal to HTML2. And then we're using that div that we've created, and we're appending the child to that. And the child that we're appending is the span 1. And so also let's create another span. And of course we're going to have to do a little bit of styling for this. So creating another span. And this one can take the contents of HTML1, or we could have just copied it down there. So this gives us a way to kind of duplicate it easily. And we're appending the span 2 child to that div as well. So let's see what that div looks like. So now we've got a div, we've got a card. You see there's that ASC character of diamonds. This is the ASC character of spades. And then you see that we've got the 7 of spades being represented there. So the next thing that we want to do is we actually want to append it to the element. And that's why this was really nice, that we were able to really easily select that element. So we can take the element and we can append a child, and the child that we're appending is that newly created div. So let's try that and refresh it and hit start. And you can see that our player 1 has a king of diamonds, player 2 has a 7 of spades, player 3 has an 8 of spades, and this also corresponds to the content that's down there. So I did say that there is quite a bit of styling still to do. So the objective really here was just to output that content, and now we're going to style it and make it look a little bit better. And that was really why I also want to create the 2 spans, so that we have an option to create 2 classes where we can have the first visual kind of smaller, and then the second one fairly large with the suit, the rank in the suit being presented. So go ahead and add this into your project and have the ability to show the card when we start the game and we deal the cards, and then next we make the cards. And as we loop through all the players, all we need to do is pass in the player element that we want to add the card to, and then also pass in the card object information, and that will output that object into the player's visual area. Welcome back. This lesson, we're going to do some styling and make these actually look like cards instead of just outputs as text outputs. So we are adding in a class of card, and as we build the cards, the visual cards, we're adding those in. So let's set some values into that class. So we've got a display of block. We can also do margin of auto, so that will center the element. Add some padding in there. So padding, let's set that up as 7 pixels. And we also want to force the height of the card as well as a width for the card. And I'm also going to add in a margin at the top. So how about we do 10 pixels. So it's not sitting right at the top. Background color for the card. And let's make it white or an off-white, so we can do a white smoke, so it's not exactly white. Also a border so that we can see where the card is sitting. And do the border black for now. And we'll check that out and we'll see how that looks. Also border radius, so most cards are not exactly square. They've got rounded sides, so we've got to add that in. And then lastly, just for a nicer effect, we can add in a box shadow. So this will add in a slight shadow underneath the card. So let's see what that looks like when we refresh and we hit start. So we've got something that looks a little bit more like a card. Also, let's set up the classes to hold the big area. We can just call this one big. So this is going to be one of the representations of what's on the card, and this is going to be the bigger one. So setting up our font size, 1.5 EM, sounds good. We can text align, so center text align that. Do the line height so that we have we have an option to to center it as well. Margin top, so it's not sitting right at the top as well. So we can do 10 pixels, and by default, let's display block. There's also one that I wanted to add in. So we know that hearts and diamonds are red in color. So this is another class that we can add if one of those matches the criteria of the suit that we're looking for. And then lastly, there's another one that we wanted to create, and this is going to be the tiny representation of what's on the card in a really smaller format. And as we've got the 2 representations, so this one is going to have a smaller font size. It's also going to have a smaller line height. And we can vertical align this one at the top and text align, and this time we're going to text align left. So now let's go back into our JavaScript code, and we're going to add the appropriate classes where we're showing the card. So here's where we were constructing the card in the show card function. So as we're building the card, let's add a class. So we've got the card attribute, and we can do a condition here that we can check to see if the card suit, as remember this is an object that we can select that object information. So if it's equal to hearts, or if card suit is equal to diamonds, then we want to apply a class of red to it. And otherwise, we're just going to leave it blank or black. So do class list, and then add to the class list, add that class of red. So see how that looks? So refresh, start. So now the hearts and the diamonds are red. So it's looking a little bit more like the actual cards. Also, as we're building out the first span, so let's take span 1, and using class list, we can add to the class list, or we can set an attribute because we don't have any classes quite yet. But in this case, let's just do the tiny one first, as this is going to be the small one that's going to show up. And then the next one is going to have, so span 2, and then this is going to be the big one. So now let's see what that looks like. So now we've got a more representation of what the cards look like. And of course, you can style this as needed, and you can see that it looks fairly good. It looks fairly much more like a card. The content that's being output is more visually appealing in this type of format. So coming up next, we need to introduce the gameplay and the game logic. So that's still to come. So go ahead and update your styling, and you can style this the way that I did it, or you can make it look even better. So that's up to you. So coming up next is game logic. Welcome back. Now that we've output the card information, we need to check to see which one is the high card, and if there's any equal cards that we need to do a playoff. So there's a few things that we need to add in, and we can do this within the make cards function. So we're going to set up a variable, an object, in order to contain the current winner. And as we loop through the players, we can check who has the highest card and update this value. So we've got a value for high, and right now we're just going to set it as default null. And we also have the player, so this is going to indicate which player is the current winner. So as we loop through all of the players, we can check to see which one is currently ahead and in the lead. So after we make a selection of the card, this is where we can check and we can apply our condition. So taking that current winner object that we just created, we can check to see if the high card there is equal to the card value. And if it is, that means that we go into a playoff. So we'll console log tie. And we're also going to set up another condition that's going to check to see if there's currently no current winner, or so no current winner high value, or there's no current winner high and the card value is greater than the current winner high. And if that's the case, then we need to set that current winner high value to the current card value. And that also means that we can set the current winner player. So this is going to be the player that is going to be the current high, and we get that from X as we're looping through all of the variables. And we also want to track the card that is the current winner. So we're going to equal that to whatever the value of card is. So as we loop through, we're going to know which is the current winner, and then afterwards we can output whoever the current winner is. So doing that within the function, so do that outside of the loop, and let's output that current winner object. So let's try that one more time. Hit start, and you can see that we output that object and we get player 1 as the winner. So they ended up with clubs, a queen of clubs, which had a value of 11. And you can see that the player 1, so this is within the array format, so that means that it's actually player 2, but within the array, it's got an index value of 1. We'll try that one more time. So this is how we can detect who the winners are. And in this case, we do have a problem because the current winner means that there's a tie game. So we see that the current high is equal to the card value. So we also know that there's a tie that's been thrown, and both of them are actually going to be within the tie. So we need to determine between which one of these the current winner is going to be. For the winner, we're going to have to run a playoff. So let's set up an object to hold that information, and this can be an array. And whenever we do have this type of playoff situation, we're going to add items into the array. So checking to see, and if the current high is equal to the card value, That means that let's overwrite this tie, and this is where we've got our tie game function. So first we're going to check to see if the playoff array length is equal to 0. And if it is, that means that we haven't deposited anything to that playoff array yet. And that means that we need to push two values in. We need to push the current value. So we're going to playoff push, and using the array method, we're going to push a new item into the array, and this is going to be an object. So we can push in a value for player, and this is going to be whatever the current winner player is. That way we're depositing the information into our current array. And also we're going to need to know what card is in play. So current winner and card information. So we get those two pieces of information, which of course we are setting down here, and we're checking against the current winner high. So we push that into the playoff object, and then we also need to push the new value in as well. So before we set the current value, we need to push the new value in. So pushing it in, and the same object information, what we need to get the value of X, which is of course the current player, and then the card is just the value of the card object. And then it will also get added into the array as we loop through. So we're going to know that at this point we do need to have a playoff session in order to account for any of the playoff conditions. So we need to run that function. For now, we're going to add in a placeholder for the playoff content, and we're going to build that functionality afterwards. Essentially the way the playoff is going to work. So if we have a situation like this where we've got two cards that are both equal, and it's got two players that have those cards, and we can also accommodate if we have more, because again we are building an array, so we can constantly push in more players and their cards into that array. So what we want to do is we want to have a function in order for the playoff to flip the next card, the next card, and next card until we actually return back a winner. So we need to run a function that's going to flip the cards and check to see who the winner of those cards is, and also build an array of all of the cards that have been flipped over so that we can add them in, and the winner of all of this playoff is actually going to get all of the card information. So I know that's fairly complex, and we are going to handle that in the upcoming lesson. So coming up next, what we want to do is we want to make an update. So we want to detect who the winner is, and we want to run the update of the functions. So adding in all of these cards to whoever the winner is. So they're going to get all of the cards that they beat. So that's coming up next. So welcome back, and in this lesson we are going to be handling the winner. So we've got the original deal and the deal out, and we're not going to do anything for the playoff quite yet, but we're going to take whoever the winner is. So if we have a clear winner of player 1 won this round, so they should get all of these cards, and then we can flip to the next card. So that's what we want to do on a typical round where we just have the one winner of the card flip. So then we also are tracking the winner, and we also are tracking all of the cards that have been played. So we've got all of the cards played within temp holder. So going back and refreshing it, and you can see that we've got the winner, who is player number 2, so index number 1, the card that they played and the card they won with, as well as all of the cards that were played get dropped into the temp holder. So the way the game is going to work is whoever won is going to get all of those cards. So let's create a function in order to handle that. We can call it updater and pass in the current winner value as so current winner. And we can pass the whole object in if we want, and temp holder as well. So we're passing in both of those arrays. And actually, really, the only one that we really need is we need to get the player. So we can also just pass in the player to make it a little bit cleaner. So when we pick up that information on the function that we're calling updater, we've got two parameters. We've got the winner, and we can also call this temp holder. So these are referring to all of the cards that were won by the winner. So let's take our players object, and because we've got an index value which is contained in winner, so the winner is the index value. So remember over here it's just being passed in as a number. So that's going to refer to whoever the winner is. And we've got all of the elements within the players, so it makes it really easy to update the background color, and we can update the background color to green. So that will visually represent who the winner is. So let's try that and hit start. So you see that whoever was the winner is actually turning green. So the other thing that we want to do is we want to select and we want to add in all of these cards. So the temp holder cards, we want to add them into our winner. So that means that we can loop through them. So let's set up a for loop to loop through. We need to create a record. So actually this is going to be the card of temp holder. So this is all of the array of all of the cards that were played. And so all of these are going to go into the winner's deck. So taking the deals array and selecting the index of the winner, we're going to push the record into there. So getting the record from here, and as we iterate through, we're going to push that in. And we can also output information here as to who the winner is. So taking our res element, so that's where we've got all of the content that we're outputting, and we can output a message to the player, and we're adding 1 to it because winner is an index value. And this is a message out to the user. And also let's list out how many cards that they won. So in case there was a playoff and that maybe they won more cards. So we're going to get all of those cards and add them in to winner of the round. So we can see now whoever is the winner of this round, their background goes green, and they also get all of the cards added in, use it into their deals array. So go ahead and add this into your project. And this is just the way that we're going to be determining the winner. And we're also outputting how many cards are won by the winner. So that's there at the bottom. We can also output underneath and information about how many cards they have left. Let's also add in an option so that we can generate, randomize the order of the cards that are being inserted into the winner. We can console log the temp holder value, and then using the temp holder array and then the sort method, we can sort in place that array by using a return and returning 0.5 minus math random. This is a quick function, and this gives you ability to sort an array object in place, and we'll also console log it after the sort. So refresh, hit start, and you can see that originally the sort order would have been ace to 3. It's been changed to the 2, the spades, and then the clubs. So we had the opportunity to update array order. So go ahead and add that into your project. So let's do one more loop, and we can use X as well for this one. And looping through while X is less than the length of players. So we're looping through all of the players array once again. So these are all of the elements that are representing the players on the screen. And the X is just, again, their index number. So as we loop through, we can create a div, so creating an element that we can output a message to the player. So creating an element, and let's create a div in this case. And then also let's create a variable, we can call that output. So this is where we're outputting information. So we've got our deals length. So depending on their index value, again, we're using that index value to indicate which player it is. And we're checking to see if they're less than 1. And if they are, then they've actually lost the game. Otherwise, we can output how many cards are left. And we're going to handle the game losing and winning in the upcoming lessons. So we're going through and indicating for the player the length of their array. So this is how many cards they have left, and we need to subtract 1 from there. And then let's take our div and append the inner HTML to it, which is going to be equal to the output value. Or we could shorten this as well, and we could just append to the div. We can set its inner HTML, so that will get rid of 1 line. And then taking players and adding to that players object, we can append a child to it, and that's going to be the div that we just created. So let's see what that looks like. So this will give an indication of how many cards are left for each player, and it does look like we should apply some styling. So let's use class list and add a class, and let's call this class stats. And then going up to our CSS, our style, and we can update the font size of this as well. So remember, this is taking the font size from the parent. So if we want it smaller, we can set it to 1 EM. So let's see what that looks like. So that's given us a little bit of spacing. We can also move this down even more, and we can make this even smaller if we want. So that gives us an indication of how many cards are left. And actually, we need to show this after we add to the new array. So let's update the order of this. So before we rebuild the winners, so now in this case, we know that the player 1 has 19 cards because he won the 2 other cards from all of the players. And if we go to deals array, you can see that indicated there as well. So we've got 19 cards. And the reason I say 19 cards left is because that's where we subtracted the 1. So you could also indicate this as card, and then you don't have to have the -1 because that's going to include the one that's showing. So there's another option as well. So in this case, there's 20 cards here. There's 16, 16. And the total cards, of course, in the deck is always going to be 52. So go ahead and add that into your project, and this is more messaging in order to enhance the gameplay. Let's do a quick walkthrough of the current functionality of the game. So the player comes in, select the number of players, they hit start, and immediately the cards are dealt, and we turn over the first card in each one of the players' hands, and we'll also compare them to find the winner that's available there. So we want to have the ability to launch multiple attacks and to launch another attack. So let's set that up within this round, where we are listening for the button click, and if the value of the button is attack, that means that we want to run another make cards. So try that out, and we hit start, and if we do that again, we see that we remake the cards. So there's a few things that we do need to do in order to accommodate this, and one of them is we need to clear out the current existing card when we come in to make the next round. So that's one of the things that we need to handle when we are making the cards. So going into the make cards function, we need to clear out the existing content from each one of the players as we iterate through. So we can do that here as we start the loop. So taking the player's object, indicating the index value, and setting the inner HTML, and we can just clear that out. So just have a blank inner HTML. So start, attack, and we can see that now we're able to play the game, and as we continuously press attack, then we get the next round, and all of the winners then get the attack cards added to their hand, and we can continuously play through and have multiple attacks. So what if we also want to launch multiple attacks, and eventually some of these players are going to run out of cards, and then we can set them as lost. So we need to handle that as well, and this is one of the game win conditions that we're going to do near the end of the lessons. So in this case, we want to get the value that's contained within the input and use that value in order to calculate how many runs we have. So we can call this temp runs, and using the document query selector, let's select the value of the input. And this is going to tell us how many rounds we want to play. Let's also update our RS inner HTML. So this is where we were outputting who won and all of the round information. So that's sitting down there below. So we want to clear that out each time as well. And let's set our round to equal to 0. And I'm going to set a few different variables here. So one of the variables that we need as a global variable is we need to set up a variable for round so we can update it and we know how many rounds have been played, as well as another variable for in play. And we can use this variable to control the gameplay, so we can stop it and start it by checking the in-play value. So going into our card listing where we're making the card. So first, let's check to see if in play is true. And if it is, then this is where we're going to launch the make cards. And we're also going to loop it multiple times. So we can use just a regular for loop, setting x to 0 and looping while temp runs is less than, while x is less than temp runs. And then what we'll do is we'll decrease the value of temp runs as we iterate through. So let's indent this content so it's easier to read. So we're checking to see if the value of in-play is true. So this gives us the ability to control it. And also in the message area, let's update the inner HTML. So we've got new content there, and we know how many rounds that we've actually gone through. So we'll do the round and x plus 1. And as we loop through here, this round value will continuously increase as well. And then what we'll do is we'll just make the cards each time. So let's try that. So now we start the game, and we've got the 1 attack. And we can update this to 2 attacks. And also we want to make sure that we're setting the in-play to be true when we start the game. So in start game function, I want to set this value to be true so that we have our game functionality and our game control Boolean value. Let's try that one more time. So we hit attack again, we hit attack again. Let's try 3 rounds. And you can see that we've got the 3 rounds played. So player 3 won 3 cards, player 2 won 3 cards, player 3 won 3 cards. So we see that the count of the cards is changing. Let's try doing 5 rounds. And we can see at the end of the 5 rounds, player 2 has 20, player 3 has 20, and player 1 has 12. And also notice as well that we've got player 2 winning, even though this is a tie. So that's one thing that we do need to handle. We need to handle that in one of the upcoming lessons in order to handle what we're happening here and how we can break the tie. So what we have to do is keep flipping cards until either one runs out of cards or one of them gets a higher card than the other. So that's the next thing that we do in the next lesson. So go ahead and add in the Boolean controller for running the game, also listening for the attack button to be clicked, and then giving us an option to run multiple rounds of the game. Hey, and welcome back. In this lesson, we're going to be fixing the playoffs. So in order to do that, let's update and tweak the number of cards that we're going to be working with so we can easier throw a tie game. So we've got 2 and 3s only, so we're only dealing out 8 cards, which makes it much more likely in order to get a tie. So going down to our function where we're making the cards, we're going to fix this function and we're going to shorten this one because in order for the tiebreaker, we're going to have to run a lot of the same code. So updating this, and we'll call this one deal round. And we need some information that needs to be passed in. So this is the player list of players that we need to do the testing for, as well as we're going to pass in temp holder. So that's the list of cards that we have to work with. So that's all going to get passed into the function. And this function is relatively going to do the same thing as we originally had the make cards do. So I'm going to copy a little bit of this out, where we're going to keep temp holder in make cards, and almost everything else we're taking out, and we're going to drop into our deal round function, including the updater. So let's grab that, and we're going to pass that in here, because a lot of this stuff we're going to be reusing. So what do we want to pass into that deal round holder? And we got to think for replayability. So let's create an object, an array, for, we can call it player list. And then we're going to loop through this player list. So letting x equal 0, and while x is less than player's length. So this is getting all of the player. We're going to loop through this block of code. And then in here, we can take player's x and we can update the inner HTML. So that will clear out that content there. That's the cards that are being shown. So this way, when we're doing the tiebreakers, we're going to list out a whole bunch of cards. And we're also going to check to see, this is also a good opportunity to check to see if the length of this is greater than 0. So this is the deck of cards that each player has handed, or their list of cards. And if they are larger than 0, then we are going to push that player value into the player list array. So as we iterate through here, this will create a list of existing players. And we might also want to keep that one as is and update only the value of the current ones that we're utilizing. So now let's pass over into the function deal round. We're going to pass over the player list as well as the temp holder. And the reason we're doing this way is so that we can constantly loop through here and have as many rounds of the playoff as needed in order to determine a winner. So going over to here, there's a few things that we do need to change. So we're coming in and we're setting our winner, so that can work the same way. And we're looping through, and this time we're not looping through all the players, but we're looping through the players list only. And we also need to set a variable. Instead of using x, we're going to have a value of player index, so temp player index, and this will be equal to the content coming from players list. And remember, this is a value that we had set earlier, and this is also the value that we're going to be passing in to this function. So when we list out player list, you're going to see the listing of players that are available. So no, this one's not going to work, but if we do get a match here, we see that the player list that we're passing in here is going to be a listing of all the available players that we have in play. So we've got the 2, 3, 2, and we're still always passing in all of the players. So we can use this index value, so it's going to be 0, 1, 2, and these are, of course, the players that we're utilizing. And it's going to be a lot more self-explanatory why this happened when we loop through this function again, when we call deal round within deal round, and we keep iterating through. We can get rid of the clearing of the HTML because we don't want to do this anymore, as we've already doing it up here within that initial function where we're calling the deal round. So the next thing that we want to do is we want to get back and return back, checking to see if the player has cards. And the way that we can do that, again, we can use the deals array, and then now we've got a new index value. So this is coming from the player list. So this is the list of players that are currently in play that we want to select, and we're checking to see if the left or how many cards they have left. So everything with deals is how many cards are left in play, and we're going to keep this within an array. And we can loop through, and this will return back all of the player information. So this is all where we're updating and we're getting cards in and so on. And actually this should also be included, that we're pushing and we're showing the cards. So if the player doesn't have any cards left, then we're not going to show any cards, and they're automatically not going to be included as a winner because obviously they don't have any cards left to play. So they're automatically going to lose and they're going to be out of the game. So that's what this condition is going to do. So next thing that we want to do is we want to get the card, and the card that we want to get, instead of X now, it's going to be player index because we do have a separate index. So originally when we have all three players in play, we're using 0, 1, 2. So it's the same thing that we were doing with the players list. But now, because we're selecting out that index, this might change. So we might not have all the players in play because there might be only a few players that are within the playoffs. So we're getting the card now from temp player index, and then this functionality is the same. We don't need to get all of, we only need the current player value, so we don't need to pass in the card because we're not really utilizing that. So let's grab that player value, and instead of X, this value is going to be the temp player index value. So that shortened that a little bit as well. And instead of X over here, we're updating with the player index. And then lastly, when we show the card, we're updating with the player index. So see how that works. And right now, we're not going to see much of a difference because we haven't had an opportunity to add in our loop yet. So this is where we initially planned to do the playoff, and this is where we can apply a condition. So I'm going to get rid of that functionality, and we're going to apply our condition. So we're checking to see if playoff length is greater than 0. And if it is, that means that we do have a tie. And if we don't, then we're okay to apply the updater function. So if it is greater than 0, then what we're going to do is we're going to loop back into deal round. We're going to pass in the current available players, which are going to be sitting in the playoff array that we've built out. So notice over here we're adding those winners in, so we're adding them in here. And actually this function should be sitting outside. So this will give us the opportunity to add multiple into the playoff. So if we have more than one in the playoff, we can continuously add them in. So that was just a quick fix there. So going by, and we're adding in just the index value of the player. So that's where we've got within playoff. And so now when we're passing in playoff, it's going to be the same thing as the player list. And we need to still keep temp holder because this is the amount of cards that are going to be 1. So ultimately, once we don't have any more ties, then we're going to run updater and we're going to pass in the winning player and then also pass in the amount of cards that they've won. So let's see how that works. So we see that now over here, we see we've got a 2, 3, 3, so that was a tie. And then player 2 ended up with another 3, and player 3 ended up with a 2, so they ended up losing. And at the end, player 2 won 5 cards, so they won all of those cards. So now they're holding on to 6 cards, and player 1 has 2. We can run the attack again, and what happened here is that we have player 2 won 5 more cards, and so we ran the first round there, so 2, 2, 3, 3, and then player 1 ran out of cards and player 2 ended up with all the cards. So this is where we've got our winning condition. Another thing here is that we should be clearing out that player 3 content because they don't need to be showing that anymore. So let's update this where we're setting the value as we're making the cards and that we're always clearing that out because we're outputting the lost anyway if the player doesn't have any cards left. And we can adjust that if we want, so we're not constantly outputting lost, lost, lost. Maybe if they're out of the game, then we want to have something more permanent, so we can do that as well. So again, let's try that out, and we can see that now player 2 ends up with 7 cards, player 1 has 1, and then lastly, player 2 ends up with 8 cards, and player 1 has now lost. So we actually have an ending of the game where we've got the ability to run an end of the game, and both of the ones that end up with lost are lost, and this is the point where we can restart the game. So when one player has all of the cards, we can restart the game. So I know this was a fairly complex lesson, but do add this in, and then again, the reason that we pulled all of this functionality out is because we're reusing it within that win condition when we're considering the tie game, and we needed ability to send information depending on who is within which players we should be looking at and which one should be drawing another card. And then we're also still comparing which one is the winner until we get a clear winner and until we reach a point where we only have one winner, which is applied with the logic here. And then that one winner that we're passing in here ends up with all of the cards. So go ahead and update this in your project. And coming up next, we'll do some tweaks and adjustments to the gameplay. Welcome back. How is your project coming along? I hope you had an opportunity to try out some of the code. This lesson, we're going to be updating and tweaking and having a win condition. So keeping it at only dealing out the 8 cards. And we can see that sometimes whenever we're only dealing out the 8 cards, we almost have a winner here. So player 1 is lost and they're pretty much out of the game. And if we do one more attack, we're going to see that player 3 is now out of the game. So we should have a clear condition and checking to see if player 8 is winning. So we need to have a full count of how many cards are in total. So let's create a global object. We can call it total. And then as we build out the array, we can increase the number of total. So when we build out our deck of cards, so we know how many cards are in total. And that means that we can also look for the number of cards and see if one player has that many cards equal to that number of cards, and then we know that they've won the game because they actually have all of the cards. So where we're building the deck, and every time we add a new card, we can increase the total by 1. So this will give us the total number of cards that we've dealt out, and basically a total number of cards that are available. So over here, where we're checking and we're outputting if the player has lost, we should also run a win condition here, meaning that if a player has the deals length is equal to total, so we'll do a quick check here, if deals length is equal to total, then that player has actually won. So we can set the inner HTML for that player to be equal to winner. And this is where we can also run the restart function. And if this is not true, then we can go ahead and we can do as we've done before, where we update and we add the card information. So let's see what happens. So now whenever we hit attack, you see that we get a clear winner. So we can actually run the win condition, because at this point, this player has all of the cards. And we can also output the card's length as well. So there's a little bit more information. And sometimes you do have to kind of play through it a few times just to make sure that everything is working as expected. But now we see we've got winner, 8 cards. So that means that we got all of the cards. And we want to run our win condition here. So let's create a function and we can call it win game. And we're going to run this. So this is what happens when the game is over. And what we need to do at this point is we need to reset some of the options that we've got a clear winner, and we want to reset some of the options. So we want to be able to select the number of players, give the players the ability to restart, and then have all of that functionality once again. So we want to run our button toggle function. That's one of the things that we want to do. We also want to output information. So we can clear this out and looping through. So let x equals 0. And there's a number of ways to do this. So looping through all the players objects again and incrementing x by 1. We'll get the player's inner object and update its HTML. So we can update the information, or we can do winner lost if we wanted to. So deal x length and ternary operator. So if this value is greater than total, then this is the one that's the winner. So we can write winner. We'll make this all uppercase. Otherwise, we can write loser. So we don't have to repeat ourselves, so we can get rid of this winner here. So total cards. So that's what we'll output, and then we'll append to the inner HTML winner or loser and take that message area, and we're going to update that to have inner HTML, select number of players. So we always have that option again to select the number of players. And we might also want to update the query selector, selecting the input element, and we can update the value to equal 3. So it's not, in case that attack round has been set to quite a bit more. So see how that works. So now we've got, and unfortunately, so it has to be equal to. So greater than or equal to total, because of course it's equal to the total. So we've got winner, loser, loser, lost. So all of that information is being output, and we can restart the game. So we've got start again, and we see that we've got a few problems that showed up. So we need to take care of that and do some bug fixing in the upcoming lesson. So now we've got the win game, and we've got to reset some more information here back to its original when we start the game. And so that's maybe something that we do when we start the game, is that we're going to clear out this game area. So coming up, we're going to do some bug fixing on the application. Hello and welcome back. In this lesson, we're going to be doing some bug fixes, tweaks to the code. And we noticed in the last one, and where we last left off, when we do the start game, then we're not actually clearing out all of this content, and we've got the content repeating itself. So it doesn't look very good. So this is one of the options that we need to do, is to clear out that element. And all of the content happens within the gameplay area. So we can clear out all of gameplay and have that completely cleared out and reset back to its original. So we can do that as we start the game, taking the gameplay object and just simply clearing out all of the inner HTML, setting it back to blank. So that's just 2 double quotes there. So see how that works. And I'm going to keep the amount of cards to a minimum so that we can really get a better sense of how this is working. We're also trying to apply style to card that didn't exist. So what happened here is that we actually ran out of cards, so we had no clear winner. So we need to have a default winner, and both of them actually ended up losing. So in this type of scenario, this is probably going to happen very, very rarely when we get more cards, but it is a good thing that it did catch this, that we do see this error being thrown, and this means that we need to have a default winner no matter what. So the problem here is that we don't actually have a default winner, and we're still trying to pass it into the updater. So we don't have a current winner, but we didn't end up with the playoff round because both of them ended up as 0. So the current player, so by default, we should always set a current player, and maybe for instance, the default player for this round, it should be whoever the player list is and whoever the first player in the player list is. So set the current winner to be that player. And again, within that current winner, and this one actually should be null. So let's update that, and I don't know if we can reproduce that, but at any point, we're always going to have at least one winner, and it's going to be the first person coming in if it's a complete tie game, if both of them are running out of cards. So in this case, we do see that we've got clear winner here, loser, loser, lost, lost, total cards. So we also need to maybe move down this winner, this lost value, as it does look like it's coming in and we're updating the inner HTML. So let's add in to this. We'll just add in a line break in front of those because we are updating the HTML. So let's do a quick refresh and start again so we can list the number of attacks, and eventually we end up with the winner, and then we end up with the start game. So let's start, and in this case, let's do 10 attacks and see what happens. So what happened here is we ended up with the winner, and it didn't continue to play because obviously we've got a winner. So we need to actually update and have it out of place. So where we set that in play default value, we need to set that as false so that the game stops playing, so it ceases to play once we do have a winner. So we're setting that, and once we do determine a winner within that win condition, this is where we can set this value, the in-play value, to false, so that it won't continuously keep playing after we've already found a winner. So let's see what happens in this case. So we can do the attack, and let's do 100 rounds. So really what should happen here is, and what actually did happen is, we only ended up playing 2 more. So let's refresh and try that one more time, just to make sure that the gameplay once again is as expected. So if we do 10 attacks, we end up with the winner there, and we can see that that's coming in as a winner. We also probably want to adjust some of our styling that we want. So there's an overlap here, so we don't necessarily maybe want that to happen, and within that play area, we can set a background color if we want, a gameplay area background if we want. And we already have some settings for that player area, so we've got a height. So maybe if we want to set a minimum height for that. And then the gameplay area, we can have a background color for that so that this one can always adjust, and it's always going to have a white background. So that way we don't have the overlap as we saw earlier. So we've got some more space to play with this time. So let's do 10 attacks, see what happens. We always end up with the winner or loser. So let's try different number of players. So in this case, we've got 4 players. And we can shut the console. We'll get rid of the console messages. So 1 attack, and then we've got the last attack, ends up with all 8 cards. So this is the end of the game, and we should be starting a new round. Something's gone wrong here where we're not actually looping through and we're not playing the restart. So something has gone wrong there when we switch the number of players. And this is why you do really need to try this out and make sure that things are working as expected. So also, if we only have that one active player, that means that that one active player is the winner. So where we're sending and we're listing out the make cards, let's check to see if this one, and if the length of player list is equal to 1. So we'll do another condition here. If the player length is equal to 1, then we know we've got a game over situation. So we can run the win game function once again. So let's try that one more time. We'll do the same thing where we've got the 4 players. And we'll run a bunch of. And we should also have a more clear message here that the game is over. So we've got our basic first attack there, and there wasn't really much of a difference between what was happening with the how many players. So let's update some of the styling there when we start the game and we output that information to the user. as we're still using that same message element, we want to make some updates to that. So default, when we start the game, let's select the message element and style, and we'll update the color of it to be red. So we come in, it's going to be red when we select the number of players. And then as we play the game, and when we hit the start button, we'll update the style and the background color of it to be black. And that means that we're going to set it to be red again when we've got the win condition. So we can better distinguish between when we're starting the game and when the game is in place. So going back down to our win condition, we're going to update the style value. And we might also want to make the message bigger as well within our CSS. So again, there's a number of different tweaks that you might want to apply to the game at this point. So setting up a font size, adding in some. So now it's more distinct that the game is over and that we're restarting. We might also want to change the button colors, the input colors. So there's another option that we can do where we've got buttons and we've got the two buttons there. So we'd have to loop through both of them in order to apply styling to them. And that's if we wanted to apply the styling to them. So maybe we do want to have a different button for the start, different color for the button for the start, as well as a different one for the attack. So going into this, let's set a class of start. And this one is going to have a class of attack. And then within the style properties, you can update those. You can also do it with JavaScript, but it's going to be a little bit more complex. So font size, and maybe we want to make it 1.5 EM. Text align, center align, padding, and let's set a background color for this. So we'll set the background color to blue, and its font color to be white. And for attack, we'll make the button different so that we can distinguish between the buttons. So this was one of the things with the buttons. When we had them the same, then it was hard to distinguish as we flip through the two different buttons. So now we've got start and we've got attack. So it's a little bit different. Also, maybe we can do it black as well. Also for the input, we can update the size of the input as well. So now it looks a little bit small, so we can set a default width for this one. And I don't want to make it too wide. Let's have a really big font size and see what that looks like. It needs to be a little bit wider than that. So refresh. And because the font is so big, we need even wider. And actually even wider than that. So we can enter in 3 characters there. So number of players, 300 players didn't really work out well. So let's do 3 players. We'll make it big, and number of attacks. So do 100 attacks. So we end up with the winner. We only end up with 4 rounds there. So now we're back onto the start. So we need to select the number of players. So we can do 6 players. We've got attack. So this one has 7 cards. That one has 1. So we end up with another attack here. And we can play it round by round. You see that it works no matter how many players we end up with. And now we're back on selecting the number of players. So it does take sometimes to play through it. And you can, of course, adjust how many cards you have by adjusting the number of ranks. And this is really good for testing. So once you've completed all of the testing on the application and you're happy with the way that it works, you can readjust the values, and we can have 10 players if we want, and so everyone's going to get an equal number of cards. You see that now it's going on to another row, so it's not really ideal for this size of screen. Made it a little bit smaller. We do the attacks, and you can see that everything is still working, and we end up with the ones that are winning and losing. And this one, maybe we want to do 10 rounds and another 10 rounds until one of them actually, or 2 of them drop out and we get a clear winner. So it looks like we're down to 2. And the functionality is working properly. We end up with the winner, total of 52 cards, and we can restart the game. So it's working on the larger scale as well as we adjust the numbers. So now it's up to you. Take the code, try it out for yourself, make some adjustments, make some tweaks to it. And remember, when you are in testing, it works better if you have less cards to deal with, and then you can scale it up and try it out on the larger scale. You can also go through and you can clean out all of the console messages as we don't need them anymore. So just going through, I've cleaned all of those console messages out, And coming up next, we'll do a quick code review. Hi, and welcome back. This lesson, we're going to do a quick code review. We've got our application working as intended, and now we can do a quick code review, reviewing all of the functionality that we've created in the earlier lessons. So we added some styling to make it look good, and of course, you can apply your own styling and make it look and apply your own customized look and feel to this game. So the styling I'm not going to be reviewing. This was just for a better look and feel. We also have our HTML, so our HTML structure of the application. So this is where our starting point was, and the way that we usually design the games is we come in and we determine what interactions and what information we're going to need to play to the user, so what interactions they're going to need in order to play the game, as well as what we need to output to them. Next, we use JavaScript to connect to the document object model, to document objects elements, so connecting to those elements using variables in JavaScript, so connecting to those instances. And this gave us the ability to really access those within the code. We also had to set up a bunch of variables. So the deck is where the deck of cards is sitting. The players array is going to be containing all the player information. And you can see this as you output in the console. So once we've got our players array, you see that all this that's contained within here are the divs. And these are the output divs, but they also give us a count and a count of which players are active. So if we have a number of players, if we have 4 players or 5 players, so this is all dynamically generated, and we get access to all of those elements there. We also have another array that we created, so that's the deals. And what the deals is essentially what cards the players have contained within their hand, and then this is what fluctuates as we play the game. We also have rounds, so we have an option to have multiple round attacks. So rounds are always at 0, and we loop through multiple rounds. In play gave us an option to set it as true or false, and that allowed us to continue the play or restart the play. And then lastly, we have total, which basically was just a total count of the cards, and it allows us to be able to detect which are the winners. And then the ranks and suits were arrays that we used in order to build the deck of cards. We looped through the buttons, adding event listeners to all the different buttons. We have 2 buttons essentially on the page, so we have a start and attack. And we have different functionality for each one. So we detect what the inner text is, what the text content of that element is, and if it's start, then we set the message color to black. We toggle the buttons, and the toggle the buttons function, basically what this is, it's toggled the hide to the button. So if it has it, it removes it, and if it doesn't have it, it adds the class of hide, and what hide does was show it. So that gave us that functionality where we've got the start button, we click start, and we end up with seeing only the attack button. And we also toggle the buttons when we win the game in order for us to restart the game. We have a start game, so this is basically our setup function where we set in play to true, we clear out the gameplay in our HTML, we set up the number of players within the input there, so we grab the number of players that the user has asked for, so 3, 2, whatever. We build the deck of cards, we set up the players, which set up the arrays, deals out the cards and deal cards, and this was our starting card player that we were dealing to. And then we were making the cards, so that was the round where we show the cards visually to the player, so that was the make cards function. And this was one of the crucial ones where every time we want to redeal the cards, or this could also be dealing the cards out to the players. And then we also were updating that input value to 1, because instead of the number of players, when we hit start, this is how many rounds we're playing in the attack. So by default, maybe we only want to have 1, but the way this game goes, sometimes it's more fun if you can play multiple rounds at once, so you don't have to keep pressing attack, attack, attack. So that's what we have that option for the player. We also have one to show the cards. So basically what happens here is we construct the card, creating elements using JavaScript create elements, and we construct the card. So we also used our styling in order to style the look and feel of the cards to make them look more like playing cards. We have deal round, which is a function that we created in order to handle the playoffs, and a lot of the functionality was the same as when we deal the cards. So this was where we determine who the winner is. We loop through all the players in the player list. By default, it's going to be all the players. And then as we play the game, the player list can shrink. And also if we have a playoff situation, then the player list is only going to include the players that are in the playoffs. So and this is going by the player's index value. So it's not 1, 2, 3, it's 0, 1, 2. So as it falls within the array list. Temp holder was the noun of cards that have been played and have been drawn. So basically what happens is that the temp holder array of cards ends up going to the winner once we determine who the winner is. So all of this was to determine who the winner is. We also select a card from the player's hand, and we check to see if it's the high card, and if it is, then we add it into the winner. If it's the first time, if there's no other cards in the playoff, that means that we need to push the current player as well as the new player. So that gives us the two players in the playoff situation. We also have our current winner. So we determine if we have a current winner and the card value of the current winner. So we're adjusting who the current winner is at that point. And then we're adding in the selected card into the temp holder. So because that card has been played, so we're adding it into our holding section. And then show card function allows us to show the card. So we select and we show which player we are showing the card, so by index value, which also allows us to select that element object. So essentially players and the temp player index value selects the element that the cards are going to be output to, and then the card information is passed into show card as well. And we keep going through until we have no more playoffs. And if we do have a playoff situation where we have a tie for the leading card, then we have to go through deal round again, and we're passing in those two players, and as well as we're adding in the temporary cards. So going in and we're continuously loop through this function until we find a winner. When we find a winner, we pass that into the function called updater. Make cards is the one that we run by default when we attack. What this does is it sets a basic holder section for the cards, and this is just going to be blank. So we don't actually need to even pass anything in here. We could do this to shorten the function if we wanted to, as we don't have any content being passed in there. The players list we do build as we loop through all of the available players and see which ones' hands have more than 0 cards. And if they have more than 0 cards, then we push them into the list so that we can play through them. And if the players list length is equal to 1, so this is a failsafe, that if we only end up with one player in the game, then we automatically run the win condition to break them out of the game. The win condition resets the messages, toggles the buttons, sets in play to false, outputs information, who the winner and who the losers are, and then also resets our original message so that we can restart the game and select the number of players, updates the input value to be 3. Updater is the function that we run when we've selected a winner. So we get our winner, we know who the winner index value is, as well as the temp holder. So then within players, we get the winner, passing in the style and updating the background color to green so it's more visual who the winner is. We resort the temp holder so that it's, this was just a really quick function to resort an array randomly. So that we don't always have the same order of cards. So we play around a little bit with the order of cards. Then we loop through the temp holder. So we loop through all the cards that are being held temporarily, and we add them to the winner's hand and list of cards. And then we also loop through all of the players. We create a div. We update the stats. So we add those stat information down here at the bottom. And then we also check to see the length. And if the length is equal to the total, then that means that we've won the game and it's game over. We update the inner HTML to the card length, and we just output some information that that player is now the winner, and we run the win game function. Otherwise, we output that they've lost and how many cards they have left. And then lastly, we append that value. So you see that happening here, where if we get how many cards are left for each one of the players. So that gives us some stats to work with. And then we also update the HTML of this tracking information down here below. So that gives us an overview of what happened on each round. Here we've got dealing of the cards to the players. So we loop through the deck of cards. And as we loop through, we add it to the player's hand. So the players each get a set of cards dealt out to them. This is where we're setting up the players. So we're building out the initial players. When we hit start, we've got the player 1, player 2, player 3 elements. So those are being created in setup players and created dynamically. We're setting the attributes to the player ID, which we're not using, but we could use if we needed to. We're also updating and adding a class of player, and then updating cards, appending it to our game area. So building that div and then appending it to the game area. And then we're also pushing that into the deals in order to prepare for slots to have an array with arrays inside of it that we can deal the cards out to. And then, so this is all done dynamically, so we have flexibility and we can select how many players we have within the game. Next, we're building the deck. So this was one of the first functions that we run, and this gives us the ability to create a new deck of cards. So when we want to have a deck of cards, we can just build a deck, and we can do it within this type of format. So within the card object, we get suit, rank, value, and we can push the card in. And then we're utilizing the values to determine who had the winning card in the deck. So that was a quick summary and overview of all of the functionality that we've covered in the earlier lessons. If you have any questions or comments, please let me know in the section. I'm always happy to help address any questions, clarify any content. Thanks again for taking the course, and I do want to remind you that the source code has been included, so I do encourage you to try it out for yourself, experiment with it, and build your own version of the game. This lesson is going to be a quick fix on an issue as we're debugging our application. So sometimes you do have to play through the game and you can detect if there are some instances of a bug. And in this case, what's happening here is that if we do have two matching cards, they're still going into playoffs, even though the last player beat both of those cards. So this one actually should be the winner. Player 3 should be the winner, and he should have won all 3 of the cards, and this should have never gone into the playoff round. So there is a code update that we have to do, and the place to add that in is where we look and we see that if we have a greater than the current high, then what we're doing is we're overriding the winner. And we should also clear out the playoff values, as in this case, we're running through and we're clearing out all of the playoff content. Values anymore, and we just can clear that out. So we're clearing out the playoff array if the current card value is higher than the current high card. So let's try that out. And again, in order to test this out, ranks values, so we're playing with less cards, so we can better simulate this occurrence happening again. So go ahead and make that quick update of the code. It might take a little bit of time to reproduce the error. So over here, we were able to simulate that issue that we saw earlier, where we've got one player that gets the high card, the next player gets the same high card, so these two are in a playoff situation, but then the third player comes along and beats both of them, and this is what's happened here is where player 3 ended up canceling out the playoff between the first two players because this one ended up with a higher card. So that was a quick fix and a quick debug on the application. So go ahead and make that update in your code.
Hey everyone, welcome to a brand new course on advanced theoretical JavaScript, in which I want to cover a lot of under the hood things and a lot of exciting stuff about JavaScript, how it internally works, so that you can have a better mental model of the programming language you have been working with. Now, before we get into this course, I would actually like to discuss whether this course is for you or not, because it might very well be possible that you're watching the wrong course at the wrong time. You might need this course sometime down the line, but not today. So let's just quickly discuss that in the next video. I'll see you really soon. Let's just go to the next video to discuss that. Alright guys, welcome back. And in this one, I want to just briefly go over if this is the right course for you at the moment. Now, if you have been following CodeDam learning paths on codedam.com/learning paths, you're going to see that JavaScript sits right here in the front-end learning path, which is a big thing, like becoming a front-end developer. but I absolutely do not recommend to dive into the internals of the language when you are just getting started with it, right? Now, for some people, it might be a good approach because, a lot of people actually learn in a way that, they have to just know at least a bit about how everything is working. But if you are someone who's just getting started with JavaScript, I would say either do not watch this course yet because it might become too overwhelming for you, or maybe just take it lightly. Like, you can just go ahead with the course, but don't stress about things if you do not understand them yet. You're going to understand them sooner or later when you work enough with JavaScript to have that actual experience. So don't worry about things you do not understand. You can always ask the community in the discussions below. You can always ask me on the Discord group. You can always ask anybody who's working, right? So do not stress about things. Just take it lightly. And of course, if you are an experienced person who has worked with JavaScript a bit, created some applications, or maybe worked on Node Server, this is the absolutely perfect course for you, because in this one, I'm going to actually teach you a lot of internal things here and there, which almost no course on internet would teach you collectively. So this is going to build up your better understanding of JavaScript, internals, how it works, and basically give you a mental model of what happens under the hood when you're actually writing the JavaScript code, how your code is executed by the computer you're working on. So yeah, that's it for this video. I'll see you pretty soon in the next one. So what is ECMAScript anyway? So for the most part, what you have to do whenever you see somebody's making use of ECMAScript, that maybe this job requires ECMAScript or you should have this much experience with ECMAScript, ECMAScript basically means JavaScript. In all the cases, you can just replace the usage of ECMAScript with the word JavaScript. Now, the reason it is called ECMAScript as well is because it is a formal name for JavaScript, and there's a community, there's a standard called ECMA International, you can see right here, which is responsible for drafting how JavaScript should behave, right? In the web browsers, at least. So this is ECMA International is a standard, right, which standardizes JavaScript, the usage of JavaScript. And it was not very active in the past. That is, I'm talking about 2004 or 5, time like that. But in the recent years, ECMAScript is super active, especially from the release of ECMAScript version 5. So yeah, we're gonna cover a lot about that. What is the versioning in ECMAScript and what does that mean? But for the most part, what you have to remember is ECMAScript is literally JavaScript. So yeah, that's basically it for this video. I'll see you in the next one, where we will discuss more about what these versions of ECMAScript really mean, that ES5 is out or ES6 is out. And yeah, I mean, you should just know about the standards of JavaScript before, even if you have not worked with them earlier. So yeah, let's see you in the next one. Alright everyone, welcome back. And in this video, let's just go ahead and take a look at the available Ecmascript standards so far. So you're going to see that if you take a look here, you're going to realize that the first edition of the JavaScript, and by edition, what we just mean is a set of features in a language, a set of syntax features, a set of how the browser engines would interpret your JavaScript code, stuff like that, right? So the first edition of ECMAScript, that is JavaScript, was released in June 97. And yeah, because it was first, so there's no change log really. Then, it made all the way progress to 2, 3, 4. And yeah, the real changer, the real game changer of ECMAScript was the actual ES6, not even ES5, right? So ES6 was released in June 2015. You're going to see that before ES6, you see that there is a lot of gaps between the years, except the first 3. So you have a 4-year gap here, then another 6-year gap here, then another 2-year gap here, and then a 4-year gap. But from that point onwards, you're going to see the community is actually very systematic. The community is actually very ordered and has been regularly releasing the new standards every single year in the month of June. So yeah, you can see that. So what's the deal with the ECMAScript standards is that ES6 actually made JavaScript much easier by introducing a lot of new features. Before ES6, there were ways to do things like, if you wanted to have a class-based behavior in ES5, there were ways to do that using objects and using new keyword to instantiate, just instantiate functions like classes if you're coming from an OOP background. But ES6 brought in a lot of syntactic sugar. ES6 brought in the module resolution system, which, people are still not able to use because of the browser support. But yeah, ES6 brought in arrow functions. ES6 brought in the let and const keyword. Before ES6, they were not available. So yeah, ES6 actually changed the picture for the JavaScript, right? And almost every major browser right now fully supports ES6, right? For the most part. Not all the features, but yeah, browsers are quickly catching up on all the features which did not really have a lot of support before. Because ECMAScript is moving so fast, that is, they're releasing something every year. So ES7 brought in the support for await, async await, which is built on top of promises. And yeah, ES6 had one major release that was promises. So promises actually changed the whole picture of how asynchronous programming is done in JavaScript. It was very difficult to manage huge code bases of JavaScript prior to ES6, simply because they lacked readability. They lacked common features which should be available in a language by default. They lacked all that speed and scoping and support. So it was usually the code bases were buggy, they were large, they were unorganized, and all sorts of stuff. So yeah, for the most part, this was a major release. Then ES7 came out. Just like I said, async await support was there. There was a multiplication operator also added. ES8, 9, 10, just added a bunch of features, refined on the RFCs for others, added some sort of methods and everything. And the current release for 2020 is ES11, right? Now, one thing you have to understand is that these are just the additions, right? So these are not, these releases do not mean that these features are available in the browsers as well. The stuff you're gonna see in ES11, which was just released in June 2020, is not available in browsers by any mean. That does not mean it is available for you to use in browsers. It just means that the ECMAScript, the ECMA international community, has come up with a draft. They're gonna discuss it with the major browser providers, the major vendors like Google and Apple and Mozilla, all that stuff. And these browser companies would then come up with some sort of procedure to implement those efficiently in their engines, in their respective browser engines, right? So yeah, if you take a look, you're gonna see that even ES6, which was released 5 years back, had a module resolution system, but still this is not natively supported in the browsers a lot. The support is now very good. You can pretty much use it in latest Chrome and everything, but it was not the situation from 2015. It has just got up support. Similarly for other things as well, it's the support is not top class, but yeah, things are looking good. So for the most part, you only have to worry about features like ES6 and above, right? Before ES6, there was not a lot of interesting things in JavaScript, but just buggy questions and trick questions with JavaScript. But after ES6 and all these additions, JavaScript has actually matured a lot as a language, has actually matured a lot as an ecosystem. And most of the people who were frustrated with JavaScript in the past, who hated JavaScript, I believe they were of the before ES6 age, right? So we can categorize developers who have used JavaScript in two groups: the pre-ES6 age and the post-ES6 age. The post-ES6 age usually love it, and the pre-ES6 age who are not working with JavaScript anymore, well, of course, they hate it because the syntax was bad, no features, no scoping, nothing at all, right? So yeah, for the most part, just remember that you're not gonna get into this ES678 mess a lot, but for the most part, yeah, this is what it all means. So one last thing, you don't really call it ES10 and 11, right? From ES7 onwards or 6 onwards, I don't exactly remember, but from that point onwards, you actually just call it ECMAScript 2017, ECMAScript 2018. You actually call this as ES6, this as ES7, but this is ES 2017, this is ES 2018, ES 2019. Well, it follows the years, but this is fine. Like calling ECMAScript 6th edition ES6 is fine, but not for this. You cannot really call it ES11, right? So yeah, for the most part, this is all the terminology you're gonna need for Ecmascript standard. I think that's all for this video. I'm gonna see you pretty soon in the next one. Hey everyone, welcome back. And in this video, I just want to discuss about the features which I was telling you shipped in standards like ES6, ES7, ECMAScript 2017, 2018, stuff like that, and the actual browser implementation for that. Just like I said, it's not possible that if ES 2020 ships with some feature that would be available in 2020 or even in 2021. You can see that I have a chart opened in front of me, which are the features of ES6, which are the proposed features of ES6. And you can often see that there are a lot of red boxes all around as well, right? So you're going to see a bunch of red boxes here and there, right? So for the most part, you can see all the boxes are green. The only boxes red in the popular browsers is the tail call optimization feature. But yeah, for the most part, you can see that most of the major browsers have actually implemented all the ES6 features, right? You also see these yellow boxes here and there. That just means that they're just behind a flag or something, or the support is not well. But yeah, for the most part, they are implemented. So ES6 is mostly done and dusted. ES 2016, that should be technically ES7, looks something like this, right? So you have all these features here and there, but you're gonna occasionally see red boxes as well, right? So this is the idea, right? So if you jump on to ES Next, that is the latest 2020 ECMAScript 2020 standard. You're gonna see you have huge number of red boxes because, just like I said, this was released in 2020, in June of 2020, but that does not mean that it brings in support for the browsers as well. You can see some browsers have green support, but not a lot of browsers have, that much support for all the features which ECMAScript 2020 starts off with. So yeah, for the most part, just remember, features you see in the more recent version of ECMAScript are most likely to be implemented sometime later in the actual browser implementation, so that you can use it without any transpilers, or you can use it without breaking the end user's code, right? So yeah, that was it for this video. I'm gonna see you in the next one. Hey everyone, welcome back. And in this video, let's just go ahead and discuss about DOM, that is Document Object Model. Now, I won't be going into a lot of depth into advanced JavaScript concepts because DOM is in fact not JavaScript. So JavaScript is a scripting language, but DOM, Document Object Model, is an API, right? So what happens is that browsers construct web pages using HTML, and they expose a certain API to a language called JavaScript. This could have very well been some other language as well. They just chose JavaScript. I don't know why, but yeah, probably JavaScript was made for it, but this could very well have been, I don't know, Dart or any language, right, which was available at that time. So DOM just means that this thing you see on the view page source, this is the HTML. Your browser, Chrome in this case, reads that HTML and it constructs a tree, right? A tree as in a data structure. So a tree is constructed starting off with the root node as HTML, then you have head, then you have head and the body tag as the children of HTML, right? And then all the stuff goes up, down, those things. So this tree is constructed, and what the browser does is that it says that, okay, JavaScript, now I'm going to give you a set of APIs, that is a way of programmatically interacting with this tree which I have constructed with the HTML the user has written, and I'm going to let you interact with this. By interact, I mean that I'm going to let you, just add the HTML element. I'm going to let you remove the HTML element, maybe change the attribute, add an attribute, remove the attribute, get the attribute value, show something on the screen, hide an element, hide the CSS, inject content dynamically. The possibilities are endless. So with this finite set of APIs exposed to JavaScript, you can do an infinite number of things on the web page, right? So this is what the DOM is about. If you really take a look at this, you're going to understand that JavaScript does not really need DOM to function, right? So DOM is just a little set of APIs which help you to interact with the page on which the JavaScript is running. But the actual logic, the actual JavaScript can really work without DOM as well, if you remove that DOM part from the JavaScript as well. For example, doing a calculation of 1 plus 1 does not really require DOM for JavaScript, right? It can do it on its own. Doing a calculation of 3 plus 3 won't require it either. Doing a difficult integration with some sort of library won't require it. So similarly, what happened is that a bunch of people back in 2010, what they did is they started working on something known as Node.js, which is JavaScript, but not in the browser. So it's JavaScript basically separated from the browser, given a little bit of more magic, and now it can actually work as a standalone JavaScript execution runtime on your operating system itself. Now, what that means is, again, because you're not running it in the browser, that means there's no web page or anything like that. That means you do not have access to those DOM APIs. And what do I really mean by those DOM APIs? I mean the window object and the document object. And basically, you can find document object on the window object itself. So basically, just the window object. The window object in JavaScript, you see right here, when you write window right here, you see this little object which pops up, right? So this is a DOM API. It's an application programming interface exposed to JavaScript running in the browser for you to interact with the page. So if I go ahead and write window.document, you're going to see that this is the document which is visible on the screen. Now I can go ahead, interact with the DOM, do a bunch of stuff, right? And window actually exposes a bunch of other utilities as well. So I won't say window is completely DOM, but yeah, window.document is 100% DOM, right? So you use those getElementByID, getElementByClassName, all these are actual API calls, right? Where the browser actually binds your JavaScript world and the DOM world. So yeah, this is what the DOM is. Your JavaScript does not need DOM to run as a language. That is why there exist multiple runtimes which are based on JavaScript but do not live inside a browser, like Node.js, for example, like React Native is another one. So yeah, for the most part, that's it for this video. I'm gonna see you pretty soon in the next one. Alright everyone, welcome back. Just wanted to throw in a quick little demonstration of what is the difference between a DOM API and a regular API. So you can see, just like I said in the last video, document.getElementByID is a DOM API, right? or maybe document.querySelector is a very popular DOM API. So if I do something like this, you see that I'm doing this in JavaScript. JavaScript does not really know what this means, right? So the JavaScript engine that is powering your JavaScript code, that is reading and understanding your JavaScript code, does not really know what do you mean by this. What it knows, however, is that this document object is provided by the browser. The query selector is also provided by the browser. So it actually performs a native call. So if you actually take a look here, when you run this, you're going to see the definition is it's a function, but has native code inside it. So if you try to convert it into string, you're not going to get any JavaScript code. Why? Because this native code is actually the C++ native code, the real code which is close to the machine, which helps the browser bridge the gap between JavaScript world and the DOM world, right? So this code would allow JavaScript to actually interact with the actual web page. Things on the other hand, like setTimeout and setInterval, you're going to see they are still native, but these are some additional utilities which are provided by the browser to you, right? So this setTimeout and setInterval is actually the part of the JavaScript itself. So what happens is if you try to go ahead, for example, I'm just going to take in a really simple lab for JavaScript here. What you're going to see is that if I go ahead and run an actual terminal right here, so if I go ahead and write node as an execution environment, what you're going to see if I try to write document.getElementByID right here, you're going to see I get an error right away that document is not defined. But I do not get any such error when I write it here in the browser. Why is that? Because this document object is filled by the actual browser which is running, right? Similarly, if you try to write setTimeout, it's going to work just fine. You can see we get a little bit of definition here. And similarly, setTimeout would work just fine here. Now, the reason that works is because it ships as an internal API for JavaScript, and it's available on the window object in JavaScript as well. Now, this is where a little bit of conflict arises because setTimeout is actually available on window object in the browser world, but there's nothing such as window object in the Node.js world, right? So in Node.js, you have the global object instead of window. So you're going to find setTimeout on the global object instead, right? So you see that setTimeout is available there. So it's just a matter of preference. Browser says window as the global object, Node says setTimeout as the global object. But for the most part, this is how the execution environments differ with each other, right? So yeah, I mean, I just thought that you should know the differences between the DOM API calls, that is anything you work with document.something, and the actual APIs which JavaScript ships with. So that would be all for this video. I'm gonna see you pretty soon in the next one. Alright guys, welcome back. And in this video, let's just take a look at what JavaScript runtime is, how it works, everything about that. So you're gonna see one of the most popular JavaScript runtimes is Node.js out there. But what the hell does it even mean to be a JavaScript runtime? So a JavaScript runtime just means that a particular piece of software, a particular piece of binary or whatever you can compile it down to, is using some sort of JavaScript engine. It's not just, Chromium or V8 or SpiderMonkey or anything like that. It could be using any JavaScript engine, but it is using some sort of just-in-time compilation machine or interpreter machine which understands JavaScript and maybe exposes a better set of APIs on the top of that. What do I mean by that? Let's just go over one more time. JavaScript runtime means that there's a software, most preferably a binary, which allows you to execute your JavaScript code somewhere. It could be a browser, it could be an operating system, it could be an IoT device, it could be a potato, wherever you want to execute JavaScript. It allows you to do that using a JavaScript engine, as simple as that. Now, there exist a lot of JavaScript engines, but JavaScript runtimes as well, and we're gonna be covering some of them in the next video. So that would be all for this one, and I'm gonna see you in the next one really quick. Hey everyone, welcome back. And in this video, let's just go ahead and talk about V8. Now, if you are moving towards intermediate and advanced concepts in JavaScript, you're gonna hear about V8 almost all the time. What is V8 and how it works? Well, V8, just like the site says, it's an open source, high performant JavaScript and WASM engine. Now we can just forget about the WebAssembly part for now. Let's just focus on the high performant JavaScript, right? So V8 is an engine written in C++. Now what happens is that your JavaScript code at the end of the day needs to be read by a machine, right? A machine just understands opcodes, and opcodes is just a fancy word for binary, that is 0 and 1. So whatever those nice fancy code lines you're writing, all those functions and statements, all of them actually boil down to zeros and ones. And somebody has to do that intermediate job of converting the actual English, the actual text you are writing, into the actual thing which machine can run on its processor, that is zeros and ones. Who does that? V8 does that for you. V8 is an engine, just like an engine takes in fuel, which is something humans can understand, and pumps out energy, which is something obviously difficult to generate and keep together, whatever. Similarly, V8 is a JavaScript engine which takes in your JavaScript code and spits out high-performant assembly, high-performant machine language code as well, which runs on your machine or client's machine or whatever on the server, wherever the JavaScript runtime is, and just helps you do things, right? So this is the function of V8. V8 is a layer between the machine and your JavaScript code, which is extremely performant, right? So there are engines like V8 as well. There are engines which compromise memory for performance, right? So they're going to be taking small memory, but then they will have less performance as well. V8 is kind of like an engine which takes a lot of memory and is highly performant as well. One of the reasons why there's this popular joke about Chromium and Chrome, that they take so much RAM and memory on a system when it's running, is because Chromium actually uses V8, and V8 is a high performance engine. And high performance, how it achieves that is by utilizing a lot of memory. Now we are not really getting into V8 right now, but that's how it works. It needs a lot of memory to be highly performant. So that's why your Chrome takes a lot of memory in the system. So now when you see that joke, you're gonna actually understand that why it happens, and the best way to avoid that is to close unused tabs, because the more number of tabs you have, the more number of JavaScript threads it needs to run, and the more the memory would be. So yeah, remove unused extensions, close tabs, stuff like that, dismiss tabs if you're not using, all that stuff. So anyway, that was a little introduction to the JavaScript engine. That's all for this video. I'm gonna see you in the next one really quick. Alright guys, welcome back. And in this video, I want to discuss about Node.js as a JavaScript runtime. Now, why I want to do that, I'm gonna take a bunch of JavaScript runtimes right now and just give you a basic idea of why they exist or what they do. So Node.js is nothing but a JavaScript runtime which wraps JavaScript with a bunch of useful utilities, right? So you can, if you have used JavaScript, you know that you can do a bunch of stuff with it. But what Node.js did is that it took that JavaScript out of the browser, put it on a computer, gave it the file system access, gave it the network access, gave it all those bunch of utilities inbuilt, which an operating system which you can use as a developer to interact with the operating system and just release it under Node.js, right? So you can see that here's a simple program in Node to actually write an HTTP server. Now, when you do write something like this, what it means is that your Node code, that is this code right here, is actually having access to the network of the computer. By network, I mean it can read your IP address, it can listen on the ports, it can interact with other networks on the system, it can accept connections on certain ports. So basically, this code right here has access to the networking on your system. If you think about it, you're gonna understand that the JavaScript which you write inside the browser, which runs, cannot really do that, right? And there are very good reasons for that, both for security standpoint of view as well as for performance. But yeah, for the most part, you cannot write an HTTP server which accepts request inside a JavaScript browser, right? Inside a browser using JavaScript. Why? Because the browser, the JavaScript running inside the browser, does not have those APIs with it. So what does this mean? Is this not a core JavaScript thing? Exactly, right? So HTTP package is not a core JavaScript thing, right? It is something which Node ships with. That is, it provides you as a utility to, just go ahead and interact with the operating system. So what happens is that you use that, it interacts just like regular JavaScript. So you create regular JavaScript functions and everything. But under the hood, this http.createServer actually does some native calls under the hood, right? So it opens that socket, it listens on that port using C or C++ or whatever, and relays that information back to the JavaScript world, right? So the processing of this code, like understanding what has to be done, is done by V8. That is, V8 acts as a layer between JavaScript and machine code, just like I said. But the actual access to the operating system is done by the Node.js libraries. So V8 would tell Node that, hey, this guy wants to call this particular function in your source code, but Node.js has that responsibility to have that code in place to actually listen to that particular port or particular socket, right? Now, again, if this is becoming too overwhelming, do not worry about that. Just go ahead and watch the video one more time. Slowly, you're gonna understand stuff, right? Just like I said, it might be a little bit challenging to grasp all this on the first go, but trust me, this makes a lot of sense when you have worked with Node or environments like that. So this is the idea. For the most part, the things which are not directly available to Node have their native code somewhere in the runtime itself, just like HTTP has a native code for opening HTTP servers. Similarly, you're going to have some native code for things like fetch request, for example, because fetch is done by the operating system, not by the JavaScript, and so on and so forth. So yeah, I mean, that's pretty much it for the Node.js runtime. What these guys did again is took JavaScript out of the browser, put it on a computer, gave it magical powers like working with networks, file systems, operating systems, stuff like that. And there you have it. You can now run Node on servers. That is JavaScript on servers using Node.js. So that's all for this thing, that is the Node.js runtime. I'm gonna see you pretty soon in the next one. Alright everyone, I'm quickly gonna talk about two things, React Native and Nativescript right now. So strictly speaking, I'm gonna come to React Native later on, but for the Nativescript part, you can pretty much call it a runtime, right? So Nativescript can be called as a runtime. Why? Because you can actually, if I can just show you some demo or some sort of example, that you can actually access native APIs, that is the native alert or toast in Android, just using the JavaScript calls, right? And how these guys do it is that they expose the actual APIs of the operating system to the V8 engine, to the JavaScript engine itself, right? Which these guys use. So let me just go ahead and see if I can get some some sort of example for you here. I'm not really sure if I can, but let's just take a look. So looks like we don't have a lot of examples here, but yeah, for the most part, if I go ahead and take a look at this alert, what you're gonna see, this alert right here, which you see, that is all right, no thanks. Okay, this alert and prompt, you see that you import this from some sort of package, but what is really happening is that these are the native alerts, that is the native iOS and Android alerts and native iOS and Android prompt. So this is exposed to JavaScript, which makes it a custom runtime, because this is not really part of JavaScript language itself, right? Just like we had that HTTP module and file system module exposed in Node to be used as JavaScript thing. Similarly, you have alert and prompt, which are custom modules for the operating systems like Android and iOS. So again, Nativescript is a runtime like that. Now, you can technically call React Native as a runtime as well, but React Native tries to pitch itself as a framework for rendering cross-platform applications, right? And yeah, for the most part, I guess the definition kind of works, because you can use JavaScript to interact with the native side, that is the native operating system, but there's a bridge which actually sits in between. There's a lot of work going on React Native as well. They are trying to shift it to the Nativescript architecture, like exposing the actual operating system APIs directly to the browser, to the JavaScript world, just like what's happening right now with Nativescript. If I can just give you a little quick little 2-minute demo with that. When you write document.getElementByID, what you see is that the native code is called directly, right? Similar thing happens in Nativescript. So when you write alert in Nativescript, in the Nativescript world, not in the browser, you're gonna see you still get native code. You're gonna still get native code in the Nativescript world as well, right? For the React Native part, right now in July 2020, what happens is that when you try to access some sort of native API, what it's going to do, it's going to send that action on the bridge to the native code, to the real native code, that is Java and Swift or Objective-C or whatever. And that native code then understands the request and then executes it. So it's more of a two-way process. That first JavaScript calls the native code on the bridge, and then the native code invokes the actual requested action. But this right here is a one-way call. JavaScript directly calls the native code responsible for that particular thing, right? So React Native team is, in a sense, they're trying to build that architecture where you can just simply call all the native code simply from the JavaScript world. So they are doing that, and that would really truly make it a runtime, again, just like Nativescript. But yeah, this was like one of my examples I wanted to show you, which the Nativescript world is doing on right now, where the JavaScript world is going on right now. So yeah, this was one another example for the runtime. I'm gonna give you one more with Electron in the next video. So stay tuned. I'm gonna see you pretty soon in the next one. Hey everyone, welcome back. And in this video, let's just discuss about Electron as a JavaScript runtime. Now, what Electron is that it ships with, just like we know, JavaScript, but what it does is that it includes support for HTML and CSS as well. Can you guess what other application does that? Well, that's right, that's the browser, right? So a browser ships with these three things: JavaScript, HTML, and CSS. So what's the difference between Electron and a browser, right? So why does Electron exist? Well, why not just ship a browser instead of Electron, a little browser which you have built by yourself? Well, the first thing is that browsers are captured. Browsers actually captures the tab in a very strict sandboxed environment, right? So the JavaScript running on this page cannot really affect my computer in any way. It cannot really shut it down. It cannot really access all those files I have. It cannot really access other tabs, nothing. So it is running it inside a jail, right? So it's a jailed environment for JavaScript inside the browser. When you're using Electron, you get access to HTML, CSS. Sure, you can, draw all this beautiful stuff, but the JavaScript is not in the jail. By that, what I mean is an application, is a desktop application, obviously might have some requirements where it has to access your file system, right? It might want to access your network for opening a HTTP server. For example, if you're creating a graphical user interface based application for launching a server, then that's the use case, right? So the JavaScript inside Electron is not jailed. So that is why Electron is a runtime. Why? Because Electron comes with kind of the Node.js benefits, right? So Node.js comes with, file system and HTTP and all that stuff. So it comes with the Node.js benefits, but it also includes support for HTML and CSS, the actual renderer for the web pages, so that you can actually build real stuff, right? So if you see, you're going to see that Visual Studio Code, VS Code, the editor most of the developers use on planet, is built with Electron, right? WhatsApp's app is built on Electron. So the Twitch app is also built on Electron. Microsoft Teams, Figma, all these, super popular applications are built on Electron. So yeah, under the hood, Electron again is also using the same architecture like a regular typical browser, that is JavaScript, then a Chromium V8 engine or any other engine, but Electron uses Chromium. Electron uses V8. So yeah, that's for the most part. So Electron is yet another runtime for JavaScript, which allows you to build cross-platform desktop applications. So yeah, this was yet another example for what could be considered as a runtime, and most of these runtimes have their separate demands. Like, you can become a mobile app developer if you know about React Native or Nativescript. You can be a backend engineer if you know Node.js. You can be a front-end engineer if you know JavaScript on the web browser. You can be I don't know if that's a field, but you can be a desktop app engineer if you know how to work with Electron. So stuff like that. Single language, JavaScript, is everywhere. And how it is possible is because of the high-performant Chromium engine, high-performant V8, high-performant engine worked on by Mozilla, and all those development with the Ecmascript Standards. So that made JavaScript truly universal, truly popular, and truly, to be able to use anywhere. You need to just have that runtime available for that particular place, right? And I'm pretty sure if you just Google about IoT and stuff like that, you're going to find little JavaScript runtimes there as well. JavaScript engines would be available for those part as well. So yeah, for the most part, that's it for this video. I'm going to see you pretty soon in the next one. Guys, welcome back. And in this video, I want to discuss, and in this whole section, actually, I want to discuss a little bit more about V8. So I already discussed about what V8 is and more or less how it works under the hood in my previous video, but let's just take a little bit of time to actually understand what's going on with the JavaScript language actually, because V8 is the machine, which is the step 2, what happens when you write your JavaScript and runs. The step 1 is obviously writing your code. Step 2 happens when you run that code. So V8 takes over and does all that stuff. So let's just go ahead and take a look at what this bad boy is and how it really works. Hey everyone, welcome back. And in this video, I just want to take a little bit of time and make you understand what JavaScript language it itself is, and how does V8 play a part in that. So JavaScript is basically a just-in-time compilation language. So what I mean is that when you actually write your code in JavaScript and run it on the browser, for example, when I load this code and I load this, for example, this legacy.js file, when the browser sees this code, what happens is that it's not going to compile this code to machine code just yet, right? So it's not going to do that compilation for you. If you have used if you have used languages like C, C++, Java, you know that you actually compile the code before actually executing it, right? So you actually write that gcc myprogram.c and then you write ./a.out, right? For Java also you write java c your file.java and then you write java test.class, right? Stuff like that. But with JavaScript, what happens is that it's a just-in-time compilation. By just-in-time, what I mean is that your browser would read this code and would start executing it parallelly, right? So by that, what I mean is that it'll, for example, it'll see this file and maybe it would just compile this much code to machine language, right? Now, it depends on how the browser works and how the engine is configured. But for the most part, for simplicity, just think about this. It just compiles this much code to machine code, right? And it sees that this code is needed to execute, so it executes it. Maybe, just maybe, that the other code is not really compiled at all, is not really in the machine language at all, right? So that helps JavaScript engines to save memory, to save, reading the whole source code for parsing all the variables, all the values at the compilation phase, or maybe there's not really a compilation phase, but at the runtime, right? So what does that mean is that when the browser is actually running your JavaScript, it kind of figures out a lot of things about your program on the fly. That is the data types, what your variables are, what function it should compile down to machine code, which function you are calling the most so it optimizes it even better, what is the most common data structure of your code. For example, if you're using an object again and again, it's going to optimize that. If you make some changes, your JavaScript engine de-optimizes that, all that stuff. So all that actually happens with V8, right? So V8 actually uses just-in-time compilation. That is, just reading the source code as it is executing, right? There's another kind of language which is known as interpreted language. By interpreted language, what you mean is that you start reading the language, executing the code by actually reading each of the tokens, right? PHP is a good example for interpreted, especially the older versions of PHP. I think PHP also ships with a JIT compiler now from PHP 8. I don't know exactly, but yeah. For PHP 4 or 5, you can think of, if you have written PHP code, what it's going to do. It's going to read a token. It's going to invoke the interpreter for PHP. That is, it interprets what you're trying to say in that token, and it's going to run it, right? Similarly, it's going to, when it runs it, it's going to come to the next token, interpret it, run it. So it's basically super slow. Interpreted languages are super slow because of, obviously, you have to read each and every token every time. JIT has a performance between, just the statically typed and the interpreted languages. So C would obviously be faster than JavaScript, but JIT can come really close to C performance with the right set of code, with the right code written, right? So yeah, I mean, that's basically how the JIT part works. It takes up chunks of code. It will just convert that into machine code, keep executing that, see that if you need any other code to be run quickly or later on, it will try to grab that code as well, convert it into machine code, optimize, de-optimize stuff all the time, do all the memory management for you, and all this is done for free by the V8 engine. So you know that if your JavaScript works flawlessly, who you have to thank. That is the V8 engine on the Chromium browsers, or if you're using Mozilla Firefox, SpiderMonkey, or I don't know what engine they're using currently, but yeah, that was one of the engines they used to use in the past. So yeah, this is how the V8 engine works really. Takes in JavaScript chunks of code, executes it, monitors everything, and does all that under the hood for you in each of the tab, right? At least on the browsers. On the servers, on the node, the similar thing happens. V8 is running under the hood. It will take a look at which function is being called a lot of times. For example, if you're running an HTTP server and you're delivering some sort of file or something, V8 is going to keep an eye on that this particular resource is requested a lot, this particular function is called a lot. So let's just optimize it in a better way inside the assembly so that we have a faster machine call, right? So yeah, I mean, that's how it all works. Essentially the overview, not the code and internals, but giving you an overview picture of that. So that's all for this one. I hope you liked it. I'm gonna see you pretty soon in the next one. Alright guys, welcome back. And in this video, I want to actually show you how you can block the main thread in JavaScript, kill it basically, and how would event loop play a role in this. So you can see this is a fairly simple code to understand. I have an event listener on this button, which is this button, because query selector would return the first button, right? I'm adding that event listener, and then I have a little bit of more interactive text like a paragraph tag and just a regular button, right? So if I go ahead and refresh this, you can see that I can interact with the text and I can click this button as well, just fine. As a matter of fact, let's just go ahead and throw in an input field as well. So if I just go ahead and say input type text and refresh, you're going to see we have an input field and I can focus in and out of this, right? So what happens now, if I click on this, you're going to see I run this while true loop, which is an infinite loop, which is going to freeze my code at this point, right? So let's just go ahead and kill the main thread, and you can see that everything is actually frozen, right? At this point, I cannot select text, I cannot focus into input field at all, I cannot click the button, nothing is happening, right? And obviously this, you might already know this because of the while true, but the message I'm trying to send here is that while true would block the event loop, the main loop, like forever, right? But what happens with synchronous code is that if it takes a lot of time, for example, network request, it might not take forever, but it might take a long time, like 4 or 5 seconds. If your network requests are synchronous, then it's going to block the event loop like this, and it's going to kill the interactivity on the page. This is the reason why JavaScript had asynchronous programming behavior, because it had to run in the browsers, and it should not be just waiting for all those network requests, all those timers to complete before the page becomes interactive again. Now, the reason for this is because JavaScript is heavily linked with the DOM on the web page, on the browser. So you need the JavaScript thread, you need a single thread to render, you need a single thread to render the CSS, the layouts, everything, because JavaScript also accesses that data. And if you try to move that out of that particular thread, then obviously you lose that ability for JavaScript or any other code which is running inside some other thread to interact with the DOM. So just to summarize this video, what I wanted to show you is that when you block the event loop, that is, when you block the JavaScript on a page, or whenever the code takes too long to process, what's going to happen? It's going to kill your interactivity on the page. Why is that? Because JavaScript works on a single thread, which is used as a main thread by the browser as well to render the UI, the user interface, and to render changes to DOM, like selecting text or maybe clicking button. These animations, all this is happening on DOM, which is happening with the thread on which JavaScript works as well. So this is why you need event loop to actually schedule the events, to queue the events, right? You don't want to run everything at once and block everything, just like you saw in case of while true. But while true is an extreme case, but if you have a very long running task, you probably want to break it down into chunks, and then as time goes by, you want to run that instead of like just blocking the whole UI, because that is a bad user experience. So yeah, that's basically it for the introduction. In the next video, we'll actually look much deeper into how event loop really works, and would take care of that how all the dynamics and everything is working, the call stack and the queues. So yeah, I'll see you pretty soon in the next video. Alright guys, welcome back, and in this video let's just actually look at what a call stack is in JavaScript and in general as well, because this would be important in actually understanding what goes on with event loop. So a call stack basically means that whenever you call a function, it goes on to the call stack, right? And as long as that function is executing, that means as long as that function has not returned anything, that function would be on the call stack, right? For the most part. So what you have to remember is that, for example, if I'm calling 1, this function would remain on the call stack till this point. So until JS comes here, 1 would remain, right? So 1, if we see, actually calls 2. So this 2 function would remain until JS comes here. So what would happen is that when this 2 is being called, that is right here, the call stack would look something like this, 2 and 1, right? So these 2 functions would be on call stack, 1 at the bottom, 2 at the top. So let's just go ahead and actually take a good look at what happens using this nice little GUI as well. So pay close attention what happens when I click on save plus run. So let me just go ahead and, oops, I think I was too slow on that, or actually let me just go ahead and increase the delay as well so that we have a good chunk of time on the screen. So click here, 1, you see 1 is executed, then 2 is executed right here, then at this point console log gets executed. So let me just take you through what has actually happened. When the code ran, well, we have a couple of functions, it's fine, okay, nothing to do here. But when JavaScript came here, it realizes that you are calling 1, right? So it goes ahead and places this 1 function on the call stack. So now you have the information that this function is executing at the moment. Then it goes to the function 1. It sees that you actually want to call function 2 as well. So it places function 2 on call stack as well. So you see that 2 is actually placed on top of 1. That is because 2 is actually called inside 1, so it could never be that 2 actually ends after 1 ends, right? Because 2 is encapsulated inside function 1, so 2 would always end before 1. And actually I messed up there, but anyway, let's just go ahead and see it one more time. So we have 1, 2, and then finally when 2 calls console log, we get this function right here, which is the final thing. It calls some native C code under the hood and everything, all that magic stuff happens, and you get the console log of hello in your dev tools. Now, once that is done, this function is done executing, right? So what's going to happen is that console log gets removed from the stack. Why? Because at this point you are here. You're done with console log. And when you're done with console log for this function, you don't really have anything else. So you're done with 2 as well. So that means you can get rid of 2 as well. And then finally, you can get rid of 1 as well because everything is done. And once everything is done, call stack is empty. And basically your JavaScript is done for the moment, right? So this is what a call stack is. It's a place where the V8 and the internals actually place the functions which are currently executing. And they basically just place them in a stack order. That is, whatever comes first would go out last. So 1 comes very first at the stack, so it goes out at the last. So that is why it is called stack is a data structure which is designed in such a way. So this is why it is called a call stack. So this is how a call stack works. Make sure you understand this nicely because this would be useful in the further videos. That would be all for this one. I'll see you pretty soon in the next video. Alright everyone, now that we have a basic understanding of call stack, let's just take a look at this web APIs column. This is technically nothing but just an interface for convenience here, right? So there's nothing as such web API section somewhere in the code. But yeah, I mean, this is just used for categorizing web APIs which are external in this tool. So call stack actually is a real thing you're going to see in code as well. but this part is just for, you know, the APIs which is provided by browser and not V8, like setTimeout, setInterval, stuff like that. So browser ships with that, not the V8, because V8 just ships with the core information that is, you know, just working with the JavaScript code in general, the functions, hoisting, variables, stuff like that. But the browser provides that async of setTimeout and setInterval. So what you're going to see is that when we go ahead and write something like setTimeout here, it's going to do, let's just name this as well so that we can see callback, for example. And if I do console log hello, let's just not use both arrow functions and traditional ones. So you can see that when we do something like, oops, I think I missed a timer argument there. So you see, when I do something like this, you're going to see the callback actually runs in the web APIs section, right? So the timer actually waits in the web API section. So don't worry about what happened except for that. I just wanted to show you that the CB function, that is the callback function, is considered as web APIs part. So that would be all for this video. Let me just quickly introduce you to callback queue as well in the next one. Let's see you there. So what is going on, everybody? Welcome back. And in this video, let's just take a look at what this callback queue would be. First things first, I would just like you to read this instead of callback queue as a task queue, right? There are multiple queues in JavaScript, which we will discuss, but this is about the task queue. So what happens now is that when I use some web API like this, like setTimeout or setInterval, what's going to happen is that if you see this code, you might think that, maybe it's going to wait 10 seconds and then it's going to run this function. Well, not exactly, to be honest. When JavaScript starts executing this function, for example, you have just, you know, your own little stuff, and for example, JavaScript is here at the moment, and when it comes to here, it's going to see, well, you're calling a function because technically setTimeout is itself a function which accepts 2 arguments. So you call a function setTimeout. That means it will place it on the call stack, just like any other function which we discussed. But what JavaScript would realize is that setTimeout is something which V8 cannot handle internally, right? So V8 would say, hey, web APIs, what should you do? What we should do with this function? So web APIs would say that, hey, callstack, don't worry about that. Mark this setTimeout as done, right? So even though this function is not executed, right? Even though this function is never executed, even though this time limit never expired, web API would say to callstack that, hey, don't worry about this. Mark the setTimeout function done and leave the rest to me. So let's just go ahead and see this much for now. So you see that, oops, let me just rerun. So you see that we get the first step as, you know, we get it on the call stack, just like we expected, that, you know, it's just a function, it's called, it gets on the call stack. Now JavaScript would spend some time thinking about what I should do. When it figures out it has, now when the V8 engine figures out it can do nothing, it will ask the web API, hey, do we have any setTimeout or something, or do you want to handle this? So when you do that, callstack, this web API part would say, hey, don't worry about this setTimeout function. Just go ahead and mark it as clear. So you see at this point, this is important. At this point, that function is cleared off the stack. That is the setTimeout function, right? And let me just go ahead and just pause it at the correct time. So yeah, the setTimeout function is cleared from the call stack. At this point, callback is not executed, but the timer has also not expired. Let's just go ahead and take a look at what's happening now. So when I resume it, you can see this green bar is becoming full. And what essentially this is waiting for is this timer to expire, right? So what is essentially happening here? I mean, didn't I just say that JavaScript is single-threaded? Well, yes, but no. So what's happening here is that the JavaScript you can work with is always single-threaded, right? So you as a developer never get explicit access to the multi-threaded world of JavaScript. That is the underlying C and C++ architecture on which the V8 and browsers work. But that does not mean that browsers and operating systems themselves cannot make use of multi-threading in order to improve support for the single-threaded architecture of JavaScript. So what just happened here is that when you called setTimeout, it took this function callback, that is the function CB, out of the stack, and it placed it probably under a timer in some other place, right? Now it's waiting for this timer to expire. That is, this is the browser part, right? And for the most part, right now, the call stack is empty. That means, if any other task is coming in, JavaScript would be running just as usual. So this timer, this waiting of timer, and the task which might, come on the JavaScript world would be happening simultaneously, would be happening parallelly, right? And once you have that happening parallelly, that means you're working with some sort of multi-threaded environment, but still it is not multi-threaded exactly because you as a developer never get access to the different threads in which browser can play different games. But anyway, let's just go ahead and continue the stuff. So let's just see if I resume this and let the timer expire. At this point, 10 seconds are about to expire, right? I've just paused it just a little bit before. All right, so what has happened exactly? All right, so here's what happens. When the timer expires, what this web API, that is the browser, would do, or in a lot of cases Node, so just replace this with Node if you're working on backend. This is web APIs for the front end. If you're working on Node, this is probably some sort of internal Node APIs, right? So what this part would do is, instead of pushing it directly on the call stack, which is one option, right? Now you have either two options. If you want to execute it, you're going to push it to call stack because, just like we discussed, that whatever is present in the call stack is currently executing. So by pushing it on the call stack, that means that JavaScript just ran the CB function. But there's a problem with that, which I'll come to later on. But the other option is it actually queues that function. That is inside a callback queue, inside a task queue. By queuing, what it gives JavaScript is the ability to pick a function when it wants, right? It is very much possible that when that timer expired, the call stack, the main thread of JavaScript, is busy with some other things, right? So, then at that point, what is this web APIs and what is this internal structure supposed to do? I mean, you can either just go ahead and push it all the way on the top, which would interrupt the JavaScript execution, and this would start the callback thing and would create a disaster of race conditions, right? Or you can let the V8, that is the call stack in this case, just free up a little and then decide what it has to do. So it does exactly that. In JavaScript, we get a task queue in which all the stuff like this, which is timer based or not really fixed or asynchronous, like network requests and file reading, stuff like that, that is placed directly inside the task queue when it's done, and then it is left onto V8 when it wants to pick up this function. And the general rule of thumb is V8 would always, obviously, this is the spec, not really a rule of thumb as well. V8 would pick the first item from the callback queue as soon as its call stack is empty. This is important. Make sure you understand this part. V8 is not going to, just pick up the function if it already has something running on the call stack. That is, even if a single function is present here, V8 is not going to run that. V8 is not going to pick that callback queue function, right? So if I resume it right now, you're going to see that what happens is that this callback queue function, let me just see if I could, or let's just start it one more time. I think it just got bored there, but anyway, you see we run the callback, and just like that, it's going to place it on the callback call stack, and it runs that console log statement, and it executes, and it just is done, right? Let's just see it one more time. We get the call stack ready, we get it on the callback queue, we get it on the call stack again, and we execute the console log statements, we exit the call stacks, and we are done, right? Now this tool might be just a little bit buggy, but you understand the idea, right? So yeah, I mean, this is how asynchronous stuff, the task queue works in the call stack way. So I mean, yeah, that's basically it for this video. I'm going to be actually showing you more demonstrations in real code in the future ones, because you know, this tool cannot be really used to actually mimic the whole behavior, but it's just a nice interface for understanding in the initial part at least. So that's all for this one. I'll see you pretty soon in the next video. So what is going on, everybody? Welcome back, and I hope you remember this piece of code which we used to crash our tab. And what I want to do this time is I want to use the Taskqueue, which is usable as a developer using functions like setTimeout. And I want to show you what exactly is the difference between, you know, how setTimeout thing would work and how the Taskqueue part would, how the synchronous part would work like. So let's just go ahead, and you know, you obviously know that if I try to call this function within a function, this is just a recursive loop which has no base condition, so it's going to eventually blow up. So at some point, what's going to happen is if I click on this, you're going to see that we very quickly get this maximum call stack size exceeded from Chrome, right? Now the reason for that is what happens if you go ahead and do something like this here. What's going to happen, it's going to fill that call stack very quickly, and it's going to hit the roof with about, I think Chrome has a limit of about 10,000 open tabs, functions in the call stack. I don't exactly know, but yeah, I think you can get that from just passing a value. So we can actually see how many functions Chrome can actually afford to call before crashing down, right? So I can say something like this, and let's just go ahead and see what's the limit for Chrome. So you see, we are counting and counting and counting, and it should probably crash somewhere about 10,000. And actually, because I'm using console log again this time, that's why it kind of like freezes and everything. Right, so you can see that about 12,515, it kind of said that maximum call stack exceeded, for me at least, right? It might vary for you. But the idea is that Chrome knows that, you know, you're gonna blow this up. So that's not really going to work. How about if I put it inside a setTimeout with a block event loop, and let's say maybe 200, right? So I can just go ahead, that is 200 milliseconds, and I can say console log I was called, right? Nice and simple, nothing, you know, nothing very complicated, nothing complicated at all. So if I click on this, you see that I get about every 200 milliseconds, that is about 5 times in a second, I was called logged, right? But what happens if you put 0 here? I mean, why would you even put 0 in a setTimeout? A lot of people ask that. Isn't it just like possible to do it like this instead? But you know, we have already seen that when you call it like that, you'll get that error of maximum call stack exceeded, and your program would crash. But if you do something like this, and you know, let me just go ahead and remove the console statement for a while, reload, kill the main thread, you see nothing really happens. Text is still interactive, you know, you can still enter everything, you can still click buttons. So what's happening, right? So actually, you can actually verify that this function is running by, just like what we did earlier, by passing a value here, and I can just go ahead and pass 0, and I can say that if I mod, I don't know, 1000 is 0, that means I'm just calling it once every 1000 iterations. I just want to say I was called, right? So hit refresh, click on this, and you can see that I get I was called, right here. And actually we just might need to have that I+1 there as well, because we are not calling it after that. So let's just refresh, click here, and you can see that I was called a bunch of times. I mean, setTimeout kind of acts too slow in comparison of while loop. So what's really happening here is that whenever you call this block event loop function, that is block event loop is called with 0, for example, what it does is that it calls it, right? It gets placed on the main stack, that is the call stack. So if I have a call stack function like this, so block event loop is now on here, then we get the setTimeout call, that is it places it inside the web API section, inside the waiting section, and because it's a 0, the timer expires immediately, and the Taskqueue gets the setTimeout function. Now remember, this Taskqueue gets the setTimeout function parallelly while the block event loop is also executing, right? So this is the condition right now. But the setTimeout does not execute this block event loop right away. Why? Because it waits for this particular block event loop to get empty. And why is that? Because Taskqueue waits for the call stack to become empty, and once call stack just becomes empty, that is this block event loop is completed, that is in the next line itself, what happens is that call stack, that is the V8, would say to Taskqueue that, hey, I'm empty now, do you have anything for me? Taskqueue would say, well, let me just go ahead and try to pop something, and it says that, hey, I had this setTimeout function which we need to execute now. So what Taskqueue would do is that it would place this function right here, that is this particular part. So this part gets placed on the call stack now, like this. The call stack sees that, hey, I have something to execute. It will execute this function. This block event loop would again get on the call stack, would get on the Taskqueue through the web API section. And this block event loop would execute. So that means the call stack now becomes whatever we had, that is this thing, right? Plus the block event loop of I+1. I hope you understand this, because this is a separate function, right? You see, this is a separate function which calls block event queue. That means it calls block event loop like this, and then in turn block event loop would further call that setTimeout function. That setTimeout function again sees that, hey, I'm a web API, so I'm gonna go ahead and place that inside web API, so setTimeout gets there. But in the immediately next step, web API timer expires, so setTimeout is actually moved to the Taskqueue. So Taskqueue is empty, setTimeout moves there, right? Web API removes it, and the condition looks something like this. Taskqueue is again this, call stack is again this, and call stack is not going to, and call stack is actually this, because setTimeout was moved. And call stack is not going to, pick up any function from the Taskqueue as long as it is not empty. So call stack would remove the block event loop first, that is, it will get rid of the block event loop, then eventually, obviously, because it has returned, so this one also returns, and call stack at this point is empty. Now it'll say again to Taskqueue, hey, do you have something for me? Yup, I have something for you. Take the setTimeout, and the setTimeout is again this particular function. So you see, at a particular given time, when you're using setTimeout to recursively call it, there's no more than 2 functions, and that is also because of the way we are actually calling it, right? But if you recursively call it, what's going to happen? In this case, what's going to happen is your call stack is this on the first call. In the next call, it becomes this. In the next call, it becomes this, because you block the execution of the block event function. It cannot go to the next line, even though this is the last line, right? So it cannot go to the next line to actually exit this function. That means the call stack just exceeds, just keep on building up and up and up and up until it explodes, until Chrome shuts you down that there are way too many functions in the call stack. So if call stack is, length is greater than 12,000 or something, throw. That is what Chrome says, right? So yeah, I mean, hopefully this video gave you a bit of picture how the call stack and Taskqueue works together. In the next one, we're going to be discussing about request animation frame, which is another thing which is closely related to Taskqueue, but is in a different place than the actual Taskqueue where the functions happen. But don't worry about that. We'll just come to that when we discuss in that video. But that's all for this video. I'm gonna see you in the next one really quick. So what is going on, everybody? Welcome back. And in this video, I want to show you a little demonstration of another queue which is present that is called as animation queue. Now, the difference between Taskqueue and animation queue is the point where the browser runs the particular piece of callback, right? So the idea with Taskqueue is just like you saw that an external web API or some C++ node internals and everything can be scheduled on the Taskqueue, and it would be picked up by the event loop. That is, it would be picked up by the call stack whenever the call stack is empty, right? And event loop would go ahead and throw that first task from the Taskqueue on the call stack. Request animation frame, this thing basically uses another queue which is not the Taskqueue, right? So it uses an animation queue instead. Now, what do I mean by that? I want to actually show you through a simple example. So let's just go ahead and assume that we have this, and actually I did not rename this. So here we are. So we have two counters on the screen. The first one is setTimeout counter, and the second one is the request animation frame counter. Again, remember that this uses Taskqueue and this uses the animation queue, and this is all inbuilt. I'm not doing any funky stuff here, right? So let's just go ahead and start the setTimeout counter. You can see it's rapidly, executing, right? What's really happening here is you can see from the code that setTimeout recursively calls itself with just an increment in the value, and whenever it calls, I set the text. And when does it call? Every time the call stack gets empty. That is, setTimeout, set st counter gets called, setTimeout places it on the call stack on the Taskqueue. This function exits, call stack picks up this function right here, this part. It calls this function, which calls this function, and you know the process from the last video. So that's how you make something like this, right? On the similar hand, if you actually, I have the wrong button name, but again, this would just work just fine. But if you start the counter like this, you're gonna get the request animation frame counter started as well. If you see very carefully, you'll actually understand that request animation frame counter is slightly slower than the setTimeout counter, right? Now I want to actually demonstrate that. So what I'm gonna do is I'm gonna create a button. First of all, let me just go ahead and do that and setTimeout, Raf counter, and start both counters, right? So I want to have these two buttons, and when I click on button 3, what I want to do is start both the counters, right? So at this point, what I'm going to do is start the setTimeout counter as well as the Raf counter. I'm just going to place setTimeout below because so that you don't think that setTimeout counter has a head start. So refresh, and let's just go ahead and start both the counters, right? You can clearly see that request animation frame now is much behind than the setTimeout counter. So what's really happening here? I mean, why does one request animation frame takes longer than a setTimeout counter? Well, let's just see what's really happening. So when you start setTimeout, something like this, so this is what's happening, right? When you call setTimeout, you see what's happening every time is you get that setTimeout on the web APIs part. Web APIs wait for it to complete. That is the timer, which completes immediately. So Web APIs throw that inside the task queue. That is the callback queue. It waits for the stack to get empty, and then that is copied over in the actual call stack, which calls the function and runs it, right? So this is what happens with the set timeout. We know about that. How about the request animation frame? You see that what request animation frame does is that it would not execute on every time the call stack gets empty. Instead, it is a function which executes just before the browser is rendering, just before the browser actually updates your screen, right? So what happens is that browsers do not update continuously on your screen. There's a thing called 60 hertz monitor, right? 60 frames per second, stuff like that, 30 frames per second. You see that now you have mobile devices with the refresh rate of 120 hertz. So what that really means is that your operating system, your hardware, your whatever, your browser in this case, is actually refreshing your display at that rate. That is, it's refreshing it 60 times a second, right? What's essentially happening with set timeout, however, is that you are refreshing it as soon as the call stack becomes empty, right? And the computers under the hood actually operate at a very fast speed. That is, millions of operations per second. However, your display does not update at millions of operations, millions of times per second, right? It just updates 60 times a second because, updating it more than that is essentially just useless because we cannot perceive that particular change to our eyes, right? That is why we have a limited refresh rate. You cannot really perceive anything above 140 or 50. So why would you want to waste all that computation when the user never really can see what's going on the screen, right? So if you are trying to, animate some sort of object, you're going to make use of request animation frame there. Why? Because this would allow you to actually spend less time on the parts where the user cannot really see anything on the screen, because it will just call this function not more than the refresh rate of your system, right? It does not guarantee to call it 60 times a second. It's not guaranteed that this function would run 60 times a second. But yeah, if the system is not under load and everything is fine, it will just run 60 times a second only. Not like set timeout just goes ahead and blows it off, right? So again, request animation frame can literally slow down if you're doing a lot of work on JavaScript other threads, like what's happening with set timeout and all these DOM updates and everything. This DOM update is actually expensive, right? And you're doing it so many times every second. So that's why this thing is slow. That is, the updation is slow on the screen, right? Because if you just run the set timeout part, this one part, you're gonna see that it's actually faster than when I run them both, right? So that's the thing. So I hope you understood what's this animation queue. It basically runs before the browser is updated, which is at most your refresh rate, or browser gets to decide that. But the task queue, on the other hand, operates on the fact that as soon as the call stack is empty, let me just go ahead and throw one of my functions on the call stack so that it gets executed. Request animation frame throws the function on call stack only when the browser is about to render a new scene on the page, right? Something new, some new data has arrived, or some sort of animation is going on, so you want a 60 FPS display there. So you can use it to hook in right before the browser actually updates that DOM node or updates that CSS and all that stuff. Hopefully this made it all clear about these two things. There's one interesting thing which I love about, which is my most favorite queue in JavaScript. That is the Microtask queue. And it's good to actually understand Microtask queue in depth because it brings a little bit of tricks with itself, right? So yeah, for the most part, that's it for this video. I'm gonna see you in the next one really quick. Alright everyone, welcome back to another video in which we'll be starting off with microtasks. And this is an important thing, this is an important topic to discuss because microtasks are used a lot of times. So what is a microtask? How does it differ from a regular task? All that stuff. So let's just first of all cover a bit of theoretical part, and then I'll actually make you see with the code as well how this works. So you know that when you use things like setTimeout and setInterval, those things are scheduled as tasks in the task queue, right? And we discussed how the Callstack works, how the task queue works. So whenever you put in something like, just calling a setTimeout or setInterval, that is pushed on to the task queue. There's another queue known as Microtask queue, which is very similar to task queue, but it differs in a couple of ways, which is going to make a lot of difference, right? So let's start with a very simple question. What I'm going to do first of all is, actually, let me just go ahead and remove this function. I'm just going to make a single function, and I'm going to say this is something like schedule, schedule, schedule work, right? And here we're going to make sure that we call some functions which process as task queues and some which process as microtask queues. So I'm going to call setTimeout with, let's say, console.log first, and I'm just going to call it immediately on the task queue, right? Then second, and then let's say I have a promise.resolve. Promises work on task queue or on microtask queues, right? So whenever you call a .then on any promise, that at that particular time, whenever the promise is resolved, it's going to place this function on the microtask queue, and it's going to execute whenever the event loop gets some time to execute the microtask queues. So I'm going to say console log first from microtask, right? And then I'm going to say second from microtask as well. And let's just create a button real quick here and say, click me. And I can just say that, document.getElementByID button, just attaching an event listener. On click, I want to call the schedule work, and that should be it, right? So now let's just go ahead and see this very simple example first of all and see what happens. So I'll click on this, and we have this order, right? So the first thing which is clear from this output, even if you click it multiple times, you're going to see you always get the microtask output before the task queue output. Now why is that? Well, that is because when event loop is running, event loop is something like this. You can think of event loop like this, and it's doing a bunch of actions. So it's doing step 1, then it's doing step 2, then it's doing step 3. And if you consider like step 2 to be check for task queues, then step 1 could be check for microtask queue, right? So this is why whenever you click on this, you're going to see event loop always checks microtask queue first, and then it checks the task queue. Now mind you, the difference here, it might not be clear eventually, but this is something you should know. The thing is that microtask queues are always evaluated in the first, in the single event loop tick. By that, what I mean is that you see when this code was being called, that is when I clicked on this button, schedule work, what happened was I got something like this. So setTimeout was called on task queue. So task queue looks something like this first, second, right? And then the microtask queue look like this, first from microtask and second from microtask, right? Now pay very close attention to what happens here actually when the event loop is running. That means when this while thing is running. Let me just go ahead and copy this actually right there. When this while thing is running, what's going to happen is that it would try to completely exhaust the microtask queue array, right? So you see that what's going to happen is that in the step 1, it will keep checking for the microtask queues, right? So it will keep on checking the Microtask queues again and again and again and again, just to, you know, see if there's any pending task there or not. So it's going to first of all do this, then it's going to do that, right? But with the case of task queues, what really happens is that it runs only once per event loop cycle. That means this would just happen just once, even though there's a second task pending, but this would happen in the next iteration of the event loop, right? It would not happen in the single iteration, it would happen in the next iteration. So how do we do that? How do we see that effect? Let's see. So I'm gonna go ahead and create another timeout, but this time this timeout would actually set up a microtask queue task, right? So let me just go ahead and comment this out for the moment, and I'm gonna say first from microtask again, this is 0, and then what I'm gonna do is this would be second from microtask, and then what I'm gonna do is probably yeah, I mean, we can just do one more thing to make things really interesting, and that is something like this, right? So it's really really something now. So here we are, 0 and then 0. I hope this is not confusing. This first set timeout is for this thing, and I think we have some syntax wrong somewhere. Yeah, that should fix it. So we have basically 2 set timeouts. Let's just see what's happening. Let's just see what happens when I click on this. So I click on this, you see we get first and second as the output, but we don't get anything else because obviously we are not resolving them, because, you know, just like I said, microtask queues are always fired when you resolve them. So I'm gonna say yeah, I mean, we already have the value, right? So we can just go ahead and get that value. So here we are, right? So now if I go ahead, refresh this, click on this, hold on, let's see what happened. Let's see what really happened. And I think we have a second nested. All right. Now, what the hell actually happened here? Well, you see, we started executing this function. So I'm just gonna create a task queue here real quick, and I'm gonna create a microtask queue as well, so that it's easier for us to, you know, just keep the check. So on the first go, our task queue schedules this console log, right? Now I'm not really writing the whole function. In essence, this would be the whole function which would be placed on the task queue, but I'm just skipping that so that it's cleaner to look. And then it also places second on the task queue. Then what it does is that it places this promise on the task queue, not on the microtask queue, but on the task queue, because it was called by setTimeout, right? So I have something like, I'll just shorten it down to this thing, right? So that it's again easier for us to manage. Then again, because we have a setTimeout, this goes to the task queue, not to the microtask queue. And then finally we have something nested, so this whole thing goes to the task queue. So at this point, our task queue, our microtask queue in fact, is completely empty, right? Now what happens is in the next iteration, what you're gonna see is only first is taken out. In the next iteration of event loop, only first is taken out. So it's taken out, it's console logged, as you can see on the screen, just like fine. In the next iteration again, it is again taken out. That is, you know, second is taken out. So we get second on the screen. Now, what happens is that we have first from microtask. That is, you know, again, a single task is taken out and displaced on the microtask queue. So we get this first from microtask right here in the microtask queue. But at this point, you know, what's going to happen is that obviously microtask queues are checked before the task queues. So the iteration again ends for this thing. But when it begins, it's not going to place it right now. It's going to actually try to exhaust the microtask queue first, right? So it's going to pick this up from the microtask queue and console log it, just like you can see. Then In the next iteration, it's going to pick up another task, in this case our second from Microtask, and execute it. It sees that it has to put it on the Microtask queue, but because the Microtask queue work is already done for this part, it's going to iterate to the next cycle. It's going to see Microtask queue is empty or not. Yep, it is not empty. Let's just go ahead and pick that stuff up, and you can see that we get the second from Microtask. And then finally, this just places this thing again on the task queue in one cycle, right? And then in the next cycle, this places it on the Microtask queue. And then finally you get the output, just like you can see, right? So this was a very simple example on Taskqueue and Microtask working together. In the next videos, we're going to be seeing more such examples so that it's absolutely clear to you how the context execution works. So if you are confused right now, do not worry, because we'll be seeing a lot of examples where it would be absolutely clear for you how the Taskqueues and Microtask execution really work. So that's all for this video. I'll see you in the next one really quick. Alright everyone, welcome back, and in this video let's just take a look at this example where we're going to be seeing that how the execution order would look like, and it's going to clear a lot of doubts for you again. If you're coming from the last video where you are slightly, perplexed about how this whole thing works, fear not, we're going to be seeing this example and would be taking a look at the whole solution for this. If you have a pen and paper or whatever you prefer, try to calculate the output order for this thing. And if you could calculate it correctly, well, it could work. But yeah, let's start and see how this would look like. So I'm going to click on this. We're going to get an output, and then I'm going to explain how we got that output. So here we have it. We have M1, M2, T1, all this output, and M is for Microtask queue stuff, which is called with the promises, and T1 is the task queue stuff. So let's see how we really got this output right here, right? So when we called our code, the promise.resolve, that is the first thing, we got M1 and M2 scheduled on the microtasks, right? So I'm going to create Microtask queue, microtasks as M1 and M2 at the moment, right? And the task queue, tasks as, whatever we'll get. So the next line is T1 on the task queue. So here we have the task queue as T1, right? And one important thing, I'm not really mentioning it right here, our call stack. Our call stack right now consists of schedule work, right? Because this function is being called right now. Remember, microtask queues and task queues would always be checked, would only be checked when our call stack is empty, right? They would never be checked if our call stack is not empty. So that is something you should keep in mind. If you have a bunch of functions in your call stack, and if you have a bunch of functions in Microtask queue as well, JavaScript would make sure the call stack is empty before it actually calls any of the task queue or Microtask queue functions. So this is something you should keep in mind. But yeah, so we have this thing, we have tasks as T1. Then the next thing is a little bit challenging because we have this whole function block. So what's JavaScript going to do is it's not going to care at all what's going on in this function, and it's going to throw this whole thing inside the task queue. Why? Because setTimeout places stuff on task queue, and that's all you have to worry about initially. Then again, we get setTimeout, so it would be T2 and T3. So I'm just gonna, just write it as T2 and T3. So this is a situation right now. Schedule work ends, call stack is empty. Now it's time to run microtasks. Why? Because microtasks come in the first order, like before the task queue is executed. So browser is going to start working with microtasks at this point, and it's going to start exhausting the whole thing, right? Just like I said, with tasks, what happens is that it'll pick up a single task and then run it in the next iteration of the event loop. But Microtask queue, what happens here is that the browser would try to exhaust this whole thing before it moves on to task queue, or before it moves on in general. So our code is kind of synchronously blocked here inside the Microtask queue. So if you have some microtasks which can further just push microtasks in the queue, you can have an infinite loop. For example, if M1 pushes M3, if M2 pushes M4, This could just go on forever because browser is going to execute M3 and M4 as well, which are going to put more tasks. So it could go on forever, right? But in our case, it's just output, so we don't have to worry a lot. So we see M1 is the first output, which is exactly what we get, right? So I'm gonna remove this. And then next we get M2 because just like I said, Microtask queues are going to be completely exhausted before event loop moves forward. At this point, event loop sees that, hey, Microtask is gone, so let's move. Then it sees that, Taskqueue also has tasks, so it picks up only one task, mind you, only one task, not more. So it picks up T1, and you can see you get that output, and that's it. The event loop runs the next cycle now. It sees that the call stack is empty, it sees the Microtask is empty, time to pick up something from Taskqueue. So it picks this up, and what happens, it executes this by bringing it into the call stack, right? That's like how things happen. At this point, what happens is that it sees that you are placing a lot of things now on the Microtask queue. So it's going to place them all, M3, M4, M5. And as you can see that call stack is done. Taskqueue has already done its one task per event loop cycle. So it's done as well. It's going to repeat. The event loop is going to complete, whatever is left, and it's going to run again. But this time you see Microtask is available and Taskqueue is also available. But just like I said, Microtasks are exhausted fully, not really, just once at a event loop cycle. So that's why we get M3, M4, M5 outputs for us, right? Because JavaScript completely exhausted the Microtask queue. It's empty now. And for the Taskqueue part, what happens now is that, they are just picked one at a cycle. So we get T2 in the first cycle. And then finally we get T3 as the output in the next cycle. So this is why you got this nice little neat output with you. So I hope this example cleared out some confusions you might have from the last video. If not, don't worry, we're gonna have one more video showing, a little bit more complicated example, but hopefully that would clear out everything you have, left so far. So yeah, that's all for this video. I'm gonna see you in the next one really soon. Alright everyone, welcome back, and this is going to be the ultimate example for you, which is going to clear out a lot of things if you have so far in mind about task queues and microtask queues. So pay very close attention to this if you ever have, if you still have any doubts about the execution order. So you see the code we have is pretty much similar from what we had from the last video, right? Let me just go ahead and throw in a bunch of console logs, hello from main thread as well, right? So that we can just cover everything. But you see that I have two similar looking functions, with the only difference being, the first one has number 1 assigned to it in the console logs, and the second one has number 2 assigned to it all over the place, right? Otherwise, both of them are similar. And what I'm doing with them is that I'm attaching them as event listeners to the same button. That is our click me button, right? But I'm doing one more thing, that is I have another button which says programmatic click. And what I'm going to do with that is I am clicking button 1 when I click button 2, but I'm clicking it using JavaScript, right? So it's going to be fun to see actually how this differs. So let's start this video. Let's start the whole execution thing, how that would all work out, and let's get into it. So this is our page, and we have two buttons now. You see I have click me and programmatic click. So let's just go ahead and click on the click me first and see what's going on. All right, so we have this much output, and let's just try to figure out how we got this output. So I'm going to create an output here, which is going to be just, for our reference so that we don't really lose anything. So first things first, what happens when you click on the button? Schedule worked is called, right? It is dispatched by the V8 engine internally, and this function runs. So this function goes on the call stack, number one thing, right? This function execution starts. We get this promise.resolve on the microtask queue, just like we discussed. There we go. Then we get the number 2 on the microtask queue. Well, nothing surprising here. We know that, we all know about that. Then we get setTimeout scheduled on the task queue. So there's that, right? Then we get this setTimeout call, right? So we get this whole big function call scheduled on the task queue, because this function is not executed yet. It's just scheduled to be executed. Then finally we get another T2 right here on the task queue one more time, and then we get T3 as well on the task queue. And mind you, none of this is actually executed at the moment. It's just waiting inside the queue. But this console log which we see, it gets executed. Why does it get executed? Because it's obviously on the main thread, right? So you're gonna just see this as the execution, as the first execution. So we get this hello from the main thread, and you can clearly see that this is something we get from our actual output as well. All right, at this point you're gonna see that schedule work is done and callstack becomes empty. And what does it mean when callstack becomes empty? You know about that. Yes, the first step is to check microtask queue, right? So even though we have a pending listener here, and actually let me be just actually clear about this. What happened when we click on this was not like it was actually magically appeared on the call stack. It was actually placed on the task queue, right? So it was placed on task queue like this, right, initially. Then schedule work was picked up and it was placed in the call stack, and when it was done, it was done. But now when the execution resumes, you see that the schedule work again is sitting in the task queue, but we do not run task queue before microtask queue, right? So we run microtask queue first of all, and here we are. We get the first output like that, right? Which you can see right here as well. Then we get the second output as well. Oops, like this, which you can see again right here. And microtask queue is empty at this point. Now you see, whenever you click on the buttons, just like I said, I missed it actually earlier when I was actually showing the function distribution, what's going where. But when buttons are clicked, you're gonna see the events are placed on the task queue. They're not directly brought into call stack, right? So schedule work was placed in the task queue. It was brought to the call stack. It was done. Now it's time for schedule work again. And just like task queue works, it's just going to bring in one function, execute it, and be done with it. But schedule work again, what it does is that it basically does this whole thing. Again, it will just place number 2 on microtask, number 2 again on microtask. This would go on task queue, right? This would, again, this whole block is going to go on the task queue. And then we finally have these two things as well on the task queue. Number 2 T2 and number 2 T3. And I think I made, no mistake. That's fine, right? And then finally we get to the main thread, and because main thread is main thread, it gets executed. So we get this order. You see the 4 statements, the first 4 statements are same as ours. All right, so again, schedule worked again ends at this point. Call stack becomes empty, and when call stack becomes empty, what time is it? It's microtask time. So we pick this up, we execute this, right? We pick this up, we exhaust the whole microtask queue. Again, we are done with the microtask queue. So what time is it now? It's task queue time. So we pick the single task queue, that is a single thing, and we execute it, right? So this is what we should have got from after this. So we have 2 M1, 2 M2, and 1 T1, right? So at this point, another event loop cycle completes. Then what happens next is, again, the whole thing runs, but at this time we don't have any call stack, we don't have any microtask. So it's directly going to pick this function from the task queue, and it's going to execute this. It's going to place that in the call stack. Call stack is going to execute this. It's going to place each of them in the microtask queue, right? Because, well, promises are microtask queues. And if you're just wondering how promises and why promises are microtask queue, it's just because of the implementation. You have to check if a function is microtask queue or not. And then you see that we resolve this bad boy and place it as a recursive thing on the microtask, right? So it does not really matter, because this is going to just create another microtask in itself, and it's going to place it in the microtask queue, which is going to execute. So it does not really matter how many promises you put in there. So here we have in the call stack, and the call stack now becomes empty. And you know, when the call stack is empty, what time it is. It's microtask time. So we cut and paste all these outputs just like that from here. And you see what happens now, just after this M5, what's going to happen is that this promise gets executed in the call stack, right? Just like everything else. Then this actually places another microtask queue task on the microtask, right? Call stack ends. You see that we still have microtask because we run microtask till the exhaustion, right? No excuses on that. So we have again that thing, and now we are done with that. So you see that we get all these 1T1, M3, M4, M5, M6, and that is exactly we're going to see here: 1T1, M3, M4, M5. And we do not have M6 because I believe I missed the dot 10 here. This is the wrong thing, right? Right, so yeah, I mean, I missed the dot 10 here, so I'm just going to remove this statement because so as to avoid the confusion. So let's just see that if this was not available at all. But if it were available, you're going to have seen the one M6 right here at this point, right? So anyway, because that promise never resolved, that is, we never run the then on that. That is why that console log never showed up, because that was never moved to the microtask queue. So anyway, that's fine. But here we are. So the next thing again is to pick each of these tasks one by one in single iterations. So we have one T2 right here, then one T3 right here, then two T1 right here. And yep, we are done with these much tasks at the moment. Then we pick up this whole block of next thing, and just like I showed you what happened earlier, each of them would move to microtask and then they would be executed, right? So we can just place it if you want, but we know what's going to happen. And obviously I'm just gonna get rid of this because, you know, we did not write .10 here. .10 here, that means it was never executed. So I'm just gonna get rid of this, and we get rid of this as well. Then finally, you know, microtask queue again runs on the next iteration, and each of these tasks are popped out, executed, and shown us as the output. At this point, microtask queue is again empty, and we can nicely and easily just pick up the remaining two tasks from our task queue without any problems, right? So here is the final output. I hope this matches from the initial. So we have two T3, two T2, two M5, M4, M3, two T3, T2, M5, M4, M3. Then we have two T1, one 3T, one 3.2, two T1, one 3T, one T2, right? So yeah, one M5, M4, M3, and one M5, M4, M3. Yep, it all matches up, right? So yeah, I mean, I hope you get a better understanding from this. And in the next video, we're going to be discussing what would happen, what would be the output, and explaining the output if you click on this programmatic button, that is the button 2. So that's all for this video. Hopefully you learned, just cleared up your doubts from this one as well. If not, obviously you can just participate in the discussions below. I hope somebody would answer. I would answer you. I would get back to you. So yeah, that's all for this one. I'm going to see you in the next video really quick. Alright guys, welcome back. And in this video, I'm going to be doing the hardest thing, that is the second button click. And it's going to be, covering a lot of things, and I'll be doing it in the nicest way possible. So let's start and let's get into this, how this would all work. So let's just go ahead and let me just go ahead and click on this button. And you see that right away, you see that the output is different from the click me button. If I click on the click me button, you see we get these two separated with two microtasks queue tasks, but with programmatic button, there's nothing like that. And the output kind of differs here as well. So why is that? What really happened? Let's just take a look. So starting off with the actual thing, what's going on in this button? Well, you see what happens when you click, just like I said, when you add an event listener of click to this button, and the event listener is schedule work. When you click on this button, that is this click me button, JavaScript would asynchronously put that event listener on the task queue, that is schedule work and schedule work 2. When you click this was the initial state, right? But when you click it programmatically, JavaScript synchronously does that thing. What's the difference between asynchronous and synchronous? Asynchronously means that JavaScript would make use of the queues, the task queues or the microtask queues or whatever queue is available. Synchronous means it's going to push it to the call stack, right? It's going to push it, to the urgent thing, which needs to be executed now. So what's going to happen is that when you click on this button, when you click on the button 2, JavaScript places this function. Well, yep, it just places that function on the task queue, just like it did with the schedule work and schedule work again. No exceptions to that. But when it brings it to the call stack for execution, what's going to happen? It's going to execute this function right here on the call stack, that is button.click, synchronously, right? Last time when I was clicking this, there was no button.click function here. There was just schedule work and schedule work again. No button.click, right? But this time there's a button.click as well on the call stack because we manually called it. That was not invoked by JavaScript internally. So in this case, when I call button.click, obviously it's going to invoke the listeners. But this time you see that it's not going to go to the task queue. It's directly going to come on the call stack. Why? Because button.click directly calls the event listeners. So schedule work never goes to the task queue in this case. It directly comes to the call stack. And when this happens, what's going to happen? The whole thing runs again, just like previous time, but with a very, very minor change, and that's going to make a lot of difference. So let me just go ahead and place them really quick on the Microtask queue because we know about this. setTimeout is going to be on T1. And then we have this whole little block of 3 promises inside the task queue as well, right? Then we have T2 and T3 in the task queue as well. And then finally, what's going to happen is we're going to get this hello world, hello from the main thread in the output because, main thread is main thread. You're going to get that output anyway. So you can see that's the first line for our output, right? Hello from the main thread. Now, at this point, schedule work ends, right? That means it's taken away from the stack, but see that call stack is not empty. That is the difference. Remember, I told you that microtasks and task queues and everything only runs when call stack is empty. But in this case, call stack is not empty. So JavaScript is not going to run microtasks or tasks, right? It's going to keep on executing the call stack first so that it becomes empty or it exits or whatever. At this point, the next thing button.click calls synchronously is the second listener, right? Because, that's what we did. We attached 2 listeners here. And then again, the whole thing happens. So we get 2M1, 2M2 on the microtask queue. They just keep on building, not really executing. And this 2T1 also happens right here. Then we have this block of 3 promises, which is placed as well. Then we have 2T2 and 2T3 can speak. 2T3. There we go. So we have this many things on the task queue. And then finally, main thread is main thread, right? So we get that output directly. That's why you see the main thread, hello world from the main thread number 2 directly after number 1, because the call stack was never empty for the microtask queues to be executed. And that's it. So at this point, schedule work again exits. Button.click has done its job, so it exits as well. Call stack is empty. Callstack is empty, that means it's microtask time. And you know that microtasks never leave before executing the whole thing. So what's going to happen, it's going to pick up each and everything and oops. Yep. And it's going to write everything. 1M1, it's going to pick the next one. 1M2, it's going to pick the next one. 2M1, and it's going to pick the next one. 2M2, right? And there we have it. The microtask becomes empty. So you see that we have hello from main thread, hello from main thread, then 1M1, 1M2, 2M1, 2M2, just like we predicted, right? At this point, again, microtask is empty. So event loop runs the next thing, which is the task queue. So it picks up only a single task, runs it, completes the cycle. And in the next iteration, it runs this whole block, which is going to place all of these things on the microtask queue, right? 1M3, 1M4, 1M5, just like that, right? And I hope that's it. So that is done. And yeah, only one task in a single iteration. Then it runs again, the event loop runs again. It sees microtask is no longer empty now, so it's going to execute the whole thing as quickly as it can to its full completion to make it empty. There we go. 1M2, 2M1M2, 1T1, M1M2, 2M1M2, 1T1. Then we have 1M3, M4, M5, 1M3, 1M4, 1M5. That's fine, right? So it's working. Again, microtask is empty. We pick up a single task again and again and execute it in a single, in individual event loop cycles. That is 1T2 is another cycle, 1T3 is another cycle, 2T1 is another cycle, right? And then in another cycle, we're going to be executing this whole block, which is going to place 2M3 in the microtask, 2M4 in the microtask, and 2M5 in the microtask, right? And we get rid of this whole block. So at this point, again, microtask is not empty. So it's going to, JavaScript is going to exhaust that first. 2M3, 2M4, 2M5. And I just placed that 2M3 as well. So I'm going to remove that. And finally, nice and easy, our 2T2 is placed and 2T3 is placed, right? And there we have it. That is our output. Let's just compare it really quick. 1 hello, 2 hello, 1 hello, 2 hello, right? Then we have 1M1, 1M2, 2M1, 2M2, 1M1, 1M2, 2M1, 2M2, that's fine, right? Then we have 1T1, M3, M4, M5, 1T1, 1M3, 1M4, 1M5, that is again correct. 1T2, T3, T1, 1T2, 1T3, T3, 2T1, 1T2, 1T3, 2T1, yeah, that's right. Then 2M3, we have 2T1, 2M3, there we have it, right? Then M4, M5, T2, T3, M4, M5, T2, T3, absolutely correct, right? So we have calculated the expected output in a correct way. I hope this actually cleared a lot of doubts about you, about your event loop knowledge as well. There are just a little bunch of things you need to remember for the most part. Number one thing is that microtask queues and task queues are never executed as long as there is something in the call stack. Number two, microtask is executed before task queue and is executed to death. That means it would keep on executing unless the whole microtask queue is empty. And number three, task queue executes only one task in a single iteration of the event loop, right? So it's only going to pick up one task in a single whole iteration, but microtask queue on the other hand would completely execute the whole queue as soon as it finds that. So yeah, I mean, that's pretty much it. I hope this is useful to you. That's basically the highest advanced JavaScript knowledge you can get, theoretical, in terms of event loop, because you now have a very good picture of how event loop works, how the execution order works, and hopefully you would be able to debug some of the nastiest bugs you might ever see in your life with JavaScript. Right now, not really all bugs, but just where the execution order is critical and you're not able to figure out how the execution is really working in a single threaded JavaScript. So this kind of makes it very interesting. So that's all for this video. I hope you liked it. If you did, I'm gonna see you in the next one really quick.